Hey everyone, my name is Brian, and we're going to learn Python 3. This video series is aimed at the complete beginner, so if you have zero programming experience, this is what you need to watch. Now, we're going to start off in this specific video with how to install, configure, and test Python 3. And I'm going to try to make a video a week, so definitely check back often as I'm going to update this series as fast as I can. Let's dive in. Okay, the first step is very simple. Check to see if Python's already installed. Now, you can and probably should use your operating system's documentation to figure out if it's installed, but a very quick way is simply bring open a command line. If you don't know how to open a command line, I highly suggest you go out to Google and learn how to open a command line. It's not super hard. And once you get to this point, type in something like this, Python 3. If you see this right here where it says Python and then some version, it's already installed and ready to go, and you can simply skip the next step. However, if you don't see this, if you get like command not found or unknown command, then you're going to have to follow the next step and actually install Python. Special note, a lot of documentation out there will say type the word Python. This is the older version of Python. This is Python 2. See, right here, ta-da, Python 2. We're going to be working with Python 3. Okay, assuming you ran a command line and tried Python 3 and got a big fat command not found or command unknown, you need to install it. Go out to python.org and then go to downloads. From here, you can either click all release or you can go into your specific operating system. We're going to go to all releases. It will try to auto detect what you're doing. However, you may need to pick your operating system. The vast majority of you are probably going to be on Windows, so I'm just going to click on Windows. Then click on Python 3 release, the latest one. Notice this is a Python 3, not a Python 2. And scroll all the way down. They've kind of got these jumbled up together. You notice how you've got, you guessed it, a tarball, something for Mac, and then stuff for Windows. Windows has the vast majority of the options, and this is why it gets a little bit confusing. Honestly, I'd go with this one, Windows x86-64 executable installer. That's going to be an offline installer. It's going to have everything you need to run, or at least it should. You're going to download that executable and run it. You may be prompted to run as an administrator, and you may have to restart your computer when you're done. After you're done installing, you will definitely need to go back and double check. You should be able to open a command line and type Python 3. If you cannot get to this step, you may have to go to Google and look for your specific error message to figure out what's going on. Now that Python's installed and configured and we can bring up a command line and type Python 3, we need to test this thing out, make sure it's actually working the way we expect it to. First things first, I'm just going to drag this up like this to take up the rest of the screen, and we're in what's called the interactive shell or interactive mode. We are not going to be using this very much because, well, it's a bit cumbersome. If you make a spelling mistake, it's impossible to go back and fix it. So we're going to use an IDE, but right now we're just testing. I want you to do something like this. Say, x equals 5 times 3. Now we're going to type the word print, and then let's say x. Notice that's in brackets. We're going to cover all this later. Right now, we're just simply testing. You should see 15 on the screen. To be brutally honest, typing Python 3 and even seeing the version is really the true test that this is working. However, I wanted to show you there is an interactive mode if you want it. Again, though, it's really hard to go back and edit, configure, and you're going to make mistakes. So we're not going to use this at all. We're going to use an IDE, or an integrated development environment, which we're going to cover in the next step. When talking about integrated development environments, well, there are tons and tons of them. If you just go out to Google and type Python IDE, you're going to get, well, millions and millions of results because there's just literally thousands upon thousands of IDEs. To be brutally honest, you don't need anything fancy. You can use a simple text editor. Really what an IDE is a very fancy text editor with a lot of functionality built on top of it. You'll probably find a lot of documentation that says idle comes directly with Python. That's not really true anymore. You got to install it a little bit separately. And personally, I don't like it. I don't think it's the greatest. PyCharm is another good one. but we're going to be using something called Visual Studio Code. And I know a lot of folks really are not Microsoft fans. You're not forced to use this. It's what I'm going to use for this series. And without warning, I may change IDEs halfway through, just depending on what I feel like coding in, because Python makes it super easy to do that. The reason why I'm using Visual Studio Code is, well, it's very simple. It's very straightforward, and this is what it looks like. So all I'm going to do here is I'm going to just add a folder. I'm going to go into Python 3, close this out. Now I need to add in some extensions. And this is what I love about Visual Studio Code is you can extend this to work with just about any language. So I'm going to say Python. And you see there are tons, and I mean a lot. I could just scroll down forever and ever to like infinity and beyond, kind of forever. I mean, there's tons of extensions, but it does a good job of putting the best ones right at the top. You can see this guy right here from Microsoft, 26 million views, 5-star rating. You just simply go, okay, do you actually need it? That's a good question, because you could go through and spend hours just installing all of these and not know what you really need. So we're going to take a short detour, go back here. This is simply the folder we opened. I'm going to say new file, and let's call this test.py. And it automatically recommends extensions for us. A Python file will end in .py. So it's detecting that extension and saying, hey, do you want to use the recommended extensions? I'm going to say, you know what? Why not? And it's going to automatically go out there and install them. And then it's going to say installed, and it's used globally. There we go. And we can even click this little gear icon and play around with it if we really felt like. Let's go back to our file, or we can use it up here. Depends on how you want to get there. Now, this is my only real criticism of Visual Studio Code is it does tend to clutter the UI a little bit. So occasionally you'll see me closing things out. And I'm just going to, well, start using this bad boy. Okay, to wrap this video up, we're going to make what's called Hello World. This is kind of the obligatory first application you're going to make in any programming language. It's actually a rite of passage for programmers. And it is very simple. It's just printing out the words Hello World on the screen. And this is where we're going to hit some stumbling blocks if we're not fully configured. So what you should see before you is everything we've done so far. You should have your IDE, whatever you're using, even if it's just a simple text editor. And you should have a blank file called test.py. The name's not super important. And last but not least, you should see the Python interpreter. I have Python 3.6.9. You can actually switch to different ones if you wanted to. Just be aware that you can use different versions. I'm going to type the word print. And then we're going to give it some brackets. Anything in the brackets, it's going to try to print. Now with Python, you can use double quotes or single quotes. I have a habit of using double quotes, but it really doesn't matter which one you choose. And then type the words hello and world. Click save. Now you should have this little guy right here that says run Python file in a terminal. If not, you can go up here. You're going to have a few options. Start debugging and run without debugging. Immediately, if you're a newbie, you have no idea what this means. Debugging sounds really, really bad. So what does this really mean? Debugging is a special mode in programming where if you have bugs or errors in your code, it will walk you through them and help you fix them, or more to the point them out to you so that you can fix them. Often I'll run without debugging because it is a little bit faster. And you should see something like this on the screen. Hello world. All of this stuff looks really nasty, but really what's going on here is you have your installation path for Python 3, and then, you guessed it, everything that it's doing in the background. It's calling this launcher, and it's saying run this script. The end result is this. Now, because I'm not a huge fan of Hello World, because it's so overly simple, let's actually get rid of that. And we want to go back to what we did in the interactive shell, where we're going to say x equals 5 times 3. What we're doing is we're making a variable. And we're going to talk about variables in the next video, but what we want to do now is just simply print this out. Save this, and I'm going to go ahead and run. And you see, there's 15 right there. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back. My name is Brian. We're going to continue our conversation about Python 3. Whatever IDE you're using, go ahead and make a new file and give it some type of name. I'm just going to name it Playground. Not really important what you name it. You just need some sort of file you can play around in. Remember, these videos assume you have no experience. So we're literally starting with a blank slate. The first thing you're going to learn is what is a variable. I'm going to write this out here. Well, a variable is simply something that will change. For example, if I declare a variable named x, I have to assign this some sort of value. Let's go ahead and try and print x out and see what happens here. Notice it's going to have some sort of error. It's going to say name error. Name x is not defined. What does that mean? Well, clearly we defined it. It's right here. Really what Python's trying to tell you is that it doesn't really have any sort of value. So I'm going to say 42. Now let's go ahead and rerun this. Notice how suddenly it says 42. So if you get a is not defined, really what you're saying is you have not set that value. You notice how this is a number, and this is what I mean by a variable is something that will change. I could have very easily said cats. Notice how cats is a string. A string is just a series of characters, but it's not a number is the point I'm driving home here. And if we run this, it works just fine. So under the hood, what you have going on here is Python knows, it's smart enough to know what type of information we're storing in this variable, and we can change it at a moment's notice. So, for example, we have x equals cats, and let's just grab this, good old copy and paste action, and we'll say x equals, I need some sort of number, why not? And the IDE is not happy with me. It's saying invalid token. I'm just going to get rid of that 0. Maybe that'll clear it out. Nope, will not. Let's go ahead. Oh, there it goes. Let's run this. You notice how it says cats, and then it's got a number. So we can take this same variable and change it. And Python is smart enough under the hood to know that x is a string and x is an integer. So what we're really diving into, and we're going to spend a lot of time talking about this, is data types. And when I say a lot of time, I'm going to have to break this into multiple videos because each data type, whether it's a string or a number, like an integer here, has different properties that you can access. So the short answer to what is a variable is just simply that it's something that will change. That's it. It's that simple. A lot of instructors are going to take like months and months and months to explain what a variable is and how it lives in memory and blah, blah, blah. But as a programmer, we don't care about any of that. We just want it to work. And this is computer programming 101. You declare some type of variable, you set the value, and that value has some sort of type. And with that type, you can now work with it. Interesting note here, if you're coming from another language or if you know a little bit about programming, Python, you do not have to declare the data type. For example, in other languages, you may have to say something like int x equals 3. So what we're really doing here is we're stating or telling the interpreter, this is the data type we're going to work with. We don't have to do that in Python. It's smart enough to figure it out on its own. Okay, let's take a little detour down to theory land. Now, what we're going to talk about is dynamic and strong typed. Python is both, and this is often confusing for people, especially coming from other languages. As you saw, we don't have to declare the data type. Python's smart enough to know. In other languages, you do have to declare, and that gets super confusing to people. So, we're often asked this question: why is Python a dynamic language and also a strongly typed language? And what do those two things really mean? Dynamic means just that, it's dynamic. You don't have to declare a variable type, and you can change that at a moment's notice, as you saw right here. We went from a string to a variable, and it's smart enough to keep track of everything for us, and no errors were thrown. Other languages, you're going to get a huge error because we're saying once you declare this as a data type, it can never be anything different. That gets kind of convoluted. Best answer here is Python is a strongly typed language, as the interpreter keeps track of all variable types, meaning the interpreter, Python itself, is smart enough to know what you want it to do, but it is also guaranteeing under the hood that once you assign it, it's going to stay that variable type until you overwrite it or change it. Remember, a variable is something that will change. And with Python, that's very true because you can change it to a completely different data type. A lot of other languages, you simply can't do that. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everybody. This is Brian. We're going to continue our journey with Python 3. Whatever IDE you're using, create a blank file. I've got mine named Python 3-3. At this point, the name's not important. Just have a blank file ready to go. We're going to cover three key things: comments, booleans, and comparisons. Let's dive right in. Okay, comments. You've actually seen them, but we haven't really talked about them. What is a comment? Without writing any code, go ahead and run your script. You see, it does absolutely nothing. We're going to hit the pound sign and just type something. This is a comment. So really, what does this do? Well, if we run our program, you'll see nothing's changed. It does absolutely nothing. A comment is just that. It's a comment on the code. It exists solely for you, the programmer, so you can keep some sort of notes. So for example, you can say, this is our third video. And you notice how you can add in letters, numbers, whatever you want, and it's not going to throw any sort of error message when we run it. This is strictly for you. This is your note. Now, if you're coming from another programming language, you're probably hoping there's a multi-line comment, meaning if you have a few lines, like, hello world, I like cats. You notice how as I was typing, it tried to help me out, and it put what we call IntelliSense in there, which is code that's already pre-written for us. Well, we really didn't want that, so it just caused all sorts of errors. Now, if I were typing in a comment, I'd say, hello world, I like, and you notice how IntelliSense suddenly is not really popping up. I can force it pop up by hitting Control and space, but it doesn't really know what we're doing because we're in a comment. Multi-line comment would be like if you had, and I'm just going to grab some text here. This is not a comment, even though it says it is a comment, it's really not. If we try to run it, you see invalid syntax, because it's trying to interpret this as code. Now, we can put a pound sign in front of each one of these. For example, let's just go this one, and this one, and it's going to get really dull if you got like 100 lines you need to do. So what a lot of Python developers will do is this. They'll just have triple quotes, and anything inside the triple quotes becomes a string. String's something we're going to really talk about in depth in another video. Just know that this is a data type. So we're not truly making a comment. We're making a string, but the string does absolutely nothing. So if we run that again, there's no error message. And let's clear that nasty error out just so you can see. You can run this all day long and there's no error message. But we have created a variable, believe it or not. So I do not favor this, and be a little careful. This might cause issues later, especially if you get into like doc strings and things like that, which we're going to cover later on in this series. So you may be asking, what is the functional purpose of a comment? Well, it exists solely for you, the developer, as a note. You can also enable and disable code using a comment. So for example, let's just say x equals 1, print x. You can see it is now printing 1. We could change this to hello world, which we did in the previous video, and there's hello world. Now if we comment this out, this x technically no longer exists, and you see it's giving us a little red squiggly line. It's saying undefined variable, and if we try to run this, you guessed it, boom, name x undefined. So we can disable this code by commenting it out. We can re-enable it by simply deleting that pound sign. So let's cover our first real data type here, and this is very fundamental. It's called a Boolean. Some people just call it a bool for short, and it is a true or a false. Think of it like a light switch, like physically look at the light switch in your room. It's either on or off, and that's really what this data type signifies. So let's make a few. I'm going to actually comment out this code. And let's make some. I'm going to say x equals true. Notice how it has a capital T, and IntelliSense is trying to help us out by saying, hey, it must be capital. And y equals false. Again, capital F. You may be tempted, if you're especially coming from another language, to give it a data type like this. If you do that, bad things are going to happen. It's not going to know what you're trying to do. We can actually try to run this, and you'll see what I mean. Oop, invalid syntax. So it's not understanding what's going on. When we get rid of that, suddenly, magically, it works. Clear that error out so it doesn't confuse anybody. Ta-da! Again, these are case sensitive, so if I change that to a lowercase, you see how IntelliSense no longer has that as blue, and we're going to get a nasty little issue if we try to run this. Name true is not defined. Remember, when you see is not defined, that's the interpreter's way of saying, hey, I have no idea what you're trying to do here. Simply because it does not exist. So let's switch this back to a capital T, and life is good. So I'm going to just copy and paste some notes in here. Notice how you can put a comment on its own line or after. If you put it before, for example, if I move this right here, it turns everything after it on that line into a comment. So be very careful doing that. And these comments have absolutely zero impact on our code. For example, we can run this all day. There are no error messages. Then clear this out. Now that we have that, understand that we want to do some fundamental comparisons, which is what we're going to talk about next. Okay, let's talk about comparisons. First off, what is a comparison? Well, it's a building block towards programming logic. So comparison is the building block of logic, meaning we want some value, take that value and compare it to another value to see what we need to do with the programming logic here. For example, I'm just going to print out x and y. I'm going to do this a little bit differently. I'm going to put the letter F, which stands for formatting, and I'm going to say x equals brackets and then x. Looks a little confusing, but really all we're doing is saying print out x, but do it in a fancy manner. See? XX. Now I can change this to y, and it becomes very simple to understand what's going on. X is true, y is false. We're going to compare these two now. So the very first comparison we're going to do is equal. And it's actually pretty straightforward. So I'm just going to grab this. And let's say, equal. We're going to do our logic here. And we're going to say, you have to be a little careful when you're doing equals, because if you just do this, you're actually assigning. These are called operators. This is the assignment operator. We're now saying x equals y. We don't want to do that. We want to compare it. So we're going to say x is equal to y. We're simply comparing. Then let's say the opposite of that. I want the not equal. Notice it's an exclamation. Whenever you see the exclamation, think exact opposite of what you want. So we want, is this the opposite of equal or not equal? Let's go ahead and run this, see what happens here. You can see x is true, y is false. They are not equal to each other. And it is giving us a true when we test for inequality. It's actually pretty cool that we can do that. We know virtually nothing about programming at this point in this series, but we already have the foundations of computer logic, true and false, and we can test for those conditions. Let's take this a step further here. And what we're going to do is greater than and greater than or equal to. So I'm going to just grab one of these. And I'm going to say greater than. Very, very simple. We're going to say print out is x greater than y. Now I want to say greater than or equal to. Very similar syntax to the not equals to. We're saying greater than equal to. And let's do the exact opposite. Let's say less than. And let's flip these around. Let's go ahead and run this. And you can see, there we go. Greater than, true. Greater than or equal, true. Less than, false. Less than or equal, false. These admittedly won't make a lot of sense to you right now until we start talking about the numbers, which we're going to talk about in the next video. But for bools, know that equal and not equal are great, and these are the building blocks of logic. We can start doing flow control now, which would be things like if-then. For example, if you're hungry, go eat. Otherwise, go do something else. We're going to talk about all this in future videos, but really nail down the fundamentals here. What we're really talked about is comments. They are your buddies, they're your friends. Be kind of careful how you do those comments. And booleans. These are simply on or off, true or false. Remember, these have to be case sensitive. And we've covered some foundational comparisons. For example, we're saying equality, inequality, greater than or equal to, less than, and less than or equal to. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Hello again, everyone. This is Brian. We're going to continue our journey into Python 3. This video, we're going to cover numbers, the number data type, specifically the int, the float, and the complex data types. And we're going to cover some basic numerical operations, for example, addition, subtraction, things like that. Whatever IDE you're using, go ahead and make a blank file. I've got mine titled python3-4.py. The name's not important at this point. You just need a blank file to start with. Last video, we talked about the bool. This video, we're going to talk about numbers. I know everybody loves numbers. So let's go ahead and start off with the integer type. And we're going to make a simple variable here. And I'm going to call this ival. And let's give it a value of 34. It really doesn't matter what value we give it, though. Say print, and we're just going to print something out here. So there we go. And let's call this ival equals, and we just want to print that value out just to see what this looks like. Save run. This is pretty basic. You pretty much guess what it's going to do. It's going to say the ival equals 34. Very, very simple. Not super hard to wrap your head around. Now we're going to take this, do the magic of copy and paste here, and we're going to make a float. Float sounds really good right about now, like a root beer float or something like that. But we're talking about numbers, not root beer floats, unfortunately. So we're going to make a floating point value, and it's going to be 3.14. Save run. On the surface, what we're doing looks very rudimentary, but under the hood, Python's doing all of this work for us. We don't have to worry about what's actually going on. So, for example, there's a fundamental difference between an integer and a floating point number. There's a lot of precision that happens in the background, and we don't have to even think about that. Python takes care of it for us. I'm going to import the sys module. And what this is going to do is allow us to work with other people's code. And we're going to talk about that in depth in another video, but just right now, take a huge leap of faith that we're using someone else's code. This is actually part of Python, but we have to import it. It's a little confusing. Again, we'll talk about it in depth in another video. Usually it's at the top of the file. We're just going to put it right here. But we want to be able to get some extra information. So I'm going to say sys.floatinfo. And let's go ahead and copy and paste some notes in here just so we can see what's going on. I'm going to grab this and voila, put that right there. That is the official Python documents. If you wanted to go out and look at it and see exactly what's going on, we can run it and see under the hood. This is what Python's really keeping track of when it talks about floats. So we have the system float info. You have a max, which is a really, really, really large number. And you can also have a max exp, and you can dive into all this stuff. Now, if you're into numbers and math, you probably know what all this is, but us mere mortals usually don't care. Basically, if you have a number that has a decimal point, you're going to use a float. Otherwise, you'll use an int. Now, we're going to talk about another one, and it's called complex, and it is, well, complex. Now, when I say complex, actually, Python makes it super simple to work with, but the data type itself under the hood, you guessed it, is not super simple. It is complex, and it looks something like this. A complex number is made up of two numbers, a real number and an imaginary number. Kind of sounds a little messed up, but let's take a look. So we're going to say cval equals, and let's say 3 plus 6j, giant leap of faith that I know what I'm doing there. What is that really going to do? Well, it's going to make that complex number. And let's grab the name here, cval, and let's print it out. Doesn't really look like we did a whole lot. It's just saying cval equals 3 plus 6j, exactly what I typed. Let's split this apart here. What we're going to do is show an alternate way of creating a complex value. And you can do this with float int, but it really drives the point home with complex. So I'm going to say complex. And notice how it wants the float and the image. Let's go ahead and give them both. So I'm going to say 5.3. And let's go ahead and I'm going to just, through the magic copy and paste here, grab this. Let's say cval is that. Now I want to print out the real. And we want to go ahead and grab this, copy, paste, and we want the second part of that number just so we can see what it is. Go ahead and save and run. So now you can see the complex number is made up of two parts, and that actually would probably be better if I made it the way it was supposed to be. There we go. Real and imaginary. Two different parts. That's what makes that a complex number. So the fundamental point we're driving home here is that numbers are very fundamental and simple data types, but they can get very complex very quickly. Python strips a lot of that complexity out. If you're coming from Python 2 or another language, you're going to note this seems overly simplistic, and it is by design. Python 3 pretty much revamped the number system and did away with a lot of the old headaches, so it's super simple. General rule of thumb, no decimal point, use an int. Decimal point, use a float. If you need something else, use complex. And there are others that we will cover in future videos, but this should get us going for now. Okay, let's talk about basic numerical operations. Now, don't worry, we're not going to get super complex. We're talking basics. Python can do some really complex stuff. For example, you can do calc, trig, advanced algebra, pretty much any type of math you can imagine. Python's actually used in scientific computations, and it can do things like artificial intelligence. We are starting at the basics, so we need to talk about the basics. I'm going to say x equals 3, which is an integer. Now, I'm going to print this out, and I'm going to just grab the old print function here, save us just a smidge of time. Nothing super fancy about that, but what we're going to do now is we're going to make another variable. Let's call it y, and we're going to say y is equal to x plus 3. So what have we really done here? We've done basic addition. Let's go ahead and grab this. And let's call this add, and this is going to be y. And that's going to be our fundamental pattern here, where we're going to do something, and then we're going to just display the results. And I'm going to say add. That way we know what we're doing. Save and run, and sure enough, add is equal to 6, because x is 3, and we're adding 3. 3 plus 3 is 6. Again, fundamentals. Now, we're going to start speeding this up because I think you're probably smart enough to understand basic math, and we're just going to grab this and, you guessed it, start plowing through this. So if we can add, we can also subtract. Let's go ahead and say we want to minus 1. Run, and you can see 3 minus 1 is actually 2, so that works exactly the way you would expect it to. Let's go ahead and multiply. And we're going to say, this is something you really can't do very easily in other languages. Python makes it just beautifully simple. So we're going to say 6.846. Doesn't really matter what number we do, just as long as we have that. Now, if you look, x is an int. But what are we doing? We're multiplying it by a float. So what's going to happen under the hood here is Python's going to determine what the end value type actually is. Is it going to become an integer, or is it going to be a float? You notice how it's not really telling us when we hover over IntelliSense. And that's because the interpreter hasn't done the work yet, so it simply doesn't know. So let's call this multiply, and ta-da, the end result is 20.538. So that is a floating point number. Now we're going to do some division. Let's grab this. And we want to say x is going to be divided by 0.5. Again, it's doing all of that hard number crunching in the background. What it's actually doing is called casting. And when you think of casting, think of like a wizard waving a magic wand, converting something from one data type to another. That is happening automatically for us. We don't have to think about it. Now, it's not always going to happen automatically for us, but in this specific case it is, and it's super, super convenient. Don't worry, we're going to talk about casting in depth in another video. Right now, we're still at the fundamentals. And let's play around a little bit. We're going to make a power of, so we're going to say that is the power. So 3 to the power of 2 is 9, and one more just to play around here. Let's do the remainder. I think this is called the modulus operator. And we're going to get this. If you don't know what this is kind of like the opposite. I shouldn't say the opposite. It's kind of like taking division and getting the remainder of what's out of that value. It's kind of weird. So let's take a look here. So 0.5. So what we're doing here is we're starting with x is 3, and we're getting the remainder of 2.5, which is actually 0.5. Very simple, very easy to use. So the fundamental concept we're trying to drive home here is there are some number data types, int, float, and complex, and you can do some basic numerical operations. Python makes those numerical operations very simple because it handles all the complexity under the hood for us, and we don't even have to think about it. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian, and we're going to talk about strings. So what is a string? That's a very good question. We have before you a simple diagram. The word hello, H-E-L-L-O. And there's some numbers here and some numbers here. And we're going to explain all this. So really, a string is a list of, you guessed it, characters. And each character translates to a numerical value. So if you look down at your keyboard and look at like the letter H, that letter, depending on whether the shift key is pressed, will be 104. Now when I say depending, because there's a numerical difference between lowercase and uppercase, we're talking about lowercase here. Some people will say, oh, that's ASCII. I've heard about this before. This is actually not ASCII, it's Unicode. Specifically UTF-8, I think it's Universal Text Format, 8-bit or version 8, I forget. But basically, Python under the hood sees this as UTF-8. So it doesn't matter if you're typing in English or Korean or Spanish or ancient Greek or some mathematical algorithm, there is a number assigned to each letter. The computer knows what that is and takes care of all of this for you, so you don't have to worry about it. The 2 major things you should focus on is, well, the letters themselves that form the string, and this down here, which is the position. Everything is in a list, so when you look at it, H-E-L-L-O, there are 5 letters there, and there are 5 numbers, starting with 0. This is a 0-based index, 0, 1, 2, 3, 4. So if I say, give me the letter at the 3rd position, H-E-L, this guy, that is actually number 2 because it's 0-based. Gets a little confusing if you're new, but you're going to go, no, wait a minute, that's actually number 3. Remember, it starts with 0, so the first one's always 0. We're thinking in terms of computers. 0, 1, 2 is this guy right here. Once you wrap your head around that, you know more than most people walking around. And honestly, it's not super hard. You just have to understand that everything you see on the screen has some sort of number attached to it. And the computer handles that number. You just need to worry about what letter and what position. And we're going to go into that. Okay, let's flip over into Visual Studio Code here. And we're just going to copy and paste some code here. And this is going to look like absolutely nothing you've seen before. Don't worry about it. just taking a leap of faith. We're going to cover this in a future video, but really what we're doing is we're saying for x, each letter in the string hello, we're going to print out the letter and its numerical value. And you can see 104, 101, 108, 108, 111. Burn those into memory. 104, 101, 108, 108, 111. If we flip back, it's exactly what I told you it was going to be. So let's dive in here and figure out what's going on. Now, again, we are going to cover loops in a future video. That's not this video. We are hyper-focused on strings. So the first thing we need to do is baby steps. How to make a string. Very, very simple. Simply make a variable and assign it. And let's do that again. Notice how the first name, or the first variable, has double quotes, where the last name, or the second variable, has single quotes. In Python, you can do it either way. And they do this not so much to confuse you, but simply because there are a bunch of little gotchas that you're going to find later on in your life as a programmer. And this is super convenient that you can switch it around however you want. So the first thing you're going to want to try is just simply to, well, merge them into one larger string or print them out. So we're going to print, I'm going to say first plus and last. Now, what do you think is going to happen here? You notice how we're using the plus sign. If you're a math nerd, you're going to say, oh, this is going to kick out some weird number. Actually, no, it's going to say, you guessed it, it's going to, I think the term is called concatenate them. It's going to merge them together into one string in memory. So it's saying the first, Brian, with a space, and last, Karen's. Very, very simple. You can also do something called formatting, which we've done before, and it really does help you avoid errors in the long term. So you can say something like this, printf, and notice how I've got quotes. Doesn't matter if you're doing single or double. And I'm going to say, hello, my name is, and then, let's see here, there we go. I had to look at my keyboard to figure out where that was, and then we just type the variable name. First, and then last. Now, we tend to use formatting to avoid issues. You've seen me do it already, but you probably haven't really realized why. And we're going to cover that a little bit here. So, hello, my name is Brian Cairns. To kind of compound that in your mind, let's make a variable called hers, and we're going to say Heathers. Notice how I'm mixing and matching these. I'm using double quotes, so Python knows, hey, this is the string. But we could also use single quotes, so that gets super confusing. What it's going to do is take the first one it sees and says, oh, you're using double quotes to make this string. So if I were to change this to a single quote, notice how this letter suddenly turned white. Even if I end it in a single quote, it's going to get really, really annoyed with me. See? Boop. Syntax error, invalid syntax. If you ever see a syntax error, really what Python's telling you is you screwed something up, and it'll tell you exactly where. In this file on line 11, and hers, and then there's a little arrow right here under S. It doesn't know what to do with this because it is not in the string. Change that, you put the double quote there, and it magically fixes it. See? Doesn't make a whole lot of sense, so let's change that back. But this is why you can mix and match these. It makes it super, super simple. And we can just print that out, and it works as expected. There's our little single quote right there, and we don't have to worry about any special encoding or formatting or anything like that. Okay, so to solidify this, under the hood, a string is a Unicode series of characters, specifically formatted in UTF-8. If you want something other than UTF-8, you're going to have to go out and Google how to do that. I'm just saying we haven't covered it yet. We may cover it in the future, but if you need something immediately, definitely go out to Google. A string is a sequence of one or more characters, and those characters are numerical values, and that's what we're really going to drive home right now. So let's make a variable. Let's call this S1. And we want this to be a character. Notice how it's looking for an integer. Return a Unicode string of one character with ordinal, and then it gives you some examples there. And I'm going to say, because I have this baked into memory, 72. And then we're going to make another one. And this is character, and we're going to say 105. Now, you don't see it, but I'm sitting here cheating a little bit. I'm looking at the UTF specifications and the character tables, which you can see definitely by visiting these links and other links, and it will give you the numeric values. Now, this is if you wanted to do something like this. You really don't need to. I'm just demonstrating it can be done. So we're going to say S1 plus S2, and let's kick that out, and it spells the word high. Notice it's a capital H, lowercase I, 72. Now, lowercase h is 104, uppercase H is 72. This is what I mean by there's a fundamental difference between upper and lower. Now, you may be inclined to say, now, what about bold and italic? No, that's actually not part of it. Those are not letters. Those are just simply styling and formatting of what you see on the screen. So really all we're talking about is upper and lower case. It actually goes way, way beyond that. You can do something like this. To say print, and I'm going to say character, and I really have to cheat and look at my notes for this one. 8710, and this goes way beyond ASCII. Let's go ahead and save and run and see what this looks like. Boom, it's this little mathematical symbol right there. That's right, it's got math symbols baked right into it. You can do some really cool things with just simple characters. You may have heard the term escape characters. Now, what is an escape character? It's not something out of a novel, although it could be. But basically, instead of memorizing all these weird numbers, they have it built right into the language, and actually most languages, and even operating systems, and they're called escape characters. What it means is you can escape a string and print a special character. And let's take a look at how this works here. So I'm going to say print, and we're going to even format this just to show you how this works. I'm going to say hello, and then world. And notice I've got that kind of jumbled together. Now, you can do something like this. You can say, okay, I looked it up, and it's, character 13 for a hard return, plus I want to do like a character 10 for a line feed, and that will put this on 2 different lines. And I had to go out and look up these numbers because I didn't memorize them, but it does work. Hello world. Or you can just simply do something like this. And we're going to grab it, get rid of all that nonsense, /R for return, /N for line feed, save, run, and it does the exact same thing. So under the hood, this little guy here, /R, notice an escape character starts with a backslash here. We're saying /R for return or N for new line. Does the exact same thing. You'll see that out in the real world both ways, where some programmers will demand you use the character and some programmers will demand you use the escape character. It gets a little confusing until you get used to it, but it's super simple, and you can do things like this. And really all we're going to do is we're going to print out hello world with a tab between them, /T for tab. When in doubt, you can go up to Google and you can type out what is an escape character, and it will give you a complete list of them. There's tons and tons of them, but they're very simple and easy to work with. Here's hello world with a tab in between. You may be wondering, why even use escape characters? I mean, it seems a little rudimentary. Now, let's go back, way back, to this problem. We want to put that in there, and it works fine if we do it in double quotes, but the minute we change it to single quotes, remember, we're going to have some sort of issue. It's not going to know to do with X, and it's going to say, you guessed it, invalid syntax. Well, instead of going through and rechanging all our strings, we can just simply put a / in front of it, and most of the time that will work. It'll escape it right out. Go ahead and save to clear that error out. Let's actually clear this out just to show you it will work. No more syntax error, and we can print this bad boy out. So escaping actually becomes a very convenient way of, well, breaking out of the constraint of which quote you should use. I know I'm going to get that question constantly of, should I use single or double? And really, it does not matter. Just pick one and roll with it. And if you need to switch them around, you can always escape out of them. It's not super hard. You can also do things like this. And this is something I get a lot of questions about, not just with Python, but pretty much every language. So I'm going to say quote equal. You see what we're doing here? You can have multiple escapes. It doesn't really matter. Basically, what we're saying here is once you do this slash, the computer will try to figure out what you're doing and it will roll with it. If it can't figure it out, it will give you an error message, at which point you're going to have to probably do something like this. Or you're simply using the wrong escape character. And when in doubt, go Google it. It's usually pretty easy to work with here. So we're going to go print. Then he said, quote unquote, hello to me. Now you may be wondering, what's the deal with formatting? When you read books or watch videos on Python, they go really in depth into formatting and why it's important. Really, you format to avoid errors, especially with strings. And let me give you a very simple demonstration here. Say, name is Brian, age is 46, and boy, I feel 46 today. I was raking leaves all day yesterday, so wow, yeah, that sucks. All right, so we're going to print these out. I'm going to say name plus, and we want the age. Oh, this will work, and it'll work beautifully, right? Well, guess what? No, it does not. There's a reason for it. It's not very intelligent when you first look at it. So we're going to say line 36 in this module, print, and it doesn't put the little arrow, but it does tell us must be str, not int. So what it's really talking about is this thing. What you're trying to do is take all of this and treat it like a giant number and then add these together. We're trying to do basic numerical operations, which we already covered. And Python's not going to let us do that. So let's get that out. And let's just put a note here. And let's show the correct way of getting around this. Now, there's a few different ways. We can do the way we've been doing, which is we just put an F in front of the string, and then we're saying we're now formatting it. Not very hard, we've done this before, but if you want a little bit more control, there are other ways of doing it. We're not going to dive into every single possible way. I'm just showing you the two that I use the most, and this is the next one. We're just going to print, and I want to say, let's do double quotes, why not? My name is, and here, what we're going to do is we're going to say we want %s. And what we're doing here is we're making our own special custom string with formatting baked right in. I am, and then I want a %i for integer. From here, though, now we need to do a % and tell it, hey, we're going to feed you some values. Those values are going to be name and age. Now, I typically don't like doing this because you have to read this whole thing, skip over to this %, and then look at this little guy here and figure out what we're sending it. Okay, so name is the first string. Okay, and then age is the first integer. All right, so let's run that, see what that looks like. And it says my name is Brian, I'm 46 years old. Let's play around with this. Let's put I and S just to see if we can easily break this. And sure enough, we've broken it with very minimal effort. Type error. So really, I tend to favor just the simple formatting because we don't have to mess around with any of this or worry about screwing this up. But if you need special formatting, it is super, super simple to put it right in there. When in doubt, Google is your friend, and there are honestly thousands and thousands of tutorials on how to really learn that in depth. We're not going to spend a lot of time on it though. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to continue our journey on Python 3, and we're going to continue with basic string operations. Now, when I said strings are complex data types, I was not joking, and there's no way we can cover everything in these little 2 videos, especially because we haven't even covered the fundamental logic of programming, so we have to stick with the basics for now. Don't worry, later on in this series, we are going to revisit some of the more advanced things we can do. But right now, you have to learn to crawl before you can walk. So let's start crawling. I'm going to say variable str is going to be hello world. This is a string. Very, very simple. And we're going to start off with here. So what we're going to do in this video is we're going to do things like getting the length of the string, repeating the string, replacing characters and things of that nature, and even slicing them and getting the specific indexes or positions within the string. Let's dive into the basic operations. So first things first, let's say we want to get the length. I'm going to say print. We're going to call it the len function, which is not limited to just strings, but it is super, super handy for strings. And we are going to, you guessed it, just print out a comment here. Get the length. When we run this, we can see this is 30 characters long. Now, you might be inclined to say, no, wait a minute, it's a zero-based index, so it's actually 29. No, it actually gets the length, not the position. That's fundamentally different, as you're going to see later on. So now that we've got the length, we can do other things as well. Well, let's say we want to repeat a string, and this is going to hurt your brain just a little bit here. We've talked about how you cannot do mathematical operations with a string. Remember, we were trying to add an integer and a string together. Well, you can do what's called string math, and this is what I mean by it's going to hurt your brain. We're going to say str times 3. Now, I know what you're thinking. You're thinking you're going to get some sort of weird thing because you're trying to multiply, but actually what you're telling Python to do is take the string and, you guessed it, multiply it by 3 and return a giant string. Let's demonstrate. Hello world, hello world, hello world. So it did exactly what we thought it would do here. Yes, the first time I did that, I kind of sat back in my chair and went, wait, what? Is that right? But it is actually a thing with Python. If you're coming from another language, you're probably sitting there just staring at your screen going, what witchcraft is this? But it's actually super handy if you need to repeat a string. Now let's go ahead and let's look at replacing. And if you're coming from another language, well, this is exactly what you think it is. It is just dead simple. So in Python, strings are a data type, but they're also a first-class object, meaning they have functions built right into them. We haven't really covered functions yet, but just know you can say your variable name dot and then call some code, and we're going to call the replace function. And what this is going to do, it's going to take the string and replace a section of it. So let's say I want to replace hello with hola. So if you're from Mexico or Spain or any Spanish-speaking country, that would be the correct way of saying hello is hola. I'm probably mispronouncing that, but you get the point. You can simply replace it. So hola world, this is a string. Makes it super simple to do that. You don't have to figure out where things are. You can also do something like split a string. So if you're coming, again, from another language, you've done this before, and I'm going to say str, I want to split. And notice how it's looking for a separator here. So let's go ahead and split this on that comma. If you're not coming from another language, you're like, wait, slow down. What is splitting? So we're going to take this string and turn it into 2 strings. And we're looking for a separator value, in this case, this comma right here. So it's going to say hello world, and then this is a string, and it's going to give us 2 strings back. Here we go. Hello world, and this is a string. Now you may be going, now wait a minute, there's commas here. Look at these little brackets. You got this end bracket, this beginning bracket. What it's done is it's created a data type we haven't talked about yet, but we will in the next few videos. And it's put 2 strings into that data type and then handed it to us. Very convenient way of saying, hey, split those up. As you go on programming, you're going to actually use that quite a bit. Now, let's say we want to know if this starts with something. So I'm going to say str, and I want to say starts with. Does it start with the letter H? I'm almost embarrassed to type that comment starts with because it's pretty self-explanatory what it's doing, but just in case, it's going to return a bool, and it's going to tell us, hey, yes, it does. If we switch this to like J, does it start with the J? False. Very simple, handy way of determining what's going on. We can, through the magic copy and paste, switch this to ends with. And let's say we want to make sure this ends with an exclamation. True, true. There we go. And let's go ahead and look at uppercase, lowercase, and capitalization. We're just going to say print. And we want upper. And it's going to give us hello world. This is a string all in uppercase. You notice how it's got these brackets here, and that's because it is a function. If we omit those, we're going to get a built-in upper of string object and then this number. You ever see something like this? Basically, what you're trying to do is call a function without these brackets, and you need those. If you're wondering what this number is, that's a location in memory. So an object is simply something that exists in memory, and that's its location. So admittedly, this message is not super helpful for beginners, but I just wanted to explain what that was. I'm going to round this out. Let's say lower, and I want to capitalize. So now we have all uppercase, all lowercase, and capitalized the way it should be. Let's take a look at slicing. And when I first heard this term, I actually had like this vision of whipping out a lightsaber and slicing something in half. And it's actually not far off from what we're talking about. We're talking about getting a substring. Now, when I say a substring, remember, this string is just a series of characters, and each one is at a position. So the 0 would be here, and then 1, and so on, and so on, and so on, and so on. So what we want to do is get a substring, or a slice. Think of it like you have a pie in front of you, and you're going to get a slice of pie. You're not taking the whole thing, just a part. So for example, I could say I want the word world, or I want just th out of the word this, or this specific space. Or I wanted to get everything in the end up to that point. You can do things like that very, very rapidly in Python. And this, if you're coming from another language, I'm going to tell you, is extremely cool once you wrap your head around it. So we're going to say print. And we're going to take our variable. Now we're going to put those brackets there. That indicates we're getting a slice. The format here is very simple. We want the start, a colon, and an end position. So the start position in this case, we're going to say the 0, or the starting position, and we're going to end in 5. And what this is going to do is it's going to get the first 5. This is a 0-based index. Let's print this out and see what happens here. 1, 2, 3, 4, 5. Hello is 5 letters. There we go. So it did exactly what we're trying to do here. Like I said, it looks a little confusing at first, but once you start wrapping your head around it, it's not super hard. Now I want to start at the 6th position, and I'm going to omit the ending. And what we're doing here is we're saying we want to get from the 6th position all the way to the end. So when you omit something, it automatically defaults to the beginning or the end, depending on which one you omit. So the 6th position would be, you guessed it, world all the way over here. Ta-da, works as expected. Let's go ahead and grab this, and let's try something a little bit different. We're going to start at -7. Now you may be going, wait, what? Negative? How can we have a -7? Well, when you have a negative, you actually start from the end. So because we're starting with a negative, it's going to start back here and count backwards. Actually pretty cool how that works. So let's run this. And the last 7 is string exclamation. Pretty cool. Try doing that with some other languages, and some are going to be very cool. Some are just going to completely infuriate you depending on the language. And now let's get a substring. We're going to say from 6 to 11. And we want to get 6 to 11 just for our notes here. See what that looks like. And it is the word world. Very cool, very simple, very easy. Now, if you're coming from another language, you're probably still stuck on this right here. Don't worry, whenever you see that negative symbol, just think you're starting from the end and working backwards. Now, slicing is cool and all, but it's not super helpful unless you can actually automate the way of getting the number, because no one wants to sit here and count things, right? So let's look at how to get the index or the position of something. What I'm going to do is I'm going to say L equals, and we're going to look for the comma. Now, if we look at our original string, we've got this comma right here, but we don't know the position it's at. So I'm going to hide that off the screen, and we just want to know, hey, we want to look for this. We're going to do it 2 different ways. We're going to say C equals str find. This is what I love about Python. It's very intuitive. Find does exactly what you think it would. It finds something. It's going to tell us what we're looking for is the L. It's going to tell us where it's at. Or if it doesn't find it, I'm going to say -1 if not found. Let's go ahead and say print. And I want to say find returned C. Let's run this, see what it does. So, whoops, actually misspelled find there. Easy fix. So find return C, so it is at the 11th position. We didn't have to sit here and go 1, 2, 3, 4, and we'd be here all day doing that. Instead, we want the computer to do the work for us. So we know that's at the 11th position. Now, if we change this to just something, let's just do a single T. You see find return -1. So in this case, when you see -1, you can say it's just simply not there. It's not going to return a 0 because remember 0 is the starting position. So find is really cool, but if you're coming from another language, you're probably looking for index of, which is something totally different. So I'm going to say I equal str index. We're going to give it the same thing, the L. And now we want to this, and we're going to say find return I. And let's see what this does. Now remember, we have this T in here. Where is T in here? It's, well, right there, but it's a lowercase, not an uppercase. So it should return a -1, or will it? Actually, no, it does not. Instead, it gives you what's called a value error, substring not found. This is a convenient way of saying, hey, that must exist or throw an error, something we're going to cover in future videos. Just know that find will not return an error and index will return an error. So most of the time you're going to want find, but if you're coming from another language, you think you want index and you really want find. Oh, super confusing sometimes. Will throw an error. Just want to make sure we put that in there just in case. And let's switch this back. And you can see they both return 11 because we're looking for that comma. Remember, index will throw an error, find will just simply return a -1. Wrapping this up, let's go ahead and say we want to create a new string from the substring. How do we do that? So we want to say x equals str, and we're going to slice that string. We're going to omit the starting position because we want to go from the beginning, and we only want to go to the position of this comma. If that seems super confusing, let's slow way down. So we have a string, and it says, hello world, comma, this is a string, exclamation. So we're looking for this guy right here, which we found at the 11th position. And we're saying, okay, so from the very start, hello world, actually just going to copy this whole thing right down here. Copy this, put it right here as a comment. There we go. So we're going to say, so from the very beginning, right here, all the way up to the position we find, we want to create a string and call it X. Now we want to take that and just simply print it out. Hello world. Super, super simple. So quick recap. Strings are first-class objects in Python. They are Unicode by default. They are UTF-8, although you can specify some other way of doing it. Google's your friend if you need to do that immediately. And you can do some really cool things like get the length, repeat it, replace it, split it, make sure it starts with, ends with, upper, lower, capitalization. You can slice it, dice it, do whatever you want to do, and you can search for or find things within the string. And if you need to throw an error if it doesn't exist, you can use index, which I do not recommend because it's not really a good idea to throw an error in your code most of the time, and you can create your own strings from substrings very simply, very easily. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian, and in this video, we're going to cover lists. A list is a complex data type. Compared to what we've been talking about, it's very complex. So far, we've covered bools, numbers, and strings, but the list is, well, vastly more complex, as we're about to see. So first off, what is a list? Well, it's an ordered list or collection of data. And what do I mean by that? Imagine we add an item. That item is going to be at position 0, meaning the first item you add is always 0. And as we add items, you guessed it, that index will increment. Let's go ahead and add an item here. So 0, 1, 2, and these items, they can be the same, they can be different, they can be something totally crazy, whatever we want to do. This is the beauty of Python. So the list doesn't have to be what's called typed, meaning you don't have to have the same data type. That's how a lot of lists work in a lot of different programming languages. You can intermix strings with numbers and custom data types. The main takeaway before we dive in here is that this is an ordered zero-based index, meaning it will be added in the order you add them, and the first item is always 0. From 0, it goes to 1 and 2, and so on and so on. Okay, let's go ahead and create a list. First thing you'll notice in our notes here is I have these square brackets right here. What that denotes is that it is a list. It's important that you remember that because we're going to talk about other data types that are very similar to a list, but they are different and they use a different style. So first things first, let's create our list. Remember the square brackets. I'm going to say x equals square brackets. And anything we put inside these square brackets becomes part of the list. For example, I'm going to say Brian, and we're going to add another item by pressing comma and then whatever we want to put in here. So we have 2 strings in there. Now, really hurt your brain if you're coming from another language, I'm going to add a number. That's right. This is not a typed list. You might be used to something like C++ where, well, you have to have a specific type. It can only have strings or only have numbers. Python is not like that at all. It makes it very flexible, very easy. So let's go ahead and put a note in here. We can mix data types. And let's go ahead and print this out. And I want to say list. Going to print our list out. Good old copy and paste. Let's put this down here. And let's get the length. So you can see right off the bat, our list is this right here, and it's inside those square brackets. Always remember, square brackets are lists, and we can have 2 strings and a number. We could add whatever we want, and there are 3 items in there. If you're coming from another language, this may actually hurt your brain because you're going to go, wait a minute, you can't have multiple types, but with Python you can. It makes it super convenient, super easy to create your own data structures on the fly. Let's make a special note here about indexing and positioning. So this really confuses a lot of people. We think like, well, humans. The first item is always 1. Well, computers don't think that way. The first item is always 0 because you're starting with nothing. So when we talk about lists, this is 0 based. Let's go ahead and let's grab our friend print here. And let's say we want 0. So to grab the first item in that list, simply say square brackets and the index. Now note, we are not creating a list. We're saying inside of that list, get that index. In this case, it's the 0 or the first item. I'm going to put that in all caps for you newbies out there. The first item is 0. Remember, humans think the first item is 1. Computers think the first item is 0 because you're starting with nothing. Now, if you watched the previous video on strings, and I hope you did, you understand what slicing is. But just in case you skipped it, a slice is a lot like making a slice of bread. You have a nice big loaf of bread in front of you, and you don't want the whole loaf. You just want a slice of it, or a slice of pie is probably a better example. So we're going to print this out and we're going to slice this. So I'm going to say I want X, and then we're going to, you guessed it. Now notice those are square brackets as well. We didn't cover this in the last video, but yes, when you see that square bracket, that means we want a piece of this list, or in this case, a slice of it. I'm just going to put some quotes here, or some quotes, some comments. Slice the list. So what this is going to do is it's going to say X, and we have a starting position and an ending position. We're going to go from the first to the second. Now remember, the first is not the first item, it's position 1. Remember, that gets super confusing as far as 0-based indexes. To illustrate that, 1 to 2 position is actually Karen's. So what we're doing is we're taking this list here, ta-da, and we're saying 0, 1 to 2, so it's going to stop. If we omit this second position, we're going to get the remainder of this. We're going to say we want that whole slice right there. So let's demonstrate that. Ta-da! Works as expected. Slicing is a very convenient way of getting a sub-item. You may be thinking, lists are great, but now that I've created the list, how do I add items to it? That's a common question. So that's what we're going to cover in this little section here, is how to add the items. And you can either append or insert. And both of them do, well, exactly what they sound like they do. For example, X append, we are going to say append pizza. And let's go ahead and X dot append. I'm doing this twice for a reason, and you'll see why here in just a second. We're going to add beer, because everybody likes pizza and beer, right? Now we want to insert. So append will put things at the end in the order you put them. Notice we did 2 appends, pizza and beer. So it's going to add pizza, then it's going to add beer, and it's going to do both of those at the end. Now insert allows you to say, I want to put this at a specific position. So because we're talking about a specific, I need to give it a number. And in this case, 1. You notice it wants an index, an integer of where you're going to put this in the list. So I'm simply going to say 1, and let's add cats. So following along, what we're doing here is we're adding pizza to the end of this list. Then we're adding beer. Then we're going to go to the 1 position, not the beginning. The beginning would be 0, remember. We're going to go to the 1 position and add cats. Let's go ahead and add a few notes here. That way anybody who downloads this code off GitHub will just have the notes and be able to easily follow along. Now let's go ahead and do a print. And I want to see this list in its entirety. And let's see what this looks like. Okay, down here you can see we have our list and we have Brian, and then cats got inserted in the 1st position. And then my name Karen's 46, and then it did pizza and beer. Very important you understand that append will do it in the order you append it. So it put pizza at the end of the list, then it put beer at the end of the list. Very simple once you wrap your head around that. It just trips up a lot of newbies. Just bear that in mind when you're adding things. If you want a specific index, you need to do insert. If you want to slap it at the end, you do append. Okay, now that we've added items, let's talk about how we get rid of items. We're talking about removing. Let's remove, pop, and delete. And these do things very differently, even though at first glance they may seem very, very similar. So I'm going to say x.remove. And I want to remove cats. I'm not a big fan of removing cats because I happen to love cats, but you know what I mean. Sometimes you just got to get the cats out. So what remove is going to do is go through and remove the first item here. Let's grab our print statement, slap that down here, and let's run this. All right, so you can see Brian, cats, Karen's. Now it's Brian, Karen's. We removed cats, so it just removed that first item there. Now let's talk about pop. Now, don't get excited. Pop is not like Coke or Pepsi or anything like that, but what we want to do is we want to remove an item, but at the same time return it, meaning we want to be able to work with it here. So I'm going to say I equals, and we're going to do x.index because we want to find something here. We want to find pizza. Now this will raise an error if it's not found in there. So if you just look for something crazy, it's not going to return -1. And there really isn't a find. Remember we talked about find in the last video where it returned a -1? This is just going to say, hey, there's an error, and it's going to crash your program. That sounds really bad until we get into more advanced discussions where we talk about how to get around that and why it even exists in the first place. So just big leap of faith at the moment. We know that pizza's in there because we appended it. We're going to get that index because nobody wants to sit here and count and figure out what position this is actually at. We're going to say food. And we're going to pop. Now, when you think pop, think of it like popping the top off of an ice cold soda or beer, whatever your favorite beverage is. You now have that cap in your hand after you've popped it off. That's at least how I learned pop. So when you pop off the cap, you still have that cap. In this case, it is the item at index of whatever pizza's at. Sounds super confusing. It really, really does. But it's really simple once you see it in action. So what we're going to do here is I'm going to clear this list just to avoid any confusion. And we're going to run this. Boom. So what's going on here? We have our list and see there's pizza in there. And we're going to pop, meaning we're going to pop the cap off that thing that's in our hand. And we now have that bottle cap. And that bottle cap is pizza. So we can now use that. But once we've popped it, it's no longer in the list. See how it removed it? Very convenient if you want to remove the item, but at the same time use the item. Seems a little confusing, but bear with me. That is actually used quite a bit when you get into a little bit more advanced programming. All right, next up, we're going to talk about deleting. So I want to say I equals, say x index, and let's get the index of beer. Because again, no one wants to sit here and go 0, 1, 2, 3. No one wants to do that. We just want the computer to figure out where it's actually at for us. So once we get that index, and I should put a special note here, this will raise an error if not found. But once we get that, we want to actually just delete it. So we're going to say del x, and then whatever that position was. Now this will delete the item without returning it. And I'm going to copy and paste some notes in here. So delete a specific item without returning it, where pop will remove and return the item. Fundamental difference there. Which one would you use and why? Well, pop is if you want to actually use it. Delete is if you want it gone. Now, when you delete this, it's gone. You cannot use it. It doesn't even exist in memory anymore. And that's why it's called delete, because you're literally deleting that out of memory. If you're coming from like C or C++ or any other language that does memory management, yes, you are actually deleting that out of memory. Now, under the hood, what's really happening is Python's flagging that for garbage collection and all this other fancy stuff that newbies don't really understand. But if you're more of an advanced person, that's what's going on, is Python saying, get rid of it out of the Python internal list. We're just going to let the garbage collection wipe it out later on. Save run. This is what's going on here. So we found the index of beer and we deleted it. Pretty cool, pretty easy to understand. So major takeaway from removing items: if remove will remove the first one, pop will remove it but let you play with it. You can do whatever you want. And delete will, well, actually delete it and get rid of it. Let's talk about extending or adding elements from another list. And this will be a little bit confusing, but bear with me here. So there's a reason why you would extend rather than just add a list. And it's because Python, you can actually add lists into lists, which we're going to cover at the very end of this video, but it gets super confusing. So let's look at this. So we're going to say, we're going to make another list. And let's call this cats, comma, dogs, comma, birds. And in case somebody out there is like, well, how would you actually add a comma? You wouldn't add a comma directly. You'd add it as a string like that. But we're just going to add in cats, dogs, and birds into our list called Y. Now, the list we've been working with is called X. So we want to take the contents of Y and put it inside of X. So we're going to say x.extend. Sometimes IntelliSense helps us out, sometimes it doesn't. And we're going to extend with the Y list. Let's go ahead and print this out. Notice we're printing X. What do you think, pop quiz, what do you think this is going to look like when we run this? Well, if you said it's going to have the contents of both lists, you're absolutely correct. Now notice how what it's done is it's taken our X and added the elements of Y to it. So these are now true items inside of X. Very cool how that works. So let's talk about sorting. And when I say sorting, we mean sorting and reverse sorting, meaning doing the exact opposite of like an alphabetical. So let's go ahead and say sort and reverse. Now think of this as like sort ascending, sort descending. Now our list is a mixture right now. And what do I mean by a mixture? So if we just take this, print this out, run it, you can see how we got string, string, int, string, string, string. We're going to have problems with this integer, and we're going to have to take that out. And I'll demonstrate this really, really quickly. So I'm going to say x.sort. And this is where a lot of newbies get tripped up. And it goes, not supported between instances of int and string. And it's exactly that. So it's saying it knows how to sort strings and it knows how to sort numbers, but it doesn't know how to sort a string to a number. So think about that. Let's say you have a table in front of you, and I come in and I dump a bunch of potatoes and a bunch of apples, and I say, sort these. Well, how do you want them sorted? Do you want the potatoes and the apples sorted, or do you want them sorted by color, but they're all different colors? And this is what I mean. Python gets really confused, and it just says, you know what? I'm not even going to try and figure this out. I'm just going to drop an error, let you just figure it out on your own. The easiest way to get rid of this at this point is to simply remove it. So I'm going to say x.remove. We're going to just remove that int, and then we're going to sort. So now it's alphabetical because we've removed that. It knows exactly how to sort these strings. Birds, Brian, Karen's, cats, dogs. Very, very simple. The polar opposite, of course, is reverse. And we're just going to grab this for the sake of time. Pretty self-explanatory what's going on there. This would be like sort ascending, sort descending. I almost wish they didn't call it reverse, but called it like sort descend or something like that, or, you know, had a parameter inside of sort. We'll talk about parameters later on, but it can be a little bit confusing. But just think of sort as you're going to sort alphabetical, and reverse is the polar opposite of that. You notice how when we sorted, we had to remove that int, simply because sort will throw some sort of error if there's a mixed type. Now, what if you wanted to do that, but you didn't want to really modify the original list? Well, what we're going to do now is called a copy, and some people call this cloning. This is a very shallow clone, but basically we're just making a copy here. So we're going to say y equals x dot copy. Does exactly what you think it does. It actually makes a new list and copies the elements into it. So we're going to say copies the elements into a new list. Now we can simply say y.reverse. And we could add items, remove items, do whatever we wanted to do. So I could say y.append. Let's go ahead and append apples. We could do any other thing we really wanted to do here. So let's grab this print statement here. So x is the original. New is our y. Let's see what these look like here. So our original remains unchanged, where our new now has apples, and it's been reversed. Pretty cool the way that works. And then if you were done with y and you didn't want it anymore, you just simply delete it, which is what we're going to talk about next. Okay, so deleting. Delete the whole thing is really what I'm going to put here. Why would you want to delete something? Well, in the previous little segment here, we said we're going to make y, and y is a copy of x. Now that we're done with y, we don't need it anymore. We can do one of two things. We can either let Python garbage collect it, meaning it's going to figure out when it's not needed anymore, or we can specifically say delete the whole list. And yes, that deletes the whole thing. So if I try to say something like print y, it's going to have a bad time here, and it's going to say name y is not defined. And you remember from a previous video, whenever you see is not defined, it means it simply does not exist. Meaning we have now destroyed y, and everything in it has been destroyed as well. So all that memory, for you computer nerds out there, is now freed up and gone. We can use it for other things. This really becomes important when you start talking about embedded systems and things of that nature, where memory might be a little bit more constrained than, say, your desktop or your laptop. You got to understand that when you delete something, it is gone. And I mean gone, gone. Is not defined means you would have to rebuild this entire data structure from scratch. There's simply no way to recover it. Deleting can be a little bit drastic. As we saw, name y is not defined is, well, kind of a problem. I mean, what if you didn't want to delete the entire variable? You just want to delete part of it or clear the whole thing off. That's what we're going to talk about in this little segment here. So we're talking about clearing. Think of your list like a big table, and you got plates and dishes and all sorts of stuff on there. You don't want to throw the whole table out. You just want to clear it off, and that's exactly what clear does. So it's going to clear all of those elements out of the list, but the list itself will still exist. It will just be blank. Go ahead and demonstrate that. So let's type cleared. So most of the time in programming land, you don't actually want to delete. You just want to clear it out. So our list exists, you can see by these brackets, there's just no elements in there. And we can actually test that. Let's go ahead and get the length of x. So it exists, but there's no items in there. Most of the time, if you're confused, just think of it this way. Delete is throwing the entire thing out. You're throwing the whole kitchen table out, where clear is you're just clearing the dishes off the table. Usually you want clear, not delete, but delete exists in case you need to free up that memory. You want to do something a little crazy. A list can contain other lists, and if you look at this, it looks kind of weird. But just think you have a start bracket and an end bracket, followed by start and end, and start and end. So that's right, a list can contain other lists. If you're coming from another language, think of this like an array of arrays. It's kind of advanced and it's not something a newbie really understands, but in case you're curious, this is how you would do it. So we're going to say x equals, and we're going to turn x into a blank list with nothing in it. Y equals, and we're going to create another list. And we're going to say 1, 2, 3. And let's go ahead and make another list called z. And in here, I'm going to say my name. You go ahead and put your name, or cats, dogs, birds, whatever you want to put in there. So now we have 3 different lists. What we want to do is we want to take the contents of z and y and put them in x. So I'm going to say x.append. Let's go ahead and append y. Now, what I've done is I've taken all of these numbers and put them inside of x. Let's go ahead and print this out. Now I'm saying merge, but that's not really what we're doing here. We're actually merging all these into one giant data structure. You notice how we've got these double brackets here? So what we're saying is this item, this individual element, is its own unique list. So I'm going to say lists in lists. All right, now what we want to do is we want to take the contents of z and put them in x, but we want to put them before all the other stuff that we put in there. Say x insert. And let's go ahead and put this at the 0 index, and we're going to put all of z in there. Let's go ahead and run this. And you see now our list actually is made up of 2 smaller lists. Newbies may look at this and go, well, there's 5 items in here. There's really not. Let's go ahead and test this out here. So we're going to say, grab this and let's call this our list. And let's go len. And we're going to get the number of items in here. There's only 2 items in there. Very simple, very easy to understand. Now, let's say we want to grab the first item. We want to say 0, and we want to go 0. And let's go ahead and grab that second item. So our first item is this list here, which is its own little list, and second item is this list here. And in case you're wondering, yes, you can get kind of nuts here. What we're doing now is we're diving into those lists. So in our first list, right here, we're going to grab the first item, which is Brian. In our second list, we're going to grab the second item. Notice that's at the 1 position, which is 2. Seems super confusing, but just think of it this way. Think of it like a stair step. Every time you see these brackets, you're going deeper down a step into the basement. So for example, we could switch this around here. And we can grab the very first item, which was 1. We could switch this around again and say we want the second item, which is 3. Seems super confusing if you're a newbie, but trust me, once you get into more advanced stuff, this is a huge time saver, is just simply putting lists in lists. And when you start working with things like web services, you're going to find that quite a bit, where the data they're going to hand you is basically a list of lists, and you just simply have to navigate through it. Okay, a little bit of bonus material here. I know I'm going to get the question, so I thought I would just add it. How do you change an item? Remember, it's positional. So for example, let's say x equals, and let's just make some numbers here. 1, 2, 3, 4, 5. We want to actually change this. When I say change this, we don't want to change the whole list, just one specific item. So what I'm going to do is I'm going to say x, and then whatever the item number is. So let's say I want to change the item at position 2. And we want to change this to the word test. Remember, this is 0-based, and this trips up a lot of newbies. So we have 0, 1, 2. So this guy right here, we're going to change that. Let's go ahead and print this out. And let's see it in action. There we go. 0, 1, 2, our 2 position is now test, 4, 5. So that is very simple how you change something. A lot of people, especially me, take this for granted because it is so simple and easy to work with. And if you've worked with other languages, you may be looking for like a change element add or swap element or something like that. It's actually very simple. You take the list, you take the position, and then you assign it a value. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian, and in this video, we're going to talk about the set. Now, the set is a little bit different than the list. We spent 30 plus minutes in the last video deep diving into the list. If you haven't watched that video, I highly encourage you to go back and watch it because we really do dive into the list. Set, however, is slightly different. That difference, though, means it is profoundly different under the hood. Let's take a look at this. So a set contains unordered, unique, and immutable data types in a hash table. Let's break that down. What does that really mean? Unordered, meaning we cannot control the order. Like in a list, you could add or insert, meaning we could now control the order. Can't do that with a set. The set determines the order. Unique, meaning you cannot have multiples. So if you try to add 2 cats or 2 dogs, it's just not going to do it. And immutable data types. What does that mean? It means that once we add them, we cannot change them. We can only remove them or add them. We cannot change individual items. And it's in a hash table. Hash table, well, that gets a little bit complex in computer theory, but really, when you hear the term hash table, think blistering fast read access. The set determines the order so that it knows exactly where things are in memory, and it makes it very fast. So if you want very, very quick lookups, a set is what you need. Now that we understand what a set is, let's go ahead and let's create one. So first things first, we'll say S equals, and then we want these little curly brackets. Remember, if you do the square brackets, that's a list, completely different data type. You want the curly brackets. And in here, I'm going to just say 1, 1, comma 2, comma 2, comma 2, comma 3, 4, and 5. You may be going, now wait a minute, I thought it had to be unique. Well, this is one thing I absolutely love about Python. It automatically strips all that out for you, so you don't have to worry about it. See? 1, 2, 3, 4, 5. Even though we tried adding multiple 2s in here, it's smart enough to realize it already exists and says, nope, can't do it. And it doesn't raise an error or anything like that, so we don't have to worry about it exploding on us here. We can also, in case you're wondering, convert a list into a set. And let's show how to do that. I'm going to say, here's our list. And I'm just going to have my name and my age. And now we're going to say S equals, and we're going to use the set function. And what this does is take any sort of iterable data type like the list, which we've talked about, and convert that. Does it automatically. We don't even have to think about it. I'm going to grab this. Now, notice the order. I did Brian Cairns 46, and in a list, it's going to be exactly the way we put it. However, in the set, it's actually 46 Brian Cairns. So the set is now determining the position. That's one thing you need to really, really drive into your brain about a set, is the set is unordered, unique, and as we're going to see later on, immutable data types. Okay, let's see how we would add items to a set. It's actually very, very simple. So I'm going to say s.add, and you can add pretty much any element type you want. I'm just going to add the word hello. There is another way, though, and it's called update. And it looks a little bit challenging when we look at this. It says *s:* iterable t none. What does all this mean? Well, when you see this term right here, basically we're talking about something like a list. I shouldn't say a list, but like a list. Something that you can go through or navigate through, like a list or a set or a tuple, which we haven't talked about yet. You just need some sort of data container that contains multiple items that you can iterate through. So in this case, we're going to say, we want to do this in a list. Say 1, 2, 3, and I'm going to go ahead and add in hello. Notice I've got hello twice, but we're working with a set, which is unique items. So what's going to happen under the hood? If you're going to guess that the set is going to automatically strip out that second hello, you'd be absolutely correct. Let's see it in action. See? 1, 2, 3, 46, Cairns, hello, Brian. Again, unordered and unique items only. Now that we've added items, let's look at how we would go ahead and remove items. And it's just as simple. Say S, discard. And discard does, well, exactly what you think it would. It just takes it and throws it right in the trash. However, there's a subtle difference between discard and remove. Pop quiz, does anybody know what the difference really is here? Well, one will throw an error and one will not. So discard will not throw an error, where remove will throw an error. And what do we mean by that? If we run it in its current form, everything is, well, just going to work. Let's go ahead and modify this a little bit and demonstrate this error. So in our set, we have 1, 2, 3, Cairns, 46, Brian, and hello. Let's go ahead and say some number that we know is not in there, 78. Run this, and uh-oh, we have a key error 78, which means it knows 78 is not in there. In future videos, we're going to talk about how to get around that. You're going to use the keyword in to determine whether or not it's actually in there. But just for our beginner's perspective, discard will not throw an error and remove will. Be very mindful of that as you're moving forward. Another thing we can really do here is we can pop. Now, pop for a set really isn't abundantly useful. I'm just going to say it. You may be inclined to say, hey, I want to get like the first item or the second item or the last item. You can't do that. It's just going to return an arbitrary item. You don't control what item it gives you. It's just going to give you an item. That gets a little frustrating. But if you're just using the set as a container and you want to just get each item and remove it, pop is actually pretty useful. But this is going to be pretty random as far as you're concerned, and you're going to have zero control over it. Now that you've popped it, you could do whatever you wanted with V because it still exists in memory. However, it's no longer in our set. One question I'm often asked, especially by newbies, is, well, I have a set and I want to modify it. Well, unfortunately, you can't. Not only can you not modify it, you can't access items based on their index because the set has no concept of this. Let's go ahead and demonstrate. So I'm going to say S and 0. And we're going to change this to A. Go ahead and run this, see what happens. And object does not support item assignment. Oh, that is super frustrating. This is actually by design. Once you put it in the set, it will not change because under the hood, it's a hash table. It's making a mathematical computation to determine where in memory it needs to go so it can do a fast lookup. Okay, not a huge super deal, but I just want to print one item out. Let's just try to print that first item out and see what happens here. Uh-oh. Set object does not support indexing. Oh my goodness, that is so frustrating. You may be thinking, well, this is stupid. Why even use this? Let's just use a list and get it over with. Well, you can. However, a set is designed for a specific reason. That is fast lookup. Think of a set like you would have settings. Like, for example, all of your computer settings. There's probably thousands and thousands of computer settings. If you put that in a list, it's going to be hard to really navigate. So you would use something like a loop or use the keyword in, things that we haven't covered yet and we will cover in future videos. But what we're going to talk about is some down and dirty ways you can modify a set. So, for example, let's say, let's run our code here and see what we got. So we've got 3, 46, Karens, and Brian. Let's go ahead and say 3 in S. Let's go ahead and print this out just to see if this is in there. True. So we know that 3 is in S. Let's go ahead and say s.remove, and we want to remove that 3. Now, we want to go ahead and turn around and add 12. So basically what we're doing is we're saying, take this set, remove this 3, and change it to a 12. Unfortunately, we cannot control where it's going to put it in the set. Let's go ahead and print that out, probably be a little more helpful. There we go. Ta-da! So now it's 12, 46, Karens, and Brian. Honestly, dumb luck that it's in the same position. Don't count on that because the set is unordered. Now, we can do some crazy things here, and this is going to really hurt your brain. So let's go x equals, and we're going to make a set. And let's say A, B, C, D. And I'm quite literally just freestyling this, so expect me to make some typing errors here. And we're going to say C, D, E, F, G. So we've got 2 sets. Now we want to do some mathematical computations on these. And this is kind of the standard way of doing any sort of set modification. We're going to do what's called a union. So I'm going to say S equals, and we want X dot union Y. And what this is going to do is it's going to, and I'm going to see if I got some notes off the screen here, all the elements that are in either set. And I'm going to Put a little print statement here. So our union is now all the elements that are in either set. Very rapid modification of that set. You don't have to go and remove and add and check and see if it's in there. I'm going to just grab this whole thing. And let's go ahead and do an intersection. Now an intersection's a little bit different. It's going to get all the elements that are in both sets. Go ahead and demonstrate that. And what's in both is D and C. See? Pretty simple, pretty easy to wrap your head around. Now let's get a little bit crazy here. So we're going to grab this. And we want the difference. You ever have somebody say that to you? Let's, split the difference. So the difference are all the elements that are in X, but not in Y. Which in this case is B and A. And one more that we're going to cover here. And this is the, maybe if I get my mouse to work, the symmetric difference. Now this is going to be a little bit different than what you're thinking. So this is all the elements that are in one of the sets. What does that mean exactly? Save and run. All of the elements that are in one of the sets. So it's going to take both of them and basically make a third set in memory and say, okay, make sure what we're giving back is a unique order of items that exists in at least one of the sets that we've given it. And it gets way more complex than that, but that's basically what's going on under the hood. You can see we have F, E, B, A, G. So the main takeaway from here is all the way up at the top, sets contain unordered, unique, immutable data types in a blistering fast hash table. What is the fundamental difference between a set and a list? Well, the set is, well, a little bit more challenging to work with, and you cannot modify it as easily as you can with a list, but it is much, much faster, which you're really not going to understand how fast that is until you get into more advanced programming. Right now, we're learning the fundamental data types, and we just covered the set in depth. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. Let's continue our journey into Python 3 with the tuple. Kind of a funny name, but this is really, really cool. So a tuple is a fast list that cannot be modified. It's read-only. Once you create it, you can make 0 changes to it. This thing exists solely to exchange data, and it's typically used between classes, between objects, between frameworks, and between devices. For example, let's say somebody made a package that was going to give you the CPU and RAM and hardware and all this cool information about your device. They don't want you to be able to modify that. So it may seem kind of plain and boring on the surface, but you can do some really cool tricks as we're about to see. First thing we're going to do is create a tuple. Go ahead and make a variable named t, and let's give this an assignment. Notice how it's got these little curved brackets here. When you see these curved brackets, think of it like a shield defending it because it's read-only. You cannot change this. We're just going to give it some information. We don't really care what we put in there because we're just testing it out. Say print and T. You guessed it, it's got these curved brackets, and that is what denotes it's a tuple. The major takeaway here is the different style bracket denotes what it's going to be, whether it's a tuple, a set, or a list, or a dictionary, which we haven't covered yet. Now that we have a tuple, let's look at how to access the elements inside of that tuple. It's dead simple. We've done this before. Let's go ahead and say print f, and we're going to access via the index. Give it our index position. Remember, this is a zero-based index, so 0 is actually the first position, and then 1, 2, and so on and so on. Run works exactly the way you would expect it to. Let's go ahead and do a slice, because slicing is pretty easy and fun. And we're going to grab this and say, I want to go from 2 to the end of the tuple there. Works as expected. Go ahead and clear this out. And let's look at a bool operation. What we want to do now is we want to look for something specific inside of that tuple. I want to say, is 3 in T? What this is going to do is tell Python, hey, take this value, and inside of this tuple, and it could be a list or a set or a dictionary, we haven't covered dictionaries yet, and it's going to search and see if it's actually in there. It's going to return a bool saying yes or no. In this case, true, because 3 is right there. This is extremely easy to work with, and it's blistering fast. Okay, bonus material. Let's talk about assignment. When I say assignment, what are we really talking about? I mean, tuples are kind of boring. You create them and you can access elements. Other than that, you're done. Well, you can do some really cool things, not just with tuples, with lists and sets, but tuples make it really simple to understand. So we're going to make a tuple, and we're going to put some variables. These are not values, these are variables. Remember, a variable is something that'll change. X, comma, Y, comma, Z. Now, I'm going to make another tuple, and we're going to give it values. 1, 2, 3. What are we doing here? Well, we're saying take these variables and give them these values, and Python under the hood is going to figure out which one needs to be which. Go ahead and print X. Let's print Y, and let's go ahead and print Z. See this in action? Ta-da! 1, 2, 3. Beautiful. Now let's talk about the range function, and this is something that a lot of people don't really talk about too much. You just see it and you expect that it'll just magically work. So let's grab this. There we go. So we've got X, Y, Z, and we're going to get rid of this right here. And we're going to say we want Python to do all that work. We don't want to sit here and type out values all day long. So I'm going to say range. And let's give it a 1, see what happens here. You're expecting an error, you got an error. Not enough values to unpack. Expected 3, got 1. Well, let's just test this theory and say we want 6. We're going to give it more than it needs. And, of course, another error. Too many values to unpack. Expected 3. So it's telling you, I demand 3. Where's it getting 3? From right here. Under the hood, Python is making a tuple of variables. And we can assign to those variables using the range function. Now, range itself is not returning a tuple. We can test this out by just simply grabbing this. Go ahead and print this out. We're going to actually print range 3. Notice how we got 0, 1, 2, so there is our range, but then we're printing range 3, and it's saying range 0 to 3. So what we're really expanding upon here is that the range itself is telling Python, go through a loop, something we're going to talk about in a future video. But you have a start and an end. We haven't really given it a start and end. We just said, hey, make 3 values. It's going to start at 0, go 3 times. What if we don't want to start at 0? We want to start at 1. Well, we give it a start, and now we have to give it an end position here. 4. Why 4? Because we need a starting position plus a length of how many we need to unpack, which is 4. 1 plus 3 equals 4. Ta-da! Now it just works exactly the way you think it would. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Hello again, everyone. This is Brian, and in this video, we're going to cover the dictionary in Python 3. So, what is a dictionary? It's a key value pair. More appropriately, it is a list that's indexed by keys. If you want to be really specific, you notice the brackets. This is actually a set indexed by keys, which can be any immutable type. What does that mean, any immutable type? It means unchangeable. So let's take a look and let's see what it takes to create and work with a dictionary. Let's take a look and see what it really takes to create a dictionary. We're going to do this two different ways. We're going to do it the hard way and the easy way. First, let's do it the hard way. I'm going to say d equals, we've got our brackets. We need a key value pair. So let's create the key. Key is going to be the string pet, colon, and now we need a value. Let's say dog. That's it. That's really all there is to it. Now, if we want to make another one, we just separate it by a comma. Now we need a key. Well, let's call this age. Value is going to be 5. Let's go ahead and make another one. Let's call it name. And its value is going to be spot. I'm always bad at picking pet names. Go ahead and print out the dictionary in all of its glory. There it is. Pet dog, age 5, name spot. Ta-da! Now let's do it the easy way. I'm going to say d equals, and we're going to call the dict function. Funny name, say that real loud in class and watch everybody just kind of look at you. But we're going to say pet equals dog, age equals 5, and name equals spot. So what's really going on here is it's doing all this formatting for you. That's why I call it the easy way. The end result, however, is exactly the same. They are exactly the same. Doesn't matter which way you create it. Just under the hood, know that you have to have a key value pair. For example, pet dog, age 5, name spot. Let's take a look at the keys and values and how we get at them. There's a third type really, and it's called items. We're going to work with that one first. So we're going to say print, and we'll go f items. And we're going to call the dictionary items function. Save run. And this is going to return a dict underscore items, which you guessed it. Look at this thing. This is insane. So we have a tuple containing a list containing tuples. But what it's really done is it's packaged it into individual items. So you can very distinctly see the key value pairs. Not abundantly useful for us. What we really worry about are, well, the keys and the items. So let's go ahead and look at those real quick. I'm going to just say keys and values. Did I say items earlier? I did. All right, so we want to look at the keys and the values. Save and run, and voila. So we're returning 3 different things. Dict underscore items, dict underscore keys, dict underscore values. But what we've got is all of the information in this dictionary right here in these 3 functions. See, items returns pretty much everything nice and packaged. The keys is going to tell us what keys are available, because remember, everything's a key value pair. So when we go to look something up, we can't do it by index. We have to do it by key, which is why these keys exist. You could easily make these keys integers or numbers of some kind, but we've done it as a string. We can also get the values dog, 5, and spot, which are abundantly unuseful without the keys. So in the next section here, we're going to take a look at how you would actually get those. Let's go ahead and take a look at how we would get a value from a key, because these are key value pairs. It's called the key because it unlocks the door to the value. And let's take a look at what I mean here. So I want to format this, and I'm going to say name. So let's capitalize that. And we're going to say D, and you're inclined to do something like this, D0. Let's run this, and key error. What does that mean, key error? It means the key was simply not found. We don't have a key named 0. We do, however, have a key named name. We also have one called pet and age. So you have to use the key to get the value. Let's demonstrate that. See, the name is Spot. Now, you notice how I have different quotes. I have single quote and double quote. There is a very interesting little issue here where if we do a single quote within a single quote, bad things happen very quickly. We get an invalid syntax. And you're looking at this going, now wait a minute. It should treat everything in these brackets as a separate entity, but it really doesn't. So you do have the quote issue that we've talked about in a previous video. All right, so now that we've wrapped our head around that, let's take a look at the key error in depth. And let's call this test. And let's just say blah. Some key we know doesn't exist. Really what's going on here is it's going out and it's trying to find any key of that value. And if it doesn't find it, it throws a key error. At the very end of this, we're going to show you a little trick using some simple logic, which we haven't covered yet, to get around that to determine if the key even exists in the first place. But just right now, know that you have to have the key, otherwise it will throw an error. So just put a quick note there, will throw an error if the key is not found. Let's go ahead and take a look at how hard is it to add an item to a dictionary. Well, it's not, it's ridiculously simple. You just simply do something like this. There you go. It's that simple. You just simply say dictionary and then some key that's not in use equals a value, and it will add it automatically. It's very cool how it does that. Now, you should note, and we're just going to copy and paste this, what happens if the key already exists? So here we're adding, and here, what's going to happen? Let's run and find out. It's just simply changed it. This is what I mean by the key is immutable. We cannot change this key. We could delete it and re-add it, but once that key's in there, all we can do is update the value or delete it. The key itself cannot change. And let's take a look at what it takes to remove an item. Our good old buddy, the delete statement. So we're going to delete, you guessed it, the trick. Now, this is what I mean by this is a key value pair. When we run this and we delete a key, the value associated with that key is also removed. You see right here. Trick, roll over, we've deleted it, and now it's just simply gone. It's not in there. Very simple to do that, but just understand that once you delete the key, the value is gone. However, if you were to try to delete the value, the key will be there, but you'll have a null value, and that could lead to some issues down the road. That's a more complex topic we're going to cover in a future video. I just want you to be aware of that. I've been getting a lot of really good feedback about this video series, and some people have said, hey dude, you're going a little too slow. I realize these are for beginners, but I want more now. So we're gonna give you a little preview of what to come. So we're gonna test for existence, and we're going to do something called a loop. And both of these may be a little challenging, especially for newbie programmers, but if you're an experienced programmer and you just wanna learn it now, let's just go over it and get it out of the way. So we're gonna say if, and this is basic logic. I say name in d colon and hit enter. What we've done here is an if statement. This is a logic. If this key is in the dictionary, do something. Now, Python has this little guy right here, this colon at the end saying, hey, it's not the end of the statement, expect more. And then you have to have, it's either spaces or a tab, it doesn't really matter, but it has to be the same amount. If you're from another language, you're expecting something like this. And you may be going, why do you need tabs? Well, if you think about it, your code is here. And if you get rid of the tabs, it looks like this. So it just makes sense. But a lot of people when they're first starting Python can't wrap their head around the tabs or the white spaces, and it just infuriates them. So this is what I was saying earlier about we're going to test to see if that key exists before we try to access it. Now, if the key was not in the dictionary, it would throw a key error, but we're saying if. So only if this exists in the dictionary are we going to run this code. We're going to go over all of this in more detail in a future video, but I've had a lot of people saying, hey, they want more now. So there's one. Now let's go over loops. This is the other thing that really trips people up, especially in newbie land, is because they're new. They don't understand this stuff. Nobody's explained it to them. What is a loop? Well, have you ever gotten in trouble as a child and your mom or dad says, go do this until I tell you to stop? That's basically what you're telling the computer to do. You're going to say for a key in D keys, and this may look really confusing if you're a complete newbie. Again, got to have that white space. We're going to go ahead and print. And let's go ahead and format this. And I am going to explain this, but at the moment, just take a huge leap of faith with me here. So we got our key, and then we're going to say dictionary, and then the specific key. This looks ugly if you're a newbie, but let's run it. It works. So it's saying pet dog, age 5, name Spot. That's what we're doing right there. So what's going on here is we're saying for every key in, there's that in keyword again, the dictionary keys. Remember we talked about this way up here. For every key in the dictionary keys, go ahead and print out the key and the dictionary value that correlates with that key. Again, you have to have that tab there. We're going to cover looping also in a future video, but this is just because people have been saying, we want more and we want more now. So if you're having trouble wrapping your head around these two right here, don't worry. I'm going to make a future video that's going to cover those in depth, and we're going to talk about them. And I do mean in depth. But if you are a seasoned programmer, that's very simply how you do it. If you're having trouble wrapping your head around these tabs, just think of it like this. You have some code, and then normally you would do something like this. And Python's trying to help me out here. But you would have something like that. Strip this out, replace it with that. And of course you'd have something here. Sad code. Why not? Let's say sad code here. But then you strip these out and it becomes that. And that's why Python is so much smaller than other languages compared to something like Java, JavaScript, because it takes all those special characters out of there. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian. Let's continue our journey with Python 3. So in this video, we're going to talk about if, else, and elif. What are these three things? Well, it is simple flow control. And when we talk about flow, we're talking about the flow of an application. And this is the basic building blocks for that flow control. Before we dive in, we need to talk about some basic theory. Don't worry, I'm going to keep it super short. We have a variable. Let's call it x, and x is true. A very simple bool. We can turn it on, we can turn it off. Now we're talking about flow control. Think of flow control like when you were a child and your parent looked at you and said, if you do this, then this is going to happen. That's essentially what we're talking about. It's a decision. It's not super hard to wrap your head around, but it does take some explanation. So x equals true. We've got our if statement. And if is going to function on some sort of condition. A condition, most of the time, will evaluate to true or false. So we're going to say if x equals true, then do something. We'll have some code that'll run if it's true, and we'll have some code that'll run if it's false. Now, this is not always the case. What I mean by that is sometimes this over here simply doesn't exist. You're only going to evaluate for true, but you can do things like say, if it's true, do this, else do that. And it can read like a book. You can literally say, if Bob equals happy, then do something. If Bob is not happy, do something else. It's really that simple. However, you need to understand this is the fundamental building block of almost all applications. This is called flow control. You are controlling the flow of the application's logic. All right, enough theory. Let's dive right in. We're going to look at if conditions. So we're going to create a variable called x, and we're going to say it is true. This is just simply a bool. We've seen this before. Now I'm going to say if, and you notice how in VS Code it gives us these little templates. We're just going to do normal if. We're going to say if x, colon, and now we want to print something out. Let's go ahead and run this and see what happens. And it says yes. So our programming logic is x is true, and if x, notice how I just said if x. We could have said if x equals true, then it's going to print this out. But it knows it's smart enough to know you don't really need that. Also notice this indent. We've talked about this a little bit before, and this colon. So if you're coming from another programming language, this is really what it looks like under the hood. You have these brackets, as everybody loves in, C++, C#, JavaScript, all the C-style languages, and the code's pretty much indented. Well, Python does away with that. So all of this gets converted into that, and it's much shorter, much easier to read. You don't have all these weird squiggly lines you got to worry about. Now, you can continue to execute as long as it's on the same indent. For example, x is true, if x, print yes and again. See, yes and again. Now we are going to say else, and this is where we pop back. Need that right there to tell Python that we've got more coming. And we're going to just simply print O. What's going to happen when we run this? Well, x is true, so if x, and then it's going to run this. Else, it will run that. Else is funny because else says, hey, if this didn't happen, then instead run this code here. Whenever you see these indents, think of this as a block of code. It's actually called scope. So this would be a scope, and this would be a scope. It's a much more complex topic that we'll cover in a future video, but I want you to be aware that exists. Let's go ahead and run. You see yes and again. It never printed no. I'm going to say help. I mean, just to make sure this really stands out on the screen. Run it again. We never see it. Why? Because this is true. If X, then print this out. It never jumps to else. So let's change this to false. And you'll get a feeling for how programming logic takes place. X is now false. It's going to say if X, print these, else print that. So what's going to happen here is it's going to get to X and say, nope, X is not true, so ignore this block of code and instead jump down to else and run this block of code. See? Help. Works as expected. So what we've really been talking about is condition evaluations, and they're pretty much going to be true or false, meaning true, run it, or false, don't run it, or just do something completely different. Let's take a look at some condition evaluations here. So I'm going to say X equals 100, Y equals 25. So I'm just creating two little variables here, and I'll say if, and we're going to say Y equals X. We want to tell Python there's more coming. And we're going to print this out. Notice I'm doing this all on one line. You don't necessarily need to do these tab indents. You can do everything on one line if you want to. So we're saying if Y is equal to X, notice there's two equal signs. If you do this, you're saying make Y the value of X, and we don't want that. We want to test for equality here. We're going to say equal to. And we can just, through the magic of copy and paste, speed this up just a little bit here. And we're going to look at our condition evaluators here. So I'm going to say if Y is not equal to, and then we can say less than. So if Y is less than X, and I want to say greater than. So if Y is greater than, what we're really getting at here is you can do some really complex decision making based off values. And they're very simple, very easy to understand. All you need to do is understand the symbols. For example, this guy right here looks super confusing, but we're saying if Y is less than or equal to. Notice how you have this compound here. So now this gets really complex and you've got it all on one line, but it is super convenient to do that. And you can do the exact opposite. You can say greater than or equal to. Let's go ahead and test this out here. So we're going to run this and you can see it doesn't print everything. It says not equal to, less than, and less than or equal to. So what's going on here? We're evaluating Y versus X. So we're saying, is Y equal to X? Well, it's not. They're two different values. So it's not going to run this code. This is what I mean by the condition evaluations will go to true, run it, or false, not run it. There are other ways of doing it, but we're keeping things super simple. And then we're saying if Y is not equal to X, which is going to evaluate to true because those two are not equal, then print this out. And sure enough, we see not equal to. I'm not going to go through each line, but you can kind of view and see which one of these evaluate to true. For example, is Y greater than X? Well, of course it's not. 25 is less than 100, so this will never run, and we don't see it down here. Now, if we change this value, you'll notice the output changes as well. Now it's not equal, but it's greater than and greater than or equal to. This is extremely cool and it's extremely flexible. Now you start to understand how computers make decisions. It's based off simple if logic. If this statement or this condition evaluates to true, then run some specific code. All right, all of this seems pretty cool, but look at this. It's kind of a jumbled mess. It's just this big wall of if statements. It's very hard to read. There's no indentation, and you got to kind of read through every single one to find the one you're looking for. Let's talk about elif, which is really a switching solution. Now, when I say switching, other languages have a concept called a switch, which is just like, think of a big panel of light switches. You can turn them on and off. Python doesn't really have that concept. There's ways around it, but it doesn't really have that specific concept. So let's look at a way of getting around this. So I'm going to say x is 10. Now we want a bank of switches. We want to be able to turn code on and off at will. So I'm going to say if x equals 25, then we're just going to print out x equals 25. Now we want to take this and kind of smash it into something without doing a completely new if statement. We want this to stay all in one line because, believe it or not, these are two different statements and they'll execute separately. So what we're going to do here is elif x equals 50. So really now it's going to read this as one giant line. So it's going to say if x is 25, execute this, else if x is 50, execute this. And we can just take this concept and keep expanding on it. Go ahead and say if x is 75, and let's go ahead and say 100. We can end this and say, you know what? If we didn't find any of these switches using the elif statement, we can simply say else and then make what's called a catch-all. Which is going to execute if none of these fired off. So it's at 10. Let's see what's going to happen here. It triggered our catch-all. See? So it went through and evaluated and says, is x 25? No. Is it 50? Is it 75? Is it 100? Else, fire it off. Let's switch this to 75. See what happens. You can see now it just says x is 75. So what's going on here is it says, evaluate this, evaluate this, evaluate this, turn to true, run this code, now we're done. So it'll jump all the way out. Very simple, very easy logic, and it looks much better than just this giant wall of text. Super easy to follow. As you dive deeper and deeper into programming, you're going to find there's always another way of doing it. If you didn't like elif, there is another way. And it's called nested or nestled statements. And this is basically a statement and a statement and a statement and a statement. And you can go on forever and ever and ever. Let's go ahead and take a look. So I'm going to say x equals, and let's just pick a number at random, 82. And we're going to say if x is greater than 50, print, and let's say over 50, but wrap that in some quotes here. And because it's over 50, we want to keep going. So I want to say if x is, well, greater than 60, then, and we can use the same logic over and over and over. And this now becomes a very repetitious pattern. So for example, I can just say this, and we can just grab this and keep going. Notice how the indents get bigger and bigger and bigger. You have to do this, otherwise Python considers that a new statement. So for example, this would actually create a problem here. It's not going to execute the way we want it to. So what we need to do is indent, indent, and this is what I love about VS Code is it puts these lines where the indent is. So now you can see this is a statement, this is a statement, and so on and so on. And it gets very, very cool very quickly. Now, sometimes pasting betrays you and you just simply got to tab it over. Again, the lines will be your guide and literally tell you where you need to go. So let's say if it's over 90, and I don't want to take this too ridiculous, let's go ahead and say if x is greater than or equal to 100, we're just going to end it here. Print complete. Let's just say that x stood for some sort of progress. Now, we've got some issues here right off the bat. You notice how this little squiggly line here, it's saying unexpected indent. So we've got to back this out here and fix our indentations. Uh-oh, didn't like that. So we can just grab this whole thing and indent it. Should fix it. There it goes. Save and run. Uh-oh, we have another indentation error. Let's see what's going on here. So this is the part of Python that will drive you absolutely bonkers. If you don't have your indentation right, it will let you know, and you'll get an indentation error. Now that all my indentations are fine, it should run as expected. So which one would you use? Well, it depends. So for example, in this scenario, we have what's called fall through, meaning x is 82. So it's going to evaluate, true, jump to the next one, true, jump to the next one, true, and jump to the next one, true, and then it's suddenly false. So it stops executing here, even though there's more of the statement. And you have these lovely little indents, love them or hate them, that you have to contend with. Remember, the indentations tell Python where you are in the programming logic. So some people like elif, some people like fall through, expect to see both of those out in other people's source code. Choose the solution that works right for you. My personal preference is for elif. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian. Let's continue our journey into Python 3. We're going to talk about the while loop. This is basic flow control, and it's going to prove a point. Your computer is very stupid. And yes, I said what I said. Your computer is just very dumb, and we're going to prove that. So a loop is just simply completing code over and over and over again until you tell it to stop, because the computer isn't smart enough to know when to quit. Let's take a look. Okay, a little bit of theory here before we move on. We have the entrance of our program, and we're going to jump down into some sort of loop. Let's call this our loop here, and it's going to evaluate this and run some type of code. Now, it doesn't really matter what type of code it runs. Let's get rid of that little guy. Usually what you're doing is some sort of incremental function. For example, count something, increase a number, look for data on a socket or something like that. So it's going to say, okay, start the loop. Don't want to connect there. There we go. And do something. If you don't exit this loop, it just literally goes right back into the loop, and your program ends up looking something like this. We call this an infinite loop, where you will enter the program, go into a loop, and then you just loop this code over and over and over again until you tell it to, well, stop and do something else. You may be asking yourself, why do you even need a loop? Well, think about it. You enter your program, you come down into your loop, and let's say you want to do something 100 times. You need to now increment some sort of counter. Once you've hit that counter, you jump out of this loop and you stop your code. There are some loops out there that are intentionally infinite. And what I mean is they look like this. The program starts, you enter your loop, and then it just loops forever. For example, when you do graphic user interface programming, you have what's called the user interface loop or the event loop, which is basically the program will run forever waiting for the user to like click a mouse or move something around. That loop just happens forever and ever until the program closes. All right, now that we understand what a loop is, let's take a look at it in practice. So I'm going to say x equals 0, and we're going to create our while loop. And this is going to look very similar to an if statement because it's going to evaluate it just like an if statement would. Meaning this loop will execute as long as the condition we're about to give it is true. So I'm going to say x is less than 10, then do something. And this is going to be a great example of how computers are dumb. They do what you tell them to as you tell them to do it. Little bit of bonus. Anybody see a problem with this statement? Well, what we're saying is x is 0, while x is less than 10, print this, but we're never incrementing x. It's always going to be 0, so this will always be true, and it'll just run forever. That's the infinite loop I was telling you about. See how it just says 0? And it's going to run forever and ever, and that console is just going crazy, so I'm going to kill it. It will just keep going forever and ever until I turn the program off or until I shut the computer down. So we need to actually increment x. Once we do that, we have now incremented our counter. Eventually, x will be 10 or greater, and this will exit out. See? 1 through 10. Works as expected now. So loops can be very powerful and very easy to use, but you can very much screw up your application just by creating an infinite loop on accident. Now, in case you're wondering, let's go ahead and print this out here, and we're going to say test 1 is done. We want to know when this loop is done executing, and we use, you guessed it, the indentations. This determines our scope or our block of code. So while this condition is true, execute this scope or this block of code. Then when we're done looping, we're going to jump right back up here. Let's see that in action. I'm going to clear that out. Sure enough, 1 through 10, and then test 1 is done. So it works exactly the way you think it would. Let's take a quick detour and talk about pass. You're going to see this quite a bit in Python land, and a lot of people don't really explain it. So let's just say while, and let's just take this little template here, and it's going to say while expression pass. But this is a valid Python expression. Go ahead and say 0, and let's just give it the same logic here. Notice how this will run. Now what's going on under the hood is this is still functioning. Or is it? Let's find out here. I'm going to kill this terminal just in case. We'll say test 2 is done. So x0, while x is less than, notice how we never increment it like we did in this guy. We're going to pass, and then eventually print out test 2 is done. Save run. Notice how it says test 1 is done from up here, but it never gets down to test 2. So what's going on under the hood? This script is still running. It's just doing an infinite loop right here. So whenever you see pass inside of a loop, be very careful because you're creating some sort of infinite loop. Pass is a special keyword in Python that tells Python, take no action and just continue with what you would normally do. So be very careful with pass. We just covered that pass is, well, pretty dangerous in a loop, simply because you can loop forever on accident. Well, it's not that simple under the hood, but we're going to try and make it simple, and we're going to talk about continuing and breaking. So we're going to say x equals 0, and let's go ahead and do something really, really terrible. We're going to say while true, do something. If you're paying attention, you know that while is going to evaluate this much in the way an if statement would, and it's going to say if this is true, do the loop, and keep doing it over and over until this is no longer true. However, we've used the Python true keyword, so this will now loop forever. And you will actually see this out in code because sometimes people just want to loop until some arbitrary condition is met. It could be input from the keyboard, it could be some network connection, it could be anything, but you're going to see this a lot. So you'll need to know when to break out of the loop or how to handle certain conditions. So let's talk about continue first. we're going to say x plus equals 1. And if x is less than 5, we want to, well, just kind of skip over this. And we don't really want to do anything. So I'm just going to say x is less than 5, whatever the number is. And then we're going to continue. And what continue does is say, go back to the beginning. Just continue along your merry way and do what you were going to normally do. And then we're going to add in some sort of logic. So if x was greater than 10, we would do something. Print that x out. And we're going to put a print statement at the very, very end of this. And notice this is on the same line as while. So this will not print out until this loop is complete. One thing I love about VS Code in most editors, you can actually collapse. So it actually looks like this. So once this loop is done, it'll print complete. Let's go ahead and clear this out. See this in action here. Uh-oh, you notice how it's working exactly as we expect it would, because the computer, while very fast, is very dumb. So what's going on here is it's going and saying, if x is less than 5, print it out, and then just go back to the beginning. So we're still in continual loop land. We need to fix that. So our programming logic, we want to basically say, if it's less than 5, just go back to the beginning of the loop and keep incrementing that counter. If it's greater than 5, do something, but we also want to stop when we hit 10. So I'm going to say if x is 10, print and then x equals, just so we can see that x is actually at that value. Now we're going to use the break keyword. Now, don't worry, we're not breaking anything. Break is like, kind of think of the while loop, this guy, as a little jail cell. And we're going to break out of jail and just jump right to the next line. So it's going to pick up code execution right here, and then it's going to run this statement. Let's go ahead and see this in action. Okay, sure enough, we've got x is less than 5. We got 1, 2, 3, 4, and then do something 6, 7, 8, 9, 10. And then when we hit 10, we're going to exit and we are complete. So that is looping in a nutshell. Some major takeaways from this video is, well, loops are very, very powerful, but you need to have some sort of condition to evaluate. Otherwise, you're going to create an infinite loop. An easy way to create an infinite loop is just simply pass, and it will loop forever. And you can say while true, which will also create an infinite loop, but you can use continue to, well, continue to use the flow inside of the loop, or break to break out of that flow and use the programming logic. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. In this video, we're going to talk about the for loop and the range function. The difference from the for loop compared to the while loop, which we talked about in the previous video, is the for loop has a beginning and an end, and the range function helps us create that beginning and end. Really helps us to just avoid that nasty business of infinite loops. Let's dive in and take a look. All right, first things first, let's go ahead and look at the for loop on list tuples and sets. This is super, super ridiculously simple. And I'm just going to make a simple list. And we're going to say for I in. Notice what we're doing here, though. We're saying for, and then we're creating a variable. And this variable is named I. You could name it X, Z, zebra, whatever you wanted to name it. I'm just going to say for I in, and now we have to give it some sort of container. Let's say X, and then the colon. This reads just like the while loop, but we are now creating the variable in the statement itself. What we can do now is just simply say print, and let's say I, and we're going to print out the value of I. Go ahead and run this. You see I is 1, 2, 3, 4, and it stops. We don't have to tell it to break or to return or to do anything like that. And we don't have to increment some sort of counter. It does it for us under the hood based off the, you guessed it, the length of this list. So it's taking this iterable container and it's saying each one of these is now a separate variable and we're going to treat it independently. And you can do this ridiculously fast and you can do it across different types of things here. So for example, I think I made one too many. We're going to say list, tuple, and a set. And we're just going to say this is L, this is T, and this is X. So we've got a bunch of different things here, and let's actually, one of the little nuances of this is you got to have it in the right style bracket here, or this case is the parentheses, and the set has the little weird squiggly thing. There we go. And we can just switch this out. So we're going to do the list. Works as expected. Let's switch this out to the tuple. Works as expected. And I know you're already probably rolling your eyes going, we know, the set's going to work just fine. And it does. Everything works as advertised. This makes it just ridiculously easy to loop through a container. Let's take a look at the for loop in regards to dictionaries. We're going to treat this a little bit differently here. So I'm going to make a dictionary, and I'm going to say dict, and let's just go ahead and build this out. Brian, I'm going to say my age is 46. Say Tammy. Don't tell her I put this in the video. She'll get very mad, but she's 48. And then Heather, let's go ahead and say Heather is 28. And Chris, let's just say Chris is 30. We could add more if we really wanted to. So we have our beautiful dictionary here. Go ahead and print this out just so we can see what it looks like. And it creates a dictionary for us. Now we're going to work with this in regards to the looping. When I say the looping, there's a couple different ways we can do this. So the first way, we're going to say for k in x dot keys. Now you got to be a little careful here. If you forget to call it as a function, and we haven't really covered functions yet, but trust me on this. If you just do this, you're going to have a bad time. And let's actually see it fail, just to prove that, hey, it is going to fail. And we're going to say keys k equals, and then we're going to fill that out later. But let's just watch this thing fail. See? Built-in function or method object is not iterable. What is going on here? What does this mean? Plain English, built-in function or method. Well, we haven't really covered these yet, but basically it's a chunk of code that we can call. And to do that, you need these parentheses. So if you forget those, you're going to have a bad time. And it says object is not iterable. What does that mean? Well, it needs to be a container of some kind. For example, a list, tuple, set, or a dictionary. So simply by saying, hey, use those parameters, it's now going to return some sort of data that is iterable, which we can go through and work with. All right, let's continue on. We're going to say X, and we want to get that specific key. And I'm going to just assume you watched the previous videos, but just in case you skipped them, let's slow this down just a smidge here. First things first, we need to fix our little error there. So what's going on here is we are creating our dictionary. The dictionary is just a key value pair. Key value, key value, key value. And you can see that in the dictionary right here, where it's created those key value pairs. Now we're going to say for each K, or each key in our dictionary's keys, it's going to return back some sort of list. We're going to say for each one of those, get the value. So we're saying XK. So really what we're saying here is X is a dictionary, K is the key. So we're saying for whatever key, for example, if it was Tammy, it's going to say print out Tammy, because that's the key, and then print out the actual value here, which is that right there. So each key is going to correlate to a value. So what I'm trying to really drive home here, maybe I explained that badly. So keys, and then you got your key value, key value, key value. There is another way of doing it. And I wanted to bring this up simply because you're going to see people do it both ways. So we're going to say for K, comma, V, this is going to blow your mind if you're coming from another language. We're going to say two different variables here, key and value, in, we want to switch this out to items. And again, we're calling a function, so we need those parentheses there. If we forget those, we're going to have a bad time. And because we are now pulling these or unpacking those, we don't have to do this little bit here. We can just simply swap that out with our variable. So what items is doing is, well, it's actually pulling each key value pair out and returning it. So now it can unpack the key and the value. So you have two different variables. Let's see that in action here. Let's save and run. And actually, let's call this items so we don't get that confused with the keys. And sure enough, items, and it has unpacked them correctly. Brian 46, Tammy 48, Heather 28, Chris 30. So which way's better? Well, it depends on what you want to do. Personally, I tend to do this method right here. That way I don't have to mess around with all these little brackets remembering what does what. But each way is perfectly fine. Let's talk about range, and we've touched on it briefly, but let's really look at range. So let's kind of quick review here. We're going to say x equals, and we want a range of 5. And if we print this out, this is where you're going to get really confused really fast. So let's go ahead and run this. And here's our x right here, range 0 to 5. Wait, what? You're thinking this is going to return a list or something like that. Actually, it's going to return a function call. So there's range 0 to 5. What is this 0 to 5? Where did this come from? We said 5. Well, we're going to look at that in the next little segment here. But just understand what we're really doing is we're saying x is really going to equal a call to that function. We're going to cover functions in depth in other videos. It's actually a large topic, so we're going to split it into multiple videos. But just understand what's going on here. You're not actually getting some sort of iterable container that you can go through. But what we can do here now is something like this. For I in x, notice how I don't have these parentheses because we are not calling a function directly, we're calling a variable. If you try to do something like this, you're going to have a very bad time. Just understand the difference between those. And then from here, it just becomes really ridiculously simple. This is what I love about Python. Everything just becomes very simple to the point I'm almost embarrassed to just even talk about it. Because to me, because I'm an old programmer, it seems like just common sense. And there we go. Range 0 through 4. So what's happening under the hood here is it's saying for I, so we're creating a variable in x, and this variable is actually pointing to a function. So it's making this function call, getting that value back, and then it's going through each item. Now, if that last little bit hurt your brain, fasten your seatbelt. Range can get a little complex here. So we have a start, a stop, and a step. What does this really mean? Let's go ahead and do this. Let's say x equals range, and I'm just going to leave it here for now so we can read this and see what's going on. We have stop int, so that's the default, but there's different ways of calling this. You can do a start, which means the number you're going to start at, a stop, which means the number you're going to stop at, and a step, meaning how many numbers in between those two you want to jump. Let's take a look at this and see what it really looks like under the hood. So let's say we want to start at 5, we want to stop when we hit 20, and we want to take 3 steps at a time. All right, pop quiz, what is this going to look like? Let's go ahead and print this out. If you thought it was going to say range 5, 23, you were absolutely right, because beginning to understand here that this is pointing to a function, not some sort of value. But we can actually work with it now that we've assigned it to a variable called x. Go ahead and say for I in x. Remember, we're calling a variable, not a function. Go ahead and print. Okay, bonus round. Who knows what this is going to print out here? Let's see. Starts at 5, and then it goes to 8, 11, 14, 17, and it stops at 20. Notice how it didn't fire off at 20. If we said 21, let's see what happens. Now suddenly it includes that. So that's the major takeaway from here, is it's not going to include that stop. It's going to stop when it gets to there. Remember, under the hood, this is using some sort of loop. It's saying probably something that we've seen before, like this. While, and then x is less than 20. So when it gets to this 20, it's just going to break out of that loop and stop doing it. Once you understand how this works, it makes life ridiculously simple. Something like this would require a little bit of math and other languages, but Python, as usual, makes it nice and easy. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to create a simple application using everything that we've learned to this point. If you're just now tuning in, there are 13 other videos in this playlist you need to go back and watch if you don't know Python. But we're going to make a paint calculator. So we're going to determine how much paint is actually needed to paint a room. When we run this, the user is going to be presented with something like this. Paint calculator, enter wall size as width, height in feet, or press enter to stop. For the example would be 12,8, no spaces or anything like that. And they can enter as many walls as they want. And at the end, this is going to magically tell them how many cans or how many gallons of paint they need to go buy. Let's take a look. First thing we need to do is, well, set up some variables. So we're going to make a list called walls. And this list is going to exist just to hold the measurements. Second thing we're going to add is gallons. This is going to be, well, how many gallons of paint per square feet? And I'm not an expert, but I did go out and look this up on Google. And according to Google, 1 gallon of paint covers 350 square feet. I question that because every time I have bought paint, I have never bought enough and I've had to go back to the store and get it. Maybe this application will help us. And then total is going to be the total number of gallons of paint we need to go buy. We're going to use this later. Total gallons to buy. So far, our application does absolutely nothing, but that's about to change. We are going to get the user's input, and we haven't talked about this yet, but we're going to make a while loop, and we're going to say while true, and you may be going, oh, whoa, 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 you're making an infinite loop. That's true. We're going to break out of this, and I'm going to show you how. So we're going to get a variable, And we're going to use the built-in input functions. There's different ways of doing this, but we're going to use input. And I'm going to say enter wall size. Then we're going to break out of this if they don't really enter any data. So I'm going to say len of s is 0. Then we want to just call break. If you're kind of questioning what any of this is, go back and watch the previous 13 videos that I've done on this. So let's go ahead and test this out. We're going to run this, and it says enter wall size. You notice how our program's just stopped and waiting for us. Well, I'll just enter some garbage. I'm going to say cats. And it wants another. Dogs. And another. Fish. And then I'm just going to hit enter. And sure enough, it exits out. So that is the correct way of using an infinite loop to gather user input and to test when we need to break out of this loop. Now that we can get the user input, we need to actually do something with it. And before we try to do anything with it, the first thing we should do is, well, verify that what the user gave us is actually what we're hoping for, or we could have a very bad time. Remember, this whole thing started with the example of 12,8. Well, I entered cats, dogs, fish. I'm not sure how you would calculate the square footage of a cat, but I'm sure it would be interesting and probably involve a trip to the vets. But anyway, so we're going to say sqft equals, and we're going to say s.split, because the s is our variable we got from the input function right up here, and it's going to be a string. So we can treat this as a string and say s_split, and we want to split this on the comma. Again, if you have not a clue what I'm doing here, watch the previous 13 videos. But anyways, string has a built-in function called split, which you can return multiple values based off a character or sequence of character. So our square footage is going to be the return value from that split function. So first thing we're going to do is make sure we actually have two values in there. And if it's less than 2, well, we want to tell the user something bad happened. Print, let's go ahead and just say invalid format. And then we're going to break out of here. Now remember, break doesn't really care where it is. It's going to break out of this loop. Let's go ahead and test this out here. So we're going to run this, and it's going to say enter wall size, and I'm going to say, okay, 2, 6. It's working, good. 5, 7. And let's enter some garbage, cats. Invalid format, and it stops the loop and exits the program. So it is actually testing to make sure there are 2 items that is split on a comma. All right, we're not done yet. We need to, now that we've gotten the user input, convert it. Because remember, we're working with strings and we want to work with numbers. Specifically, we want to convert from a string to an integer. And this could lead to a bad time. And we're going to demonstrate that. So I'm going to say w equals, we're going to call int, and we're going to do something called casting. And I'm going to do a whole video on this later, but when I say casting, just think of a wizard with a magic wand who's going to cast a spell and turn something into something else. So what we're saying is we want to cast a spell called int, which is going to convert whatever we give it into an integer. And in this case, we are going to get that first value out of square footage. Go ahead and grab this. Give it the old copy paste. Whoa, a little too much copy paste. And let's get the other dimensions. So now we have the width and the height from square foot 0 and square foot 1. Interesting bit, if we try to do this and it's not actually a number, we're going to have a bad time. It's going to actually error out and our program's going to stop and die a horrible death. And I'm going to cover how to handle all that in another video. The whole point of this program is to do a program with what we've learned so far in the 13 videos. Now I'm going to say item, and I want to make a list with the width and the height. And we're going to add that to our walls. If in case you're wondering where I got walls from, remember it's way, way, way up here in our variables. It's just an empty list. So we're going to say walls, append. Let's go ahead and add that item in here. So now we have a list holding the wall dimensions for every single wall that they add. Let's go ahead and just print that out just to verify, hey, we did something. So adding wall. Go ahead, save, run, and let's test this out. So inner wall size, all right, 3 by 6, that's a very small wall. And it says adding wall, all right, great. So 8 by 8, let's go ahead and say 9 by 12. Now let's test out this conversion right here and watch it die a horrible death. So I'm going to say 2 by cats. Uh-oh, invalid literal for int with base 10 cats. And this looks very ugly, and it is. It's a value error. We're going to talk about errors in a future video. I just want you to understand if you get a value error, what's going on is we're basically saying we cannot convert this to a number or specifically to an int. Remember, think of a wizard with a magic wand, and we are casting a spell called int, which is going to convert whatever we cast it on to an int. Once we've gotten to this point, the only thing that's left is to really just crunch the numbers and tell them how much paint they need. So what I like to do is just tell them what they entered. So we're going to say F, you entered. That way, if there's any discrepancy, I can say, send me a screenshot of the app, and I can show, oh, no, you screwed up. You entered the wrong value here. And then we're going to say for M, M is going to be for measurements in walls. We're going to say the width is going to be M0. Remember, it's a zero-based index. And inside of our walls, we have created another list here. So we're getting this guy, the width. And we can say H1. Remember, zero-based index. That always trips newbies up. Now we're going to get the square footage. So I'm going to make another variable called S. I'm going to say that's simply the width times the height. Now I want to get some sort of value. So I'm going to say this is the S, or the square footage, times the gallons. In case you're wondering where gallons magically appeared from, remember it's all the way up here in our global variables that we created. I did Google it. 1 gallon should cover 350 square feet. So this value right here is 1 divided by 350. Not a clue if that's accurate. I highly doubt it, even though I do trust Google. And then we're going to grab our other global variable, total. We're going to say plus equals V. So we're just incrementing that. In case you're wondering, plus equal, we did cover this in a previous video. It's basically, we're saying total equals total plus the value. But we're just shorthanding it. Now we're going to drop down and go inward. We're going to dent in. So we're dropping out of this code block right here. And we're going back to the main. We're going to say print. And we're just going to tell them you need to go buy some paint. And this is how much paint you need to go buy. You need to buy. Let's go ahead, and if we just say total, it's going to give us some crazy number. So what I like to do is make it a little pretty, and I'm going to say round. And we're going to round the total by 2 decimal places. We're going to tell them you need to go buy however many gallons of paint rounded to 2 decimal places. Let's go ahead and test this thing out and see if it works. So I'm going to say 12 by 8. And let's make another one 15 by 9. Actually, let's make it by 8. That'd be weird if the ceiling was different height. And let's go ahead and say we have an 8 by 8 and a 4 by 8. Just kind of a weird shape room. And then I don't want to enter anymore, so I'm just going to hit enter. And you need to buy 1 gallon of paint. Basically, it's going to use less than a gallon. I should have some left over. I don't know how accurate that is, and honestly, I'm kind of looking at my little office here going, I think it's going to take more than a gallon to do this. So when in doubt, blame Google. But the major takeaway from this video is Even though we're only 13 videos in and we've really just scratched the surface of what Python can do, you can make some pretty interesting programming logic. We just did a simple application, which is a paint calculator telling us how much paint we need to buy. We're letting the user enter any number of walls they want. We are verifying that user input, and then we're converting that input into the correct data type, and then we're calculating how much they need and giving it back to the end user. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to continue our journey into Python 3 with an introduction to functions. So first off, what is a function? It's a block of code which only runs when it is called. So far, all the code we've written runs immediately. I mean, as soon as Python reads it, it runs it. This is going to change that. We're going to write some code and we are going to decide when it runs. This is another fundamental building block of programming, and there's a lot of theory attached to it, and there's a lot of names and terminology. So we are going to split this into multiple videos. Some key takeaways from this video, though, is that you can pass data known as a parameter or an argument into a function. You're going to hear these two used interchangeably. It gets really confusing. So down here, I put some notes. The difference between a parameter and an argument. A function parameter is the names listed in the function's definition, where an argument is the real value. That's just confusing. Why don't they just call it like a name or a value? But instead, they've got to call it parameter argument. And everyone, even myself, gets these mixed up. You'll hear some videos where I'll call it a parameter and some videos where I'll call it an argument. And I've heard people with vastly more programming experience than me switch these around as well. It's just that confusing. Another major takeaway is that a function can return data as a result. Return is actually a keyword, and we're going to cover that. Diving into theory land just for a moment here, so far we've worked with statements. And what do I mean by statements? We've done something like this so far. We'll have a statement, a statement, a statement, and Python just reads it from the top down. For example, we would like print something, maybe do a while loop. Inside that while loop, we could have like an if statement, and it's just kind of read like a book straight from the top down. But now what we're going to do is introduce a function, which is a separate block of code. It's not going to run unless we specifically tell Python, go run this code. And a function can call other functions, and so on and so on. The end result now is that we can fundamentally decide how we want our program to run and how we want it to behave. We can do some pretty complex programming logic using this. Another key takeaway here is we are subtly introducing the concept of scope. Everything that we've done so far has been on what's called the global scope, and each function, each block of code, has its own scope. Scope is something we're going to dive into detail in a future video, but just understand we are subtly introducing this. So let's test this. Let's go ahead and define a function. We're going to say def, which is shorthand for define or definition. And we're going to give it a name. And then we have those little parentheses. If we forget those, we're going to have a bad time. We need the parentheses. And then in there, we would define any parameters. We're going to keep this first one very basic, and there'll be no parameters, but we still need the parentheses in there. And then colon, and hit enter. And notice how most IDEs will do this automatically, where they will drop you down a line and indentate you automatically. Then we can just fill in our code. We can have pretty much anything we want in here. I'm just going to put a print statement just for testing. And we're just going to say this is a function. Now we can work with this thing as needed. Okay, this last one was a little bit simplistic. Let's ramp up the difficulty here. So we're going to define a function with parameters and return a value. In the last video, we made a paint calculator, which calculated based off the square footage how much paint we needed. We could have very easily used functions in that, and most programs would have. So we're going to make a function called SQFT, which is shorthand for square footage, parentheses, and let's define some parameters. I'm going to say W for width and H for height. Now we can add our programming logic in here. So the value we're going to return is going to be simply the width times the height. Now we're going to use the return keyword to return that value. Notice how these are both very simple, but they're fundamentally very different. This first one basically has no parameters and runs some code, and once it's done, it just jumps right back out of here. This one, however, we have to give it 2 parameters, and there's going to be some logic, and it's going to return a value. It's up to us to decide if we want to actually work with the value that's returned. It's not actually mandatory. We can just ignore it if we wanted to. But this is what I mean by functions can get very complex very, very quickly. We have 2 very small functions that act completely differently. Let's take a look at how this actually works. How would we call a function? Now, what do we mean by call a function? Remember, this code is not going to execute until we specifically tell Python to run it. Let's go ahead and run our program as is and see what happens. Absolutely nothing. So what it's doing is it's reading from the top down. It's saying define test, define SQFT, and it has this queued up in memory ready to go, but it's not actually going to use it until we tell it to. So let's tell it to run it. Most editors are going to be smart enough to tell you, hey, this is an actual function. And in VS Code, this little block means it's a function. Notice the block because it's a block of code. Now, if I just hit OK or enter or click on it, it does nothing. This actually will not run. We have to add those parentheses. Now, suddenly see how it says def test, and it knows we're trying to call that function. Let's go ahead and run, and ta-da, this is a function. So Python is reading this from the top down, defining test, defining SQFT, getting here and saying, oh, it wants to actually call this. There are no parameters, so we don't have to supply any arguments. You may be wondering what the big deal here is. Why would we even mess around with functions? I mean, we could have just printed this out. Well, let's take a look at a specific situation. Let's say we wanted to call that function multiple times. We're going to say for x in range, and we're going to say range 4. So we want to call that multiple times. Now, we could just write this out like this 4 times. We could do something like this. And you'll see people do that. However, that's not the best way. What if your boss comes and says, well, I want you to do that 20,000 times? Okay. You're going to have a very big file calling that out. There's a much simpler way. You would say for x in range, and then you would call this. So what we've done now is we've created a loop, and we have a lower boundary and an upper boundary, and it's going to call it. So we have not created an infinite loop. It will call our function. Let's see this in action, and ta-da! There it goes, right there. So that's the power of a function. You can define a block of code and then decide when and how it runs. Now, in typical fashion with these videos, I do like to ramp the difficulty up here. So we're going to call a function with parameters. And this is what I mean by this is going to get confusing fast. Remember our little buddy, the SQFT function, which we defined, which we haven't really worked with yet. let's go ahead and say x equals sqft. Now we have some parameters, and it's smart enough to know that it's a param. So we have to feed it some information now. I'm going to say 12 by 8. Bonus question here. These numbers, are these parameters or are these arguments? Well, they're arguments. So these up here are the parameters. They're in the function definition. The values we're feeding it are arguments. And you're going to get people that will, no pun intended, argue this all day long because people get it so confused. All right, let's go ahead and print out the square footage. So the square footage is 96. Now you see just how powerful this is. You can define some sort of logic and then call it on demand when you need it and get the value back from it and use it accordingly. Just a quick recap, what we've talked about in this video is, well, functions are amazing. They're also very complex. It reads from the top down. You have to use the DEF or the def keyword to define a function. Functions can have 0 or more parameters. Those parameters have to be fed arguments. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Hello again, everyone. This is Brian. Let's continue our journey into Python 3 with functions and scope. This is a theory-heavy video, but we're going to try and make it very simple. So we're talking about lexical scoping, sometimes known as static scoping, which is a convention many programming languages use that sets the scope or the range of functionality of a variable so that it is only called from within the block of code from which it was defined. However, scopes can be nested inside of each other. So you ever have like a box and a box and a box and a box? That's kind of what we're talking about. And that's why this really will hurt your brain if you're not paying attention. So let's dive in and take a look. So let's take a look at lexical scoping. And I'm going to just put a square out here. I'm going to make it nice and big. And let's go ahead and give it a color. Let's say this is going to be some sort of green. Doesn't really matter what it is. So that would be a block of code. And actually, you've been working in this whole time. This has been called the global scope. Everything we've done so far has been in one giant scope called the global scope. There's other names for it as well, but that's basically what we're talking about. Now, we can actually take another one. Let's go ahead and bring this all the way to the front, and let's set this as a different color. Let's say blue. And this is a different scope. Think of this like a function. Doesn't necessarily have to be a function. It could be like a while statement or an if statement, something like that. So what we're getting at here is you have this big overarching global scope, but then you have these subscopes. Now, to make things a little bit more complex, let's say we have this scope here that's inside the global scope. Let's call this a function, for example. We're going to go ahead and make another one. And let's give this a different color. This is what we're talking about. So you can have a scope with a scope in a scope, like a box and a box and a box. And it gets very, very confusing. Now, this guy here, let's just actually move all of this down here and make it graphically easier to understand. You have your global scope, you have your function scope, and then you have another little, like a statement in here. You can define something in the global and use it all the way down through here, even down into this statement. You cannot, however, do the reverse. You can't define something in the statement and use it backwards up in the global scope. So this is why it gets very, very confusing. And I think graphically, this is probably one of the better ways of really defining this. Just understand that you can have a scope with a scope inside of it and another scope inside of it. You can define something, and as you get more granular, you can use whatever you defined. However, you can't define something at the very granular level and use it higher up. All this talk about scope is, well, confusing. So let's just dive in and look. First thing we're going to talk about is the global scope. This is probably the easiest concept to understand because we've been using it this entire time. That's right. So if I say name and then just whatever your name is, we have now created a variable on the global scope, meaning anything in this application can now use this. This is extremely cool and it's extremely easy. So let's demonstrate this global scope. Functions can access the global scope. So let's go ahead and define a function. Let's just call this test1. Very descriptive name, I know. And we are going to use this variable, which we created in the global scope, in this function. And remember, this function has its own scope that we're now defining. Say print. And to test this, let's go ahead and let's call this function. My name is, and then the name from the global scope. Makes it super, super convenient. However, what we're going to show in this video is that this convenience comes with a cost of complexity, and there's some issues you can definitely run into. Let's do the reverse and show some problems we can run into. So for example, the global scope cannot access a function scope. Seems absurd. We define the function in the global scope. We should be able to access it, but it doesn't work that way. We're going to say x equals 10. Let's go ahead and define a function. Let's call this test2, very super descriptive name. And we're going to say x equals 50. Now you may be going, wait a minute, there's two x's, so it's the same x. But it's really not. Let's go ahead and take a look here. And we're going to say function scope, and then we're just going to print out that value of x. Go ahead and go down here. Let's call this function, just so it's going to print that out. And then we're going to say global scope. All right, so pop quiz, x equals 10, x equals 50. What is this going to print out? It's going to say function scope x, global scope x. Let's take a look. So if you thought both of these would be 50, you are wrong. This is what's going on here. We have x in the global scope. We are now creating a new variable in the function scope and assigning it a value of 50. These are two different variables, so it's treating them differently, even though they have the same name. Oh, this is confusing, but it exists for a reason. It's called name collision. If you have a variable with the same name, you don't want to overwrite that. Let's say this was some magic number, like a password or something, and then we went and kind of goofed it up in a function somewhere. We don't want to break the functionality of the application. So this actually exists to protect us from ourselves. Okay, let's dive deeper and deeper still. So we're going to talk about global scope, function scope, and statement scope all in one. And this is going to really, really tax your brain here. So we're going to make a global variable. We'll say x equals 15. And let's go ahead and just put a print statement, print global x, just so we can see what's going on here. There it is, 15. Now we're going to define a function. So I'm going to say def s3. Ever descriptive name, I know. And I'm going to make x 0. What have we done here? Well, we've created two different variables. We've talked about that a little bit here. And we're saying this variable is 15 and this variable is 0. So I'm going to, through the magic of copy and paste, I have some notes off the screen here just to save a smidge of time. We're going to print these out. Let's go ahead and call this just so we can see what's going on. And sure enough, global's 15, function is 0. Things are working the way we'd expect them to, even though it's a little bit confusing. This exists to keep us from hurting ourselves because you have a concept called name collision. If this were a password or something crazy like that, we wouldn't want to overwrite that and then screw something up somewhere else in the code. Okay, now let's take this a bit further. And we're going to say for I in range, and we're going to really make some people mad here because we're going to do some things we really should not be doing. We're going to say x plus equals 1. Now we're going to say y equals x times I. So far, everything's good, but now this x. You notice how we're 3 layers down. Which x is this really? Well, this is the confusing bit. So this x is actually borrowing from our definition. It's going a bit higher. So think of any time you see the def keyword, we're actually putting some sort of wall or a shield here. Let's actually just draw a line. So it's like we're setting a boundary right there saying you will not pass if I've already named that. Now let's go ahead and do something we probably should not be doing. We have statement X, statement Y. This is perfectly fine. Let's go ahead and run this and see what this looks like. Sure enough, it's working as expected. We can see that statement Y is actually multiplying. Everything's working good. Now let's do something very, very horrible. We're going to grab these and we're going to go backwards through the scope. VS Code adds these beautiful little lines to tell us where in the scope we are. You can actually see it's like a bubble here. So we're at the global, we're at the function, we're at the statement. Now we're dropping back to the function scope. Let's run this and see what happens. You notice how it does work, and it's because we're in this little boundary here, and it thinks it's a safe little playground for us to work at. However, you can definitely break some things and you can cause some issues. I would strongly advise against this. Future versions of Python and even current versions of Python, you can run into some issues, some name collisions, and you can break your code. Now, let's go ahead and take this same concept here and try to go backwards still. And let's go back up to the global scope. So we want to see X and Y. We've defined Y here, and we're able to go backwards into the function scope. Let's see if we can go backwards up to the global scope. And sure enough, we cannot. Name error, Y is not defined. Why are we getting this? What's going on here? This definition is a block of code. It's its own individual little scope. And I've got these arrows here. Global goes to function, function goes to statement. You should not go backwards. However, we've seen you can violate that principle and go backwards, even though we really shouldn't be able to. Or I should say you don't want to, because you can cause some problems. Because if you take that logic and try to go backwards all the way up to the global, you're going to get a name error. Y simply does not exist out on the global namespace. You need to be a little bit careful when you're working with scope and really wrap your brain around this. That will cause problems time and time again. I see people constantly doing this going, well, I defined Y, why can't I use it? And then you have to explain scope to them. Let's run that again, and everything runs beautifully because we've commented this code out. Now, all this talk about scope and functions and all that can get a little bit confusing. So one thing you need to really understand is that functions do not share scope with each other. Let's go ahead and test this out. So I'm going to say def cats, better name, I like cats. So I'm going to make a variable called z, and I'm going to make this 1. Now, what you need to understand, I mean, really, really pound into your brain, is this only exists in this function. Let's grab literally that function, make another one, and let's call it dogs. Now, z is 3. What have we done here? You see two different functions with two different z's. These are individuals. They are not the same variable, and they cannot talk to each other. So, for example, if I do something like this, what's going to happen? Well, we're going to call cats, we're going to call dogs, and then we're going to get some sort of undefined error. And Visual Studio Code is already smart enough to know it's not defined because these only exist up here. Now, to kind of pound that in here, let's grab this. Let's get rid of these guys. Now we've commented this out. Let's save that. What's going to happen if we call dogs right now? Let's go ahead and say, notice how it's already going, uh-oh, you're going to have an undefined variable. And let's test that. So sure enough, print z, name z not defined. Remember, when you see not defined, it means it simply doesn't exist. Even if we were to call cats, see, ta-da, does not exist. So they do not share scope with each other. If you're ever confused about this, just simply take your IDE and you can collapse the code down if your IDE allows it, and that's what we're talking about. These are individual islands. They don't talk to each other at all. Now, to wrap this up, you may be asking yourself, if functions do not share scope, how do you share information between functions? Well, functions can return values, and we've talked about this a little bit here. So let's go ahead and generate some lucky numbers. I'm going to say define a function called numbers, and we want actually a parameter of steps. Let's go ahead and we're going to say L equal range, and then we want to go from 1 to 20 using the steps. There we go. Go ahead and print these out. We're going to say for I in L. And we're going to go ahead and print I. And this is just so we can see on the screen what's going on. Now we're going to drop back down and we're going to say return. And we want to return that little list that we got from this range here. So what's going on under the hood? We're saying define this function who has a parameter of steps. We're going to say L is range 1 to 20 using steps, I to L. So we're just going to print those out, and then we're going to actually return all of this information we generated. Now, a real-world program would have vastly more complex logic. But now we're going to use that function and get the information out of it. So we're going to make the lotto function. Everybody wants to win the lotto. I know I do. And we're going to say z equal, and we're going to call that numbers function with a step of 3. You may be going, now wait a minute. Numbers doesn't exist. We can't use it. If you're ever confused and your IDE allows it, collapse the code down. You can see numbers exists on the global scope. Therefore, we can call it. We're going down, not up. All right, so now that we have this, we can say for x in z. And let's go ahead and print out our lucky numbers. And we're just going to print that out. Now, let's go ahead and call our lotto function. Notice how we're not calling numbers directly. We're calling lotto, and lotto is going to call numbers, run that code, and return the value, get the return value, and then use it. See, there's our lucky numbers. Major takeaway from this, we've talked about scope, and we've talked about it in depth. Scope can be a little bit confusing, but just remember, it's going to go from global to function to statement. You should not go backwards, and if you do, you're probably going to run into some sort of problem. Although you'll see people do this all the time in Python, and it drives me bonkers because they're going to eventually run into a problem if they haven't already. And a function can call a function, and you can get values from those functions and use them locally. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Okay, this video we're going to talk about functions in depth. Specifically, we're talking about arguments and parameters and different ways of doing things. For example, you can have a function inside of a function. That's crazy. So let's dive in and take a look. Okay, let's start off nice and simple. We're talking about no arguments, no parameters. We're just going to do what we've done before, just so we can have a good base to start with. We've done this multiple times by now, so we're going to just print this out, and we're going to say normal function. This is kind of our starting point here. We're going to go on a little bit of a journey, and what we're going to do is we're going to dive into the mouth of madness and just see how crazy this can get. So we're now going to just call this. You notice how I put this right here. These are escape characters. Return line feed with some dashes and arguments. We're going to break this up because we're going to have a lot of output in this video and we want to be able to see what's happening here. So I'm going to just copy and paste these as we go. We're calling this function and it works as expected. If any of this seems unclear at this point, you need to stop watching this video and go watch the previous 16 videos to really wrap your head around what we're going to be talking about, because we are going to no holds barred, just dive right into the deep end. Let's take the training wheels off. We're going to talk about positional and keyword arguments. Okay, this is where it's going to get really confusing really fast. So we're going to make a function called message. We're going to say name, message, and then we want an age. So we've got a couple different data types we're going to be working with. Pretty clearly, it's going to be like a string, and an int. So we're going to say print hello, and then we want the name followed by the message. You are, and then however many years they tell us. So fundamentally, this doesn't seem like rocket science, but we can start doing some really, really crazy things. So I'm going to just put that out there, positional keyword arguments. So when we run this, we'll see the output broken up. Let's go ahead and say message. And let's call this as you would expect it. Now, what we're doing here is called positional. You notice how there is name, message, and age. Those are the positions. Think of this like a list. It's zero base, so 0, 1, 2. We don't have to give it an index. It's smart enough to know what the index is. But I'm going to say Brian. Let's say good morning. And then let's give it an age. Let's say I'm 22. Boy, I wish I was 22. I'm really not, but and that's positional. Go ahead and run this and we'll see, sure enough, hello, Brian, good morning. You are 22 years old. So it looks great. Let's grab this and let's play around with it a little bit here. We're going to use positional, but we're going to use the wrong order. Let's go ahead and screw this up. So I'm going to say 22 and good morning. So really what we're doing is we're switching these around here. The output suddenly makes no sense. Hello, Brian, 22. You are good morning years old. That makes absolutely no sense. It's like a serial killer wrote that or something. All right, so what we've done here is positional, and we've screwed up the order. So how do we fix that? We use what's called keywords. So we're going to do the same thing. We're going to say message, And here, we're going to say MSG equals, and you can see this in Visual Studio Code. It's got that parentheses and little bitty block there. It's smart enough to know that we are trying to call the parameter message with the argument of good morning. Now you notice right off the bat, we are completely disregarding the order because message is, well, the second one, and we're giving it first. As you're about to see, it really does not matter. Say age equals, say 46, and then name equals Brian. Let's go ahead and run this. And sure enough, it says, hello, Brian. Good morning. You are 46 years old. So now it's working as expected. We don't have to give it a specific order. We are working with keywords. And I wish they would have called this parameter arguments or something like that, but basically it's keywords. So what's happening is Python is taking these parameters here and turning them under the hood to keywords, and it has some sort of internal list, and it's saying, hey, if you give me a keyword and pump it in there, it will just magically know how to line those up and in what order they need to go into. You can also do both. So let's just grab this guy. Let's grab this. I'm going to say Brian, and then let's go ahead and flip these around. So you can mix and match these as you want. So you can say positional followed by keyword. Let's run that, see it in action. It doesn't matter which way you do it, it just works. Extremely cool, and I absolutely love that about Python. Let's make this ever complex still. We're going to talk about internal or inline functions, and there is a subtle difference between internal and inline. We're talking about an internal function, which is essentially a function inside of a function. So we're going to say counter, and inside of counter, we're going to immediately call another function or create another function called display. We want to say count equals 0. So really all we're doing is we're saying a function in a function. And notice how it's smart enough to drop us down a line so it knows it has its own scope. And we're just going to print this out, and we're going to say internal. That way we know. I was going to do it something else, but let's just say internal so we know where we are, and then print that count out. Under the hood, this is really complex, but it's super simple the way we do it. We just have a function. We've defined another function. That function gets its own little scope. And we can now drop out here and say something like this. For x in range, say 5, nothing too drastic here. Let's go ahead and call our function display, and we're going to call that with x. So we're saying for x in range, so it's going to do that 5 times, and it's going to say call display 1, 2, 3, 4, 5. Interesting how that works. Let's see this in action here. A little bit of copy and paste action for my notes. We're going to talk about internal functions, and we're going to call the counter function. Sure enough, 0, 1, 2, 3, 4. I always forget that 0 base. Always trips me up. Okay, so what we're doing here is calling a function which has an internal function, which is calling it internally, and it's just kind of going around inside and doing all this madness for us. So let's take this counter, grab this internal function called display, and try to call it. So we're now going up a notch. Now let's just see if we can call this. Sure enough, we cannot. We get a name error. Display is not defined. Remember, when you see is not defined, that means Python has no idea what this is because it does not exist in the scope we're working in. So you guessed it, you collapse that down, display doesn't exist. It's inside of this scope over here. Gets super cool, but it's also super confusing. So if you're going to use this, be very careful about how you try to call it, or you're going to get some sort of error. All right, let's give you a nightmare scenario. Boss walks in, you're a newbie Python programmer, and he says, I want you to make a function, but I'm not going to tell you how many arguments I'm going to give you. I want your function to automatically figure it out. Well, what we're talking about here are star args, and star stands for wildcard. This is a positional variable length argument. All right, so what are we talking about positional? Well, we've talked about this a little bit before up here where you have a position, and that's not so much what we're talking about. We're talking about this right here. We're going to say def, and let's go multiply star args. We could name this whatever we wanted. Now, we're going to feed that a bunch of arguments, and they're going to be based in a position. So let's go z equals 1 for num in args. And let's go ahead and print that out so we can see what's going on. Now we're just going to multiply that. We're going to say z is multiplied by the number. Now let's go ahead and print this out. A little bit of copy and paste action from my notes just so graphically in the output we can see where we are. Let's go ahead and call this. I'm going to say multiply, or multiple actually, and we're going to say boss gives us 3 numbers here. Number 1, number 2, number 3. This is what I mean by positional. It's going to take the exact order we give it, 1, 2, 3. We could switch this around and say 2, 3, 1. And you'll see the position changes, 2, 3, 1. All right, very, very simple, very easy to wrap your head around. The major takeaway here is we're not constrained. We can take this out to just some ridiculous level. We could do something like this. See? Works as expected. Let's take that same nightmare scenario where our boss is just a complete jerk, and we're going to say, okay, he's going to come in and say, I'm going to give you random information. I'm not going to tell you how much information I'm going to give you, and I'm not going to give it to you in a specific order. Yes, that's a nightmare. So what we're talking about is keyword args, which is basically the same thing, except for instead of positional, we're using a keyword. We've talked about keywords before, way back up here, how we can mix and match and do all this other cool stuff, but we're going to try and dumb this down and make it a little bit simple because, yes, this can get complex fast. Major thing to note is there are 2 asterisks here, 2 stars. So let's go ahead and say def profile. This is what the boss is going to do to us. He's going to say, I'm going to give you a person. And the person is just going to be a bunch of data, and you need to figure out what to do with it. So we're going to print out our person. Now let's jump out of there for just a moment here. And I'm going to say, add our little delimiter here so we know we are in our output. And let's go ahead and call this. So I'm going to say profile. Now it's smart enough to know it's using keyword args, so it gives us that double asterisk. And now it's on us to define what information we're going to give. And I'm just going to say name. And if you're wondering where I'm getting name from, I'm literally just randomly grabbing something out of my mind. It doesn't matter what we give it here. So we'll say Brian, and then let's go ahead and say age equals 46. Let's run this and see what happens. We're printing out this person, so notice it's now converting that into a dictionary. That's right. So now we can just use this like a dictionary. It's extremely cool the way this works. All right, let's go ahead and use an internal function. I'm going to say f display. Let's go ahead and display k. Now we're going to do a little bit of test here. We've covered this in our dictionary video here where we're going to say if k is in the person keys. Then we want to print this out. And if that's super confusing, I would highly encourage you to go back in the playlist and watch the video where we cover dictionaries. So now we can just work with this dictionary directly. So we have a function in a function. This internal function display is just going to say if this keyword is in person keys, because remember it's converting it to a dictionary, then go ahead and print out the key and print out the value. Now that we have our little internal function, let's go ahead and call it. So I'm going to say display, and let's give it a keyword name. Now notice how we're actually hard coding this. You can do different things like this. So I'm going to say name, age, and we were in a meeting and they were talking about adding a pet, but they didn't actually do it yet, which is why we're saying if the keyword's in the keys. Because we've done this if, we don't have to worry about not defined. It's going to print out name, age. Okay. Someone in marketing comes back and goes, wouldn't it be really, really cool if they had a pet? So let's go ahead and add that in there. Now you can see Brian 46 and cat, and we have our two different calls here. So we have the first one that does not have the pet and the second one which does have the pet. And it just works the way you would expect it to. And we can now test this for other things. So for example, let's say food equals pizza. What have we done here? Well, we've added a keyword that we're not using. It does not crash our application because it's saying if it's in there, and we haven't even called it. So let's do the opposite here. Let's go here and let's say I don't know what that is. We're just goofing around. Doesn't crash because it's not in there. Very cool, very easy the way this works. Super simple to wrap your brain around. But what we're really trying to drive home here is these are keyword arguments, not positional. The position simply does not matter. Okay, let's wrap this up with a brief conversation about Lambda or anonymous functions. You're going to hear them called Lambda functions. They're actually not Lambda functions. They're anonymous functions. We use Lambda to create an anonymous function. So let's go ahead and define this real quick here. So first things first, we're going to make a normal one. Just as a point of reference, so I'm going to say def, and let's call this make sqft, so we're making the square footage. We're going to say the width, the default, and the height with the default. And we're just going to return the width, the height. So we're just really getting the square footage here. Super simple, super easy to understand. Go ahead and print this out. I'm going to say print. Actually, I'm going to pause for just a second, and we're going to add in our little delimiter here so we can see it in the output. All right, back to what we're working on here. We are going to print out the square footage, and let's go ahead and do this both ways. We can say width equals, trying to think of a good number here, 10. The height, anybody out in the audience, anybody, let's call it 8. Why not? We can also just say print and then make the square footage, and let's say 15 by 8. We can call it both ways. Go ahead and run that. You can see, ta-da, there's our numbers. Now let's use the Lambda keyword to create an anonymous function. I intentionally called it a Lambda function, even though they're anonymous functions, because you're going to hear people say, well, I'm going to create a Lambda function. We're actually using the Lambda keyword, sqft equals. So what are we doing here? We're making a variable. We're going to say Lambda, and let's go ahead and define some things. Now, I want to kind of slow way down. I'm going to plop a note in here. There's a certain format we have to do this in. So we have a variable, the lambda keyword, a list of one or more variables, and then some code. So we're saying lambda. Let's go ahead and say width equals, and let's say 0, height equals 0, colon, and now we're going to our code. So if you're looking at this, really what we're doing is we're saying lambda is going to replace all of this. Then we have our information, and I specifically named these the same so you could see them highlighted on the screen. Let's do that again. So now we have our parameters. Now we have our code. Now, if we wanted to, we could just grab these, and through the magic of copy and paste, instead of a function call to make square footage, we're going to just call this variable SQFT, and it functions exactly the same. See, 8120, 8120. This is just witchcraft. I mean, this is like voodoo magic from old school programmers like me. But so what's really going on under the hood is when you call lambda, Python is basically making this, but it's doing it all in one line. So as a programmer, it makes your life a little bit easier because it's all in one line, and you just have to remember this variable name. And it exists out in the global scope, so we can treat it just like a function. If we mouse over this, you see it's smart enough to know that it is a call to lambda. So it is making an anonymous function. I personally am not a huge fan of anonymous functions, but they do have their place out in the programming world, especially if you get into like GUI programming and socket programming and things like that. You'll see people use these very heavily. Some people love them, some people hate them. My personal preference is I like to actually define what I'm going to use rather than relying on some crazy witchcraft. But I don't want to steer you away from this. Lambda is very powerful and very useful. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to talk about packing and unpacking data. Now, what are we really talking about here? Well, we have a problem with arg and keyword arg is that we cannot easily use lists, sets, tuples, and dictionaries. Instead, we have to pack and unpack the data. And that's what this video is really going to dive into. Let's take a look. So let's look at packing data. And this sounds like it's going to be super complex, but actually in the spirit of Python, it's super, super easy. So I'm just going to make a function called pack. And we're going to make a parameter here called nums. And this is a star arg right here, which means one or more variables. And in here, we're going to say, go ahead and print this out. Just so we can see what we're actually getting. Now let's go ahead and call this pack, and I want to pack 1, 2, and 3. Let's see what's actually going on here. Sure enough, it has made a tuple. From here, we can very easily say for x in nums, and then do something like this. Get those individual numbers out of there and see exactly what's going on inside the tuple. Super, super simple to wrap your head around. This works as expected. However, there are some issues here. And let's go ahead and take a look at how we would unpack the data. Okay, packing data is, well, simple, and we've done this before. But what if we try to do the opposite and unpack the data? What are we really talking about here, unpacking? So let's go ahead and make an example. Let's say def unpack, and let's give it 3 variables, A, B, and C. From here, I'm just going to print out unpack, that way we can see what's going on, followed by print. And we can just grab those directly. Super simple, probably the simplest function we'll ever write. Say BC, and of course line those up to B and C. Just looking at that function, it's pretty straightforward, pretty obvious what's going to happen. But now let's introduce a problem. I'm going to say num equal, and I want to make a list of numbers, 1, 2, 3. If we say unpack and just give it our variable, what do you think is going to happen? Well, IntelliSense is already telling us there's going to be a problem here. No value for argument, and it says, uh-oh. See, missing 2 required positional arguments, B and C. Wait, what? But I gave it a list. There's 3 elements in this list. What's really going on? Well, what's happening is we have to tell Python specifically, take this list and unpack it. And we do that just by adding a star right here. Let's try that again. I'm going to clear this out. And now it magically works. So what we're driving home here is when you see this asterisk, this little star, no matter what context, whether you're using args or keyword args, or you're using it up here as a parameter, or you're using it as an argument, think of this as telling Python, you're going to be packing or unpacking data. And Python, I want you to take care of all the messy details so I don't have to. As with everything programming related, it's not that simple. Let's look at another issue, the dictionary issue. Let's go ahead and make a dictionary. So I'm going to say D equals dictionary, and I'm going to say name equals Ryan, age equals 46, and pet equals cat. Feel free to put in whatever values you want. You just need a dictionary with 3 elements. Now let's go ahead and say print, and say packing dictionary. And let's go ahead and try to pack this. So we're going to call our pack function, and we're smart enough to know now that we need to put that asterisk there because we're going to tell Python, you deal with the details, and we're going to put our dictionary there. Go ahead and clear out our results down here and see what happens. Uh-oh, we've got a problem. It's only getting the keys. It did get the keys successfully, but it's only getting the keys. And remember, a dictionary is a key value pair. So, that is frustrating. Let's try the opposite. Let's try to unpack that. And let's go ahead and say unpacking. Handy little function name right there. And run again, unpack, and again, A, B, C. It's only getting the keys. So you're absolutely right. We have to do it a special way for dictionaries. Let's take a look. Looking at the dictionary issue, how it's only getting the keys, we have to treat this special. So we are going to look at an example of how to pack a dictionary. Now, when you say pack a dictionary, I get this image of putting a dictionary in your backpack and going off to school. And that's kind of what we're doing here. So we're going to say define pack a dictionary. And let's go ahead and say we want to do asterisk asterisk nums. Notice the double asterisk. Asterisk stands for wildcard. So we're telling it we're going to get 2 things. And if this looks eerily familiar, it's because we're talking about, you guessed it, keyword args. A dictionary is nothing more than a key value pair. So this is exactly what we're talking about, keyword args. Let's go ahead and say print. And let's actually print this out. I want to see what we're being fed here from Python land. nums equals, and then let's just print this out. Now let's go ahead and call this, and I want to say, let's go ahead and feed it some arbitrary data. Just make up whatever you want. As long as you got 3 values, it doesn't really care. I'm just going to say name Brian, age equals 46, and pet equal cats. Run this, and sure enough, nums is equal to, see these little squiggly lines, a dictionary object. So it's automatically done this for us. Basically, under the hood, what it's done is it's called the dict function and converted all those keyword arguments into a dictionary for us. From here, it is ridiculously simple to work with. I'm just going to say print f, and let's go ahead and say packed, and we want, actually, we're going to do a for loop instead of pulling these out one at a time. 4k in nums. Last minute change of plans here. So there is our keyword, and then we want to say equals and give it our key. There we go. Save run. Let's see what this looks like. Sure enough, packed name, age, and pet works as expected. As long as you have that double asterisk in there, you now have access to the entire object as a dictionary. Just to wrap this whole thing up, let's do the polar opposite. We are now going to unpack a dictionary. So let's go ahead and say def unpack dict. And boy, that's a funny name. I'm probably going to get some flack in the comments about that one, but name, age, and pet. We're just going to stick with that kind of little paradigm there. And let's go ahead and say print. We're going to unpack a dictionary object here. Let's go ahead and say print. And you guessed it, it is just ridiculously simple to do this. Do the magic copy and paste. I'm going to speed this up just a smidge. All right, now to call this. Well, how would we actually go about calling this? We have a dictionary object out there. So let's go ahead and reuse that dictionary object. In case you're wondering, it's this guy right here. And I'll actually just grab him and bring it right here. Just recreate the wheel. It's already set, but I'm going to set it again just so we can see it on the screen. And we're going to unpack that dictionary object. Because we're using a dictionary, we need the double asterisk telling it, hey, we are working under the hood with keyword args, and watch this thing in action. So it's going to create a dictionary, and then we are going to tell Python unpack this into these. See? Ta-da! Unpacking a dictionary. Name Brian, age 46, pet cats. So this video, well, seemingly simple, we're actually doing a lot of work under the hood. I should say Python's doing all the work for us. We are packing and unpacking data. We've given examples on how to pack and unpack lists, sets, and tuples, and how to pack and unpack dictionary objects, and some of the issues that arise. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Okay, functions and arguments. Functions are really cool, but wouldn't it be cooler if you could use a function in a function's argument? What do we mean by that? So let's say we were going to do something like this, def test, and then in here we would do something like def test2 or test1 or whatever we wanted to do. Not exactly how we're going to do it, but yes, we are going to use functions as arguments. Let's dive in and take a look. Let's dive right in here. We're going to look at a function in an argument. It sounds a little squirrely, but let's take a look here. So I'm going to say def test, and we're going to have some parameters here. I'm going to say name, age, and pet. We've seen that kind of before in a previous video. Go ahead and print these out. So I'm going to say print. Do the magic copy and paste. We can speed this process up just a little bit. This is going to be a super, super simple little function here. So we're just going to print out name, age, pet. There was vastly easier ways we could have done that, but I just want to really print that out one line at a time using the information we've learned so far. So from here, we're going to make another function called getData. And this is pretty common, not just in Python, but pretty much every programming language out there, where you'll have one function that returns some type of data and another function that actually does something with the data. So here we're going to return a dictionary using the, well, same kind of data pattern here. So I'm going to say Brian, enter whatever age you want. I won't tell anybody if you enter, something much younger or older, if you're into that. I don't know. So it's just going to return a dictionary of name, age, and pet. Now we have some fundamental problems here. For example, how do we actually use these two together? Well, there's the standard way, as I call it, which you would just call this standalone getData. But now you have to feed it in like this. Test. And you have to do this really long, annoying you got to get the order right and all this other fun stuff, which is really not that fun at all. And you could do that all day long. And of course, if you change one thing, you've got to change everything else, and it becomes just a royal nightmare, but it does work. We did look at an easier way with packing data, or unpacking data, I should say. And we're going to say test, and now we're going to call getData. But there's a fundamental problem here. If we call it like this, and we're actually calling that function, we are returning a dictionary, but now we need to unpack it. Example, if I just run it, it's going to say missing 2 required positional arguments, age and pet. So now let's just go ahead and tell Python to unpack that. Save and run. Ta-da, now it works. And it's very simple, very easy. You can do it all in one line. Super cool the way that works. Okay, so we're going to cover something a little different. It's a function as an argument. We've already covered a function in an argument right here, where we said test, and then we've called getData with these parentheses, and we had to unpack it. And we've got all these special characters in the special order that we got to get just right, or nothing works. We're going to do something a little bit easier. We're going to say def, and I need a good name. Let's call it funky. Why not? I don't know what name to give it. So we're going to call it funky. And we're going to have a variable called data. So far, everything's very abstract. Nothing's really defined. We just have a variable called data. And we're going to make another variable called d, and it's going to be the result of data. Notice how data is being called like a function, even though it's also a variable. Other languages, you would call that like a function pointer, but basically what's going on is we're saying, grab some function and then call it. Doesn't matter what we name it. We could name this kittens. And then d is going to be the result of kittens. The name really doesn't matter. What matters is we are going to call this as a function. And Python is smart enough to know, hey, that variable is a function pointer under the hood. Do something with it. So we're going to go ahead and print out d. Now to do this, I'm going to say funky, and we're going to reuse our getData function from up here, which is just going to return a dictionary object. So here is the important bit. I'm going to just say this. Notice there's no stars, there's no extra parameters. It doesn't look like this. It's just the word getData. And I'm going to actually put a special note right there. Let's go ahead and run this, see what it looks like. So this is the result right here. It is our dictionary. And in case we are just super concerned with that, we can say D equals, and then D, save run just to verify D equals blah, blah, blah. So what's going on under the hood here is we are saying our function is going to have a variable. And we're going to take that variable and now treat it like a function. And Python's smart enough to go out and say, okay, funky is getting this guy right here. And we're now converting that to an argument for our function. That is extremely cool. As long as everything just works, we can then go ahead and do something like this. Let's say print. And we can do this a number of different ways. I'm going to do it the long way just because why not? And let's go ahead and go D. And we got to worry about those single double quote issues. Again, there are other ways of doing this. Age. In case you're wondering where I'm getting these and typing it horribly, it's actually from our dictionary object up here. So I know we have a name, an age, and then a pet. So let's go ahead and grab the pet too. Could have done this a number of different ways. We could have done a for loop. We could have, tested to see if it was actually in the dictionary keys, grab the item, however we wanted to do it. And ta-da, just works. Main takeaway from here is we can actually use a function as an argument and then use that variable as a function. Very cool the way that works. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian. We're going to continue our journey into Python 3 with the global keyword. This is extremely cool, it's extremely easy, and it solves a complex problem. For example, we've seen this code before. X is 1, we have a function x is 6. If we run this, what's going to happen? Well, let's find out. So we have 6 and 1. Basically, x is two different variables, and they're being treated different because it's two different scopes. Remember, whenever you're defining a function, you're actually defining a scope. So what the global keyword allows us to do is actually modify variables at, well, you guessed it, the global scope. Let's dive in and take a look. Okay, in case you skipped that video on scope, what we're really diving into here is, well, blocks of code. We're defining a function which has its own scope. The problem is Python is lexically or statically scoped, which means if we run this, we have two different variables. However, this is frustrating. If you comment this out, it's going to access the global scope. So what we want to do is to be able to access and modify, and that's what the global keyword does. So first things first, now that we understand that basic premise, let's go ahead and test this code. Sure enough, 1.1, we can access at a higher scope. Let's figure out how to modify. Let's go ahead and make a global variable. Ta-da, that's it. It's really that easy. Just because we put it on this very first line, there's no padding, this is just right at the edge of the file here, that is now considered in the global scope. Let's take a look at the scope issues in depth here. So let's say scope issues, and let's make a function called count, which is going to have some type of maximum number that we're going to count to. Now, without the global keyword, Python is going to get very, very confused very, very fast. Now, let's go ahead and demonstrate that. So I'm going to say counter equals, actually, let's do plus equals. We're just going to increment this right off the bat here. And sometimes Python will let you do it, sometimes it's not. Other times it's going to just completely freak out and not have a clue what you're doing. But before we even run this, you can see right now it's saying undefined variable counter. And this is perplexing because it's literally right here. So remember our conversation, we're accessing it, but now it's suddenly saying, whoa, it's not defined. Oh, that is frustrating. Let's go ahead and try and run that. So let's say count, and let's just try to count to 1 just to see what happens here. Uh-oh. Unbound local variable counter referenced before assignment. Referenced before assignment really is our clue as to what's going on here. What it's saying is it is now making a new variable and then trying to increment it before we've actually assigned it. So remember, Python types are a little bit, well, a mystery. We don't know if that's a string, a bool. Actually, as soon as it's created, it's an undefined. So if you take undefined and you try to add 1 to it, what is the expected behavior? Remember, undefined is not 0. It's just simply there's nothing, literally nothing. It has no idea what type it is. So Python's going to get super confused super, super fast. And let's just continue on with typing away here just to see how bad this can get. We're going to say counter is greater than or equal to the max. Then let's just go ahead and return false. Otherwise, we're just going to return true. See, same problem. So right here, it thinks it's just fine. It actually knows it's an integer, but right here, it's saying it's undefined. This is what I mean by Python gets very confused very, very quickly. Oh, that is frustrating. So we're going to fix this problem by saying global counter. And notice it's got the exact same name. So really what we're doing is we're saying use the global variable called counter and give it this same name here. Save that, and as soon as you save it, you notice IntelliSense is smart enough to know that, hey, this is actually defined now and we can start working with it. And it knows it's an integer. Let's go ahead and just see the global keyword in action here. I'm going to make a variable called limit. It's going to be 5. And I want to increment our counter using that. So I'm going to say for x in range, and we're going to use our limit. Go ahead and get a variable from that function using that limit. Let's go ahead and print it out. We're going to print out our counter. And just for giggles, let's go ahead and print out just done, so we can see it actually worked. Go ahead and run. Sure enough, boom, done. So it's working as expected now, and it's all because of this simple little keyword right here. Now, standard practice, I tend to avoid modifying global variables inside of a function for this very reason. For example, let's just say I were to grab this and make an entire new function out of it. And I go, I don't need that global. I just want a variable called counter. Now I don't need that. Now suddenly, you guessed it, we are right back to the exact same issue. So now it gets very confusing about which counter we're talking about and in which function. You can very easily fix it by just doing this, but then of course now you're going back to modifying a global variable, which is not really a good programming practice. When in doubt, We're going to have a conversation about encapsulation later, but you want to encapsulate or use pretty much everything internal to your scope without going out and modifying other scopes. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. In this video, we're going to talk about the walrus operator. The what? That's right, the walrus operator. It's a funny name, and it gets it from the syntax. It's : equal. And if you look at it, like if you cock your head sideways, it kind of looks like a walrus. It's got the little eyes and the tusk and everything. But that's where it gets its name. This is a little bit confusing, and this might hurt your brain a little bit. And to make it even more complex, you have to have the right version. This isn't available in Python until Python 3.8 or higher. But what the walrus operator allows us to do is assign a variable from an expression, meaning we're going to take some chunk of code and turn the end result of that code into a variable without having to do a whole lot of complex stuff. In case you're wondering about versioning, remember, if you pull up a terminal, and there's different ways of doing this, you can see down in the corner, I'm using Python 3.6.9. There are different versions installed. So for example, if I type Python, that's 2.7. If I type Python 3, my system's at 3.6.9. So that's not going to work. I would have to do 3.8. I have 3.86. Just use whatever you have. If you don't have 3.8 or higher installed, this will not work, and you'll have to go out to Python's website and download and install and configure Python 3.8 or higher. Follow the instructions for your operating system. Google's your best friend if you have a problem, or you can visit me in the Void Realms Facebook group. There's details at the end of this video. For our purposes here, we're just going to go down here, and we're going to select Python 3, and then select the correct workspace, which should be Python 3.8 or higher. And suddenly everything starts popping up and saying, do you want to install this? Do you want to install that? I'm not going to do any of that for this video. I'm going to apologize if it keeps popping up though. Let's dive in. Let's look at some common issues. And I put the parentheses here for a reason, because that's going to be your biggest issue when working with the walrus operator. For example, if I say y and then walrus, I'm just going to say walrus, len of hello. What do you think we're doing here? Well, let's try and print y out. Uh-oh. I get no graphical error in the IDE because, well, there's really no PyLinter installed. I can install Kite or something else like that, but I just wanted to switch versions and see this thing work, and it's saying syntax error, invalid syntax. What do you mean invalid syntax? I'm using the walrus operator, and I've got the right version of Python. This is what I'm talking about. Let's just grab this guy right here, and let's just put that same thing inside of parentheses here. And I'm going to put some notes at the end here, just for anybody who downloads the code so they know what's going on. And let's comment this bad boy out. Put that at the end there, didn't I? There we go. And let's rerun this. Now suddenly we get the output, len5. It's valid, but according to Python's website, it's not recommended. Why? Because it's just confusing to look at. What is going on here? It's almost like we're calling a function. Remember, in programming and in math, anything inside of the parentheses is pretty much done first. So what we're really telling Python is, as you're reading this, stop what you're doing, crunch all this stuff between these parentheses, and then replace all that parentheses with the value, which is 5. So it's just going to really make a variable called 5. Seems confusing, and it is. 9 times out of 10, that's going to be your biggest issue, is just you forget to put something in the parentheses. So let's go ahead and look at another real world example here. I'm going to say people equals, and we're going to make a list of people. So me, my wife, and the family dog. Big old stinky dumb dog. He's probably down there wanting a treat right now, but he's not getting one because I'm up here making a video. Poor dog. So I'm going to say if n walrus len, and we're going to just get the length of that variable right there. And I want to just say it's less than or equal to 3. Then go ahead and print it out. We're going to print out n. A little confusing, but what's going on here? I'm saying n is walrus or equal to this expression, the length of people, which in this case should be 3 because I have 3 elements. We're saying if it's less than or equal to 3, go ahead and print it out. But when we run this, we have been betrayed. It actually says 2. What? Come on. Why is it true? Why? Because we forgot the parentheses. Let's just take the same thing and let's just go ahead and wrap it in parentheses here. Rerun it, and sure enough, we get 3. So 9 times out of 10, if you have a problem with the walrus operator, it's because you're missing your parentheses. I am not a fan of introducing new concepts without some sort of example. So let's make this super short, but super confusing because the walrus operator is confusing. All right, so I'm gonna say lines equals, and we're just gonna make a list. And we're going to use a function called canAdd with a maximum of 5, that's the default, which is going to determine whether or not we can add to that list. And we're gonna say, global lines. I don't like doing this because what we're saying is now we can modify this, but I want to make sure Python knows we want this list. We're not creating some new variable. That gets a little bit cumbersome. Not a fan of doing that. When in doubt, you should actually send it as a parameter / argument. Let's work with the walrus operator. Let's unleash our inner walrus. I'm going to say allowed equals, and notice how allowed's not defined. So what we're doing is we're letting the walrus operator define this variable. So if you're worried you're going to get an undefined error, don't worry, it's not going to happen. But whenever you see walrus, think the walrus needs to open his mouth. You should see these parentheses. If you don't, you're going to have a bad time. Let's go ahead and say this is going to be the count. And again, walrus operator, so we need some sort of parentheses. But we're going to use a function, len. We're just going to get the length of those lines. Now we're going to say we want the max. And that looks really crazy and confusing. But what are we doing here? We're creating 2 variables, and we're saying allowed is going to be this code expression here. Oops, if my mouse ever wants to cooperate. This code expression here, and count is going to be this code expression here. Whenever you see these parentheses, you are working with some sort of expression or scope, but usually both. Let's go ahead and print. And we're going to say if you can enter, and we want the max minus the count more. So we want to tell the user in real time how many more they can actually enter. We're going to drop back down and say return, and we're going to just return whether or not this was even allowed. That looks super confusing, but the whole point of the walrus operator is we've reduced code. We now have a variable that got assigned an expression. We didn't have to say something like allowed equals something, 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 and then put the allowed in the if. It just automatically does all of it for us. To further make this confusing, let's do something that I see people doing all the time. We're going to say while, and then a function is going to return a bool, and we're just going to loop until that function says we can't do it anymore. Say lines. Go ahead and append that. And we're going to make another variable called L, and we're going to get the input from the user. Whoa, that's crazy. All right, so we are making yet a third variable here. And let's go ahead and just print out that we're done. Okay, highlight the walrus operator. You can see just in our little example here, we are creating 1, 2, 3 variables. Whenever you see walrus, think immediately to the left is what we're creating. Immediately to the right, whatever's in the walrus's mouth, is what we're using to create it. Kind of crazy. So if allowed and the count less the max, then we're going to go ahead and get the max minus the count, blah, blah, blah. That gets super confusing. We're going to return a bool. We're going to use that bool. And then we're going to get this value from the input all in one line. Really, really reduces our code, but it also makes it a little bit harder to read. So I'm going to say, we're just going to enter some stuff. 1, we can enter 4 more, 3 more, 2 more, 1 more, and boom. You entered, and it gives us our nice, neat little list. Major takeaway here, walrus operator is super convenient, but can be super, super confusing. Whenever you see the walrus operator, think immediately under the tusk, you need the mouth, which are these parentheses, and then whatever's in the parentheses is going to get assigned to the variable, because you're really taking an expression and putting it into a variable. You also need Python 3.8 or higher, or you're going to get a whole lot of crazy errors because earlier versions of Python have no idea what you're talking about. That, in a nutshell, is the walrus operator. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to talk about navigating folders in Python 3. Now, before we begin, spoiler alert, there are multiple ways to do something. And this is true in every programming language on every computer operating system. Basically, as computers evolve, so do the programming languages and platforms that people use to create programs. They get infinitely more complex behind the scenes and infinitely easier to use up front, but they also hide a lot of that complexity, which leads to a lot of confusion, especially newbies, because they say, what's the best way to do something? The short answer is there isn't one. Use what works for you. We're going to cover a few situations, but you're going to see people even in the comments down below say, why are you using that way? Use this other way instead. Again, refer back to the golden rule, use what works for you. Let's dive in and take a look. First things first, what we're going to do is import a module. You may be going, now wait a minute, I thought we were going to work with navigating folders. Well, understand that folders are part of the file system and it can get very, very complex, and a lot of this is baked right into the core of Python, but we need to work with someone else's code. And some of these, the ones we're going to work with, are already baked into Python. We just need to tell Python we want to use them. So we're going to import the OS module. In case you're wondering what a module is, it is a group of code that we can use. Someone else has already written this code. We can just simply use it however we want. So first things first, import OS. So we're importing a module. Once that module is imported, we can start working with it. So I'm going to just make a variable called D, shorthand for directory, and I'm going to say os.get current working directory. In case you're wondering what that is, every single application runs inside of a directory. Every single one of them. They are a file on your system somewhere. That file lives inside of a directory. If you're on like a Linux or Unix or Mac, it's in what's called root, which looks like that. It's just a slash. If you're in Windows land, it's going to look something like that. Now, that is the root of the OS, but chances are you're not actually in the root. You're buried down deep in the OS somewhere. So let's figure out where we're actually at. So I'm going to say print, and let's go ahead and format that, and I'm going to say current. We just want to know where the heck we are in the OS. Sometimes this could be like, navigating the deep blue sea or something. We just don't know where we are. So we're going to get that current working directory, or we could just use our variable, which we've already pulled out. Now I have to put this is the current directory. Does not mean that every single program runs in this directory. It just means what our program is running in. All the other programs are running in different directories or even in the same directory. It can be either or. It gets super confusing. All right, on my little virtual machine, we are currently in /home/root shell, just the account that I'm on here, /code/python3. So you can see we're not in the root, we are in a subfolder several levels down. So let's say, just for example, we don't really like this folder. We just want to work with a different folder just to see if we can do it. So let's go ahead and change folders. So I'm going to say os.chdir, which stands for change dir, change directory. So get cwd is get the current working directory. We're going to chdir, or change directory. Seems a little confusing to get the terminology down. Now, you can actually hard code this, like let's say we could home, Bob's files, something, or if you're on Windows, it would be like C, whack, whatever you wanted, or you can use what's called a current path, which means you don't have any sort of pathing in there. Again, a little bit advanced, and I'm just going to do ... In case you're wondering what that means, that ... it actually stands for your current directory and its parent. So we're actually going up 2 levels. Sounds a little confusing, but let's take a look here. I'm going to just grab some code here. We're going to print the current, and we're going to say os get current working directory. Notice how we're not reusing D, and I'm going to just grab that for future reference here. Let's run this. And we've gone up a notch. So we were in Python 3, now we're in code. So we just simply jumped up to the parent. So when you see ... that's really all we're doing is jumping up a level. Now, we're going to reuse this variable here, and I'm going to say os.chdir, and we're going to jump back to that string representation of that directory. Grab that, paste it, clear this out just for good measure, and run. So we went from Python 3 up to the parent and then back to Python 3. So Python 3 up to the parent and back to Python 3. Navigating the folder structures is very, very simple. If you know the path, it's just ridiculous simple, but you just hand it a string and boom, it just goes. Now that's assuming it actually exists. We're going to cover what to do if it doesn't exist in a future video, but just know that if you try to give it something that doesn't exist, you're going to have a very bad time. Remember when I started this video, I basically said there are multiple ways to do the same thing, and we're going to start looking at some of those. The first one is list dir, and this is probably the easiest way to do it. So we're going to say for f in os, remember that import that we added, and we're going to, anybody, drumroll, list dir, there you go. This is a function, so we have to have our parentheses, and we can specify a directory, we can use the current. Now, if we just print this out, let's just go ahead and print and see what this does here. Not a whole lot here. It's just got one file plus this little .vs code. .vs code is this folder right here, which has another file in it. So we're getting folders and files. And if you've got a lot of files in your directory, you're going to see them all. Interesting. So how do we actually determine what each one is? And let's pretty this up a little bit. Notice how this is just Python 3-22, just the name of the script, but we don't get the full path. Let's go ahead and say print. Let's format that. Path, and this is where people in the comments below are going to start arguing with each other. I'm going to say os path and I want to get the ABS, or the absolute path. This is going to tell us the absolute path of that file. Someone down below is probably going to say, why aren't you using real file or something of that nature? Again, personal preference. This is what I want. Let's go ahead and run that. Uh-oh. Has no, oh. Base sensitivity has come back to bite me. There we go. So now it is working as we expect, path, and then it's giving the full path, not just the name of the file. So that's the difference here, is we've got the file name and then we've got the absolute path here. Let's go ahead and make this a little bit more complex. I'm going to say if, and I want os.path. And let's make sure it is a directory. Then we're just going to go ahead and print this out. And we can take this same pattern and just repeat it. So we're going to say if it's a directory, just print dir and then whatever it is. And then if it is a file, just going to go ahead and print file and whatever it is. And let's add one more just for giggles, is link. If you're wondering what a link is, it's a special kind of symbol out there in file land, which basically says, I'm not the right one, go to this other location. It literally just points to another location. You could call them shortcuts or symbolic links. It really depends on your operating system. Notice how this will always return false for Windows prior to 6.0, because Windows before 6.0 did not have symbolic links. And you may be wondering, what's Windows 6? Did we ever get an advertisement for Windows 6? It's just the way Windows does versioning. Microsoft's just kind of dumb sometimes, but basically, if you got an older version of Windows, that's just not going to ever return true. Let's go ahead and save run. And you can see that our path, it is a file, and then our path, and it is a directory. So it's working as expected, and we can now determine whether it's a file or directory, and we can get the absolute path. So Lister, along with os.path, is actually pretty complex and does most of what you may actually need it to do. Rewind the video a little bit and you'll remember I said, hey, as computers get more complex, the code gets easier, but details get kind of murky. And this is a perfect example of this. Scandir. This appears in Python 3.5 or higher. We've been using Lister. And you may be asking yourself, why do we need Scandir? Lister seems to do just about everything we'd want it to do. Well, Scandir, the big selling point for this is it encapsulated in a class and it is faster. Although I will just say it, unless you're doing some high-end coding, you're really not going to see a massive performance boost, and you may be scratching your head wondering why you're even working with it. But when in doubt, let's just dive in here. And I'm going to say Scandir, and let's go ahead and print this out. Notice how I have E in there. When I run this, you're about to see something magical happen. Ta-da! It says dir entry and then the name. So what does this mean? This is a weird little syntax. Whenever you see something encapsulated in brackets like that, it means that Python is handing us a class. And we're going to talk about classes in a future video, but right now, major leap of faith, a class is just simply a custom data type. It's really a blueprint for an object that someone else has defined. We're going to learn how to build our own classes and blueprints in the near future. But right now, all you really need to understand is we have a custom data type called a dir entry. And when we say data types, we're talking about things like strings, numbers, lists, and things like that. Dir entry is just another data type. Let's go ahead and work with this a little bit here. We're going to say print. And this is what I mean by you get lost in the complexity a little bit here. We're kind of scratching our head figuring out what we would need to print out. So you have to actually go out and read the docs or watch the rest of this video. Go ahead and say name. And we're going to say e dot, and we want the name. Go ahead and get the path here. So I'm going to grab this. So the whole purpose of this is to make life a little bit easier, but at the same time, Scandir does work faster than Lister. And ta-da, it works now. Name path. Let's go ahead and run a little bit of an issue. Now, when I say run a little bit of an issue, we want to get the directory, the file, and the symbolic link, the bools, kind of how we did before. So I'm going to grab this. And this is where it's going to get a little mind-bending here. So if I say e.isdir is file is symbolic link, you think it's pretty straightforward. You go, okay, let's try this. But what we're doing under the hood is subtly creating an issue. And I'm wondering if anybody out there can really spot this. Let's go ahead and grab this name here. Now that we've done a little bit of surgery, pop quiz, can anybody spot the issue? Raise your hand. So what's going on here? Dir entry .vs code. We said .vs code is actually a directory. See, there it is right there. But it is printing out dir, file, and link. Wait, it can't be all three at once. What's going on here is we're actually calling a function, or at least we should be. I wanted to demonstrate that because somebody out there is going to run into that issue where they forget to put the parentheses and then they have some weird results. Run that again, and you see now it works as expected, but it never actually threw any kind of error. That's the confusing part. So if you ever get some weird kind of results out of scandir, just make sure you got those parentheses there. Okay, well, let's go ahead and cover glob. And I put glob multiple ways because so far we've covered two other ways to do it. Glob represents a third way, and glob, although it sounds gross, is actually really cool. In short, use what's right for you. We're covering glob because of this, and I put the link here. Typical Stack Overflow question, which is, how do I scan all folders and subfolders, or AKA a recursive scan? And if you kind of wrapping your head around what a recursive scan is, we're in this Python 3 folder. We're going to jump up to the parent here, and I want to know the contents of all of these folders. And if one of these folders has a folder in it, I want to go into that folder, and so on and so on. And we're just going to do a recursive scan. Now, in some languages and frameworks, this is not for the faint of heart, but glob makes it ridiculously simple. So first thing we need to do is we need to import glob. I don't know why you'd want a glob, but anyways, I wish they'd picked a better name for that. So we're going to change our directory, and we're going to go up to that parent. So we're going to go a directory higher. Now I'm going to say dir, I'm going to make a variable here. This is going to be OS, and we're going to get the current, I'm going to say get current working directory. Now we're going to actually work with glob, and I'm going to say for file name in glob. And glob's going to get really confusing, and we're not going to like deep dive into all of the parts of glob, but know that you can do a bunch of different things with glob. We're really just scratching the surface. So we're going to say glob. Sounds like you're talking to a drunk person in a bar. Glob. Anyways, so glob, we want to give it a path name. We're going to have IntelliSense help us here. So path name, I'm going to say, is equal to our directory. And we're going to give it some wildcards here. We need to tell glob what to do. I'm going to say anything followed by anything. Whenever you see star, that's our wildcard. And then we want recursive equals true. So we're telling glob, not just this directory, but all the directories inside of it. Go ahead and do your magic. Let's go ahead and print that out with formatted. I want to glob this out. Like stuck in my head now, glob. Anyways, you know, there was probably like a bunch of programmers sitting around a room going, we made this really awesome thing. What do we call it? Let's call it glob. And then they kind of took that seriously. There you go. So glob has gotten a lot of stuff. And you can see I've got other code from other projects in there, including C++ files, make files, text files, other Python scripts that I've worked on, things like that. So glob has gone through and read the contents of all of those. Now, to kind of show that there are multiple ways to do this, let's go ahead and do it yet a different way. So I'm going to say for, let's go current path, folders, and files in OS, our good old buddy OS.walk. And basically, we're going to tell OS to go take a walk in our current directory. Now remember, dot dot is the parent, dot is the current. So we're just going to say OS walk the current directory, and I'm going to go ahead and say for file in files. This is not so much a recursive scan, but it gives you a little bit of detail here. Let's say go ahead and print. And let's go ahead and work with these. I'm going to say os.path.join. So what we're going to do is we're going to join all of this up. We want to know the current path and the file. And if you're kind of confused about where I got current path and file, it's right up here. So really what OS walk is doing is returning, I believe it's a tuple, and then we're just pulling those elements out of there and then using OS path join to join all that up and make it look something like this. Pretty interesting, pretty easy to understand. So to summarize, there are, well, multiple ways to do virtually the same thing. Each one has its own little pros and cons and little gotchas and different ways of doing it. Use what's right for you. This video covered how to change folders, lister, scandir, glob, along with OS walk. And you're going to see all those out in other people's code. And we were talking about recursive, and that has its own set of complexities, which we're also going to cover in future videos. This is the beginner's guide, and we're just scratching the surface of what we can do. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to talk about reading a text file. The main takeaway from this is it is easy. Anybody can do it. So if you're intimidated with the file system, do not worry. This is super ridiculously simple. Let's dive in and take a look. First things first, let's go ahead and get a file name. Now, your operating system's full of files, but we want to read a file and not disrupt any other application. So we're going to read ourselves, meaning this file right here that you see on the screen. Ta-da, we're going to read this. So we have to get the file name to this script. How do we do that? Well, there's a couple different ways. We're going to show how to do a few of them. So we're going to say OS and sys. We're going to import both those modules. You do that just by putting a comma. We could have done it one per line with import module, import module. I'm just going to do it all in one shot. Let's go ahead and say print. And you're going to see this quite a bit out in internet land, where someone is going to say something like this. Whenever you see the double underscore, it's kind of like a built-in little piece of information in Python. It gets a little more complex than that, but just understand that double underscore means built in. And you can see, ta-da, we've got the full path to our script. Now, there is a problem here. Now, the problem is that may not always exist. Sometimes you're going to get into a situation where this just simply does not work. So again, going back to our previous conversation, there's always multiple ways to do something. So we're going to show you what I believe to be a better way. And we're going to use the arguments. Now, args or arguments are usually not a good thing. Usually you want to avoid getting into an argument, but in this case, we want to dive right into them. So we're going to just print out the sys, and we want the arg b. What's going on with this? Well, under the hood, when Python calls your script, this guy, Python da-da-da, it actually sends you a list of arguments. You ever, like, in your file browser, double click a file and your operating system knows what program to open it up in, those are arguments. So it will call your script and there'll be another, it'll be like comma and then whatever you want to work with. So just know the first argument Python's going to send you is, well, the name of yourself, what you're currently running. Makes it super easy. Now let's go ahead and say, we want to get the full path here just to be sure. We want the OS path. We want the ABS path. Now, a lot of folks in the comments are going to say, why are you using the ABS path or the absolute path? Why don't you use this other one? We're just doing this for demonstration. We haven't really dived into the complexity. I'm going to do an entire video on the different types of paths and what they mean and which one's best and so on and so forth. But right now we're still in newbie land, so we're just going to do the ABS path. And then we're going to print out reading whatever this file is. Let's go ahead and run this. And there it is. So it's just simply handing us back a list of arguments. The first one, or the 0 position, is always the script that's currently running. One thing I really want to demonstrate is, does it exist? Well, if we're running our own file, we know it exists. If we're going to run this and read it, we know it exists because we're currently in there editing it. But just for giggles, I want to cover how to determine if the file exists. I mean, that is the existential question. Does the file exist? Do we exist? Interesting. So anyways, let's say if, and let's go ahead and say not os.path exists. You may be wondering what not is. Not is similar to something like not equals to. It's kind of short version for that. But I'm just going to say if not os path exists. And then I want to give it the name of our file, which we got up here. So if it does not exist, then I want to say, hey, print, and let's go ahead and print out file not found. Because if we try to work with some file that doesn't exist, we are going to get an error message. And what we're going to end up getting is something like this, where it's just going to say file not found error, which would be covered later on. So if you're just churning away and you give it the wrong file name, you're going to have a bad time. But now that we know the file does not exist, we don't want to go any further. So I'm going to say exit. And I have to give it some sort of exit code. And I'm just going to say 1. In case you're curious, a normal exit is 0. And then you would give it some sort of error message like access denied or whatever. But usually vendors will have different exit codes. So I'm just going to say 1, just so we can tell the end user, hey, something bad happened. But because we're reading our own file, it should work just beautifully. So let's run this. Sure enough, works beautifully. Let's go ahead and take this and let's give it a name I know just simply is not there. Nope.txt. Let's run this again. See, file not found, and then it exits out. Works as expected. Now comes the confusing bit. We're going to actually start working with the file. We're going to start with opening the file. And if you get a file not found error during this, it means you have the wrong file path and you did not follow the directions, or something's going horribly wrong with this. So what we're going to do is we're going to say f equals, and we want to call it open. Sounds ridiculously simple, and it is. Now we're just going to give it a path. Now comes the confusing bit. We have to give it what's called a mode. Now, I'm going to do another video on modes, but this one's just going to cover reading text files. So I'm going to say R. It just stands for read, and we're just going to read plain text. But what this whole thing's going to do is it's going to go out in your operating system, make sure that file's there. If not, you're going to get a file not found error, and then it's going to try to open it for reading, and it's going to put the cursor in the file at the 0 position. It's going to hand you a file object back. So this one little line, there is a lot of complexity going on there. Now that we have the file open, let's go ahead and read a line. And I'm going to say line equals, we're going to take that file variable, and I want to say read, and you notice how we get a whole lot of options. Read, readable, read line, and read lines. We want read lines. So we're just going to read one single line, and let's go ahead and print that out. Save, run, and ta-da! Reading a text file. So it read the first line out of our file. Very, very cool. You also notice how it put this little return down here because guess what? There's a return right there. At the end of this, there is an invisible /r/n or /n, depending on your operating system. Just know that it's also going to include that. So when we print this out, we're going to have to strip that out. But we have successfully read a line. Now, if reading a line was cool, you're going to really love this. We can actually control this. So I'm going to read a number of letters. So I'm going to say chars equals f.read. And notice how it wants a number. So we're going to read 10. Let's go ahead and print this out. And I'm going to actually format this. Say chars. I'm going to put star star. And then what we're actually reading. So if you look at our file here, it says reading a text file. And now the cursor's right here. So let's run this and see what happens. And you see how it says chars star, and then it's got a return line feed, get a fi, and then star. So we've actually controlled how many characters we've read. I wanted to do it this way to really show the complexity here. Notice we've got this hard return line feed here. We may not actually want that. So if you're using the read function, you're going to get some weirdness like that. And that's why I tend to use read line when I'm working with a text file. Now, somebody very observant is going to notice as we've been reading, things have been moving forward, meaning we read a line, then we read number of characters, and it said get AFI. It didn't start back over at reading. So what's happening here? As we read, there's an invisible cursor, much like in this text document. You can see that cursor's right there. It always starts off at 0. So invisibly, there's a 0 right there. And it's just like a list or a tuple or anything like that. It's a 0-based index, and it's going to start at 0. And as we read, it will move forward. So as it says read line, boom, it's going to move there. And then when we say read 10, it's going to move there. So it's going to actually count. So this invisible cursor is going to keep moving. What I want to do now is just show the position. How do we figure out where we actually are in the file? This is a bit advanced, and it may not make a lot of sense to you in beginner land, but as you get into advanced file processing, you're going to need to be able to move back and forth in a file. So I want to introduce this concept fairly early. Let's go ahead and say print. And we are going to format this and say position. And I wish they had named it position, but instead they named it tell. So we're going to call the tell function, which is going to tell us the position. Now I want to say of, because I want to know how big this file actually is. So I'm going to say OS, and we're going to call the statistics. We're going to use our S file variable that we have earlier. And I want to know the st underscore size. And if that's super confusing, sometimes IntelliSense will help you out if you're working with an advanced IntelliSense system like Kite or something like that. But you can dig through the documentation, or you can just, trust me, os.stat, file name, st underscore size. So we're getting back an integer. Now the size is the size of the file in bytes. Let's run this. So we are position 31 of 529. And as we add more and more to this, you'll see this position change. Even though it's a comment, the file's growing in size. Let's run that again. Sure enough, 538. Remove that and 530 because we deleted some stuff. So that is how you would determine where you are and the file size. The major takeaway here is as we're reading, that invisible cursor is moving. Now I want to put it right back at the very beginning. So we're going to call seek. And again, this is more of an advanced function, but I want to introduce it very early. This is always a 0 based. Remember our conversation about lists and tuples and dictionaries. It's always a 0 based index. So I'm going to say our file object dot seek, and we're going to seek to 0. Now, if you caught that as I was typing, you see this seekable. Some files are not going to be seekable, so that may break if you're doing some custom work. But for our purpose, it should work just fine. We're just going to tell it where to seek. So seek 0 is going to tell this move all the way back up. So if we were working and we're just reading, a seek 0 is going to say go right back up to this 0 spot. Let's run this, and graphically it has no effect, but if we do another read, you'll see it actually start over again as we're about to demonstrate. So now that we understand this invisible cursor and positioning, and we know how to control where it is, and we've set it back to the 0 position, let's go ahead and read all the lines. I'm putting this big long line here. We're going to print this out just to separate all this out so we can see it in action here. What I'm going to say is for L in F dot read. I want read lines. Notice there's read line, which will do a single, and read lines, which will just keep going and going. And we're going to read this entire file line by line. I want to say print. It's going to hand me back a string, so I want to say L. We want to strip that. Now what strip does, it removes any extra white space. So those hard returns, like right here, how we got these little returns, it's going to strip that out. If we don't do that, we're going to get some really funky results, and I'll demonstrate that. So let's run this. See, stopped it right here. So here's the start of our file, and it went all the way down to where we are. Pretty cool, huh? Now, if we comment this out and just grab this, this is what I mean by you'll get some funky results if you don't strip that out, because print automatically puts in the carriage return line feed. Let's go ahead and clear all of this out. You can see how now it's got this extra space in between each line. So that's why we need to call strip. Let's go ahead and put this right back the way it was. And ta-da, it just works. Okay, Systems Resource 101. Anything you open, you have to close. So we are going to now close that file. Think of a file like a door on a really cold day. You open that door, you're letting all that weather in. Now you want to close it. So what close does is a few different things, but for our purposes, it's very simple. It allows other applications to work with it. If we have opened this and the underlying operating system has locked the file for reading, that means nobody else can make modifications to it. Don't worry, ridiculously simple, F close. Always, 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 when you open a file, close it. You don't want what's called a hanging resource. Now, Python can, and most of the time does, close the file automatically when your script's done, but don't count on that. Sometimes you'll see out there, if you open a file and forget to close it, it just stays open forever. Very, very frustrating. So close, you're not going to see anything graphically change, but it is now closing that door so other people can open it and do what they want to do. Quick recap. This video, we have covered the complexities of the file system for reading a text file. Now, a text file is different than a binary file, which we're going to cover in a future video. So we're talking about just plain text. We talked about importing. We talked about getting the current file, determining if it exists, opening a file, reading some lines and letters and all the lines, moving around in the positions, and how to actually close the file. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian, and we're going to continue our journey into Python 3, and we're going to talk about how to write a text file. This is plain text, not binary. We're going to talk about writing binary files in a future video. We're going to take what we've learned in the previous video and overly simplify it using functions. The last video was kind of verbose. I want to make life much, much simpler. Our first goal is to simplify mode usage. Now, what are we talking about here? We're going to cover two different modes. We're going to talk about write and append, and they do two totally different things, but we can use the same code. So let's go ahead and make a function. I'm going to say toFile, and let's go ahead and say file name, mode, data. I hear a lawnmower behind me. I apologize if the microphone's picking that up. It's just kind of COVID-19, nothing you can do about it. My neighbor likes to mow his lawn 100,000 times a day. So I'm going to say open, and we're going to open that file name. And we want the mode. Now remember, in the last video, we opened it with the read text, or the R mode. We're going to work with W and A, but they can work very, very similarly using the same code as we're about to demonstrate. I'm going to say for I in range, and we're going to go ahead and say range. Let's just pick a number 5. And let's go ahead and write this out. And I want to say the string representation of that number. You're going to get some sort of error message if you don't do that. Let's go ahead and put a little colon in there, along with the data. And let's go ahead and add in a carriage return line feed /r/n. Those are our escape characters. We talked about that when we were in string land. So really all we're going to do is we're going to write out the string representation of the number using str to convert it from an integer to a string. And then we're going to add a colon, whatever data we're in, and then rn. Data is going to come to our function as an argument. Now, there exists this tendency to do something like this, and you're going to see this, flush. I'm going to comment this out. What does flush do, and why do people have it in their code? When you write to a file, you have an invisible buffer in the background. I should say Python does. And that buffer will fill up because you can add more to it faster than it can write down to the disk, especially if you've got a slow hard disk. Think about like embedded systems, how they get really slow. You don't really need to call flush if you're going to close the file. When you're done with the file, you close it. Python calls this automatically when it's closed. However, if you're doing some sort of like sequential writes or something like that, and you want to just write to the file in chunks, you're going to want to flush it periodically to make sure that data gets flushed down to the disk. I wanted to put that there because I know somebody's going to ask, why didn't you flush the contents? You don't need to, because close calls that automatically. And I hate that name, but at the same time, it makes me chuckle because you're going to flush it. And I always think about looking down, as disgusting as it is, looking at a toilet, and you're just going to drop data into the toilet and then flush it down. But that's literally what that does, is it flushes all of that buffer down into the hard drive. So we're going to cover two modes. And the first one is write. When you hear the word write, write will overwrite, meaning it's going to take the existing file, completely erase it, and start from scratch. And you need to be a little bit careful when you do that, because if you have something sensitive or something you wanted to save, it's just going to obliterate that data. It's just gone. It will not be in your recycle bin. It will be gone forever. So you need to be a little bit careful here. So we're going to write file, and let's go ahead and say, I need some special variable name like file name. There we go. And we're going to call this toFile function. We have a file name, mode, a data. So let's just go ahead and grab this. And we're going to call our function here. So we're going to reuse the variable file name. The mode, we're going to switch this to W for write. And the data, we're going to say hello world. Remember, write will overwrite. It will completely destroy that and start over. The other mode we're going to talk about is append. Now, append will add. So Write will overwrite, append will add. Now, what this does is it opens the file, seeks, remember we talked about seeking, moving through that file. It's going to go to the very end of the file, and then it's going to start adding to it. Now, this is what I mean by simplify mode usage. We can literally take this and just paste it. And then simply change this to an A for append. And then let's change this to hello again. So what's going to happen here is we're going to call write. It's going to obliterate the file, start over, and then up to 5, it's going to say hello world. And then we're going to call append, and it's going to add to it. All right, the immediate goal of this was to write and append, but I want to read this file back. So I want to use an import, and I'm going to put it all the way at the top of the file. This is not mandatory, but it's almost like an industry standard, if you will, to put your imports at the very top rather than just adding it right here, which you actually could, but let's put it all the way at the top. That way, anything that we've just kind of flubbed through and we've used OS will get it as well. And if we decide to go back and modify these functions in use, we don't have to accidentally import it multiple times. So in short, always put your imports at the top of a file. We're going to say def, and let's go ahead and read file. And I need some special variable names, something that really stands out, like, I don't know, file name. We could name it fuzzy button kitten or whatever we want. All right, so we're going to say if not, we want OS. And let's go ahead and say path .exists. So we're just going to make sure the file we're trying to read actually exists. Otherwise, we're going to get some bad errors. Now, instead of exiting, I just want to return right out of this function, not kill the entire script. Now I want to say, we're going to open this up, and this is how just ridiculously simple working with files in Python can be. Give it a mode. And because we've opened something, let's go ahead and before we do anything else, call close. Now, in between open and close, we can do whatever we want to do. For example, I could say for line in f.readlines, something like this. Or if we wanted to really oversimplify that, we could just read the entire file in one line. And we're just going to call read. Now, spoiler alert, if you do that on a very large file, you're going to have a very bad time because you may run out of memory, your little app may crash. For example, if you have 3 gigs of memory and you try to read a 30 gig file, it's just not going to do it. And it'll sit there for 3 hours before it crashes, but it'll eventually crash. That's why we use things like for line in read lines, because it reads it one line at a time, not the entire thing. Okay, our warning about reading all of it in one function, if you had a massive file notwithstanding, we're going to leave it like this just for demonstration purposes because we're going to work with a very small file. We're going to see this in action. I'm going to say my file, we could name this really anything we want. Let's name this hello.txt. First things first, we're going to write this file. Just going to call our function. Now let's go ahead and append the file. And let's go ahead and read the file. There's a reason why we're breaking this up into functions, and it's so we can reuse this code. You're going to hear that term a lot in programming, code reuse. Rather than hard coding the file name and then calling, or I should say rewriting this function for every single file, it's just simpler to use a variable and reuse the code. So let's go ahead and run this. And you can see how it says 0 through 4, hello world, and then there are append kicks in here, hello again. Now let's demonstrate this. So let's get rid of this append, and let's just do write. Notice how we already have a file out there, and we can actually open it up, and this is exactly what it looks like. Let's go ahead and get rid of that append, and let's see what I mean by write file will overwrite. This is why it's so dangerous. Hello world, 0 through 4, and if we open our file back up, you can see hello world. All of that hello again is gone because it obliterated that file and rewrote it. Now we can do this, and it goes right back the way we want it. Hello again and again. Major takeaway from this is writing will overwrite, append will seek to the end and add to it, and we can make reading files ridiculously simple. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. This is episode 25, working with binary files. So first things first, what is binary? We've worked with plain text, but what's binary? It sounds kind of crazy, almost like something from the Matrix. The harsh reality is binary is something you're really not going to want to work with directly, and I'll explain why. Go over to the Extensions tab, and let's install a hex editor. Now, spoiler alert, you do not need this specific hex editor. You don't even need this IDE. I'm running VS Code. You can just use any old hex editor out there. Hex is hex. Does not matter. As long as you can view the actual hex representation here. Once that's installed, we're going to flip back over to the files, and we're going to take this file that we're in. We're going to right click, and then from here, we're going to go open with the hex editor we literally just installed. You can see we have the hex encoded bytes along with the decoded text. This is what I'm talking about here, decoded. This is what the computer works with. This is what the machine reads. This over here is what we usually work with, the plain text. So for example, pound is hex 23. Then you have 57, which is a capital W, 6F. I mean, imagine trying to type out just like your name in hex. That would be long and frustrating. So when we're talking about binary, we're talking about the raw data the computer works with. It's not something we want to work with directly. We want to work with a representation of that data. So that's really what we're talking about when we say binaries. We want to give that computer a representation of binary data and let the computer do all the hard work for us. We're not working with plain text. We can work with individual bytes that represent plain text, but we're not working with the plain text itself. All right, we need to leave binary land here, and we're going to go back to plain text land, and this is just the file we've been working with. I'm going to plop in some notes, and it's going to just say install the Microsoft Hex Editor extension. Don't really need it to be the Microsoft one, but then some general instructions on how to work with it in case you're following along with these videos. Now we're going to add some imports, and we need to do this step before we even continue with anything else. So I'm going to import random. And what I mean by random is we're not just randomly importing something. We're importing a module named random, which will help us create random numbers. And we're going to import the operator module. This has a little function here called equals or EQ that we're going to use to compare two lists together, just to make sure that the information we're generating and the information we're saving and loading all matches up and everything works as expected. Let's go ahead and work with that random module, and we are going to create some random bytes here. So let's make a function. Let's call this random bytes. And from here, we're going to just have a parameter called size. Let's go ahead and make a list. Absolutely nothing in that list. Now we're going to say for x in range, and we want a range to equal the size. We're getting that from our argument. Let's go ahead and append our list. So bytes, and now we want to actually say random, and we want a range. So I'm going to say rand range. And if you know anything about a byte, it typically goes from 0 to 255. You can do some crazy things, and we're just going to stick with the norm, 0 to 255 here. Very simple, easy for anybody to understand. We're not talking about some crazy encoding schemes or anything like that. Just 0 to 255. That's all we want. From there, we're going to go ahead and return the bytes. So we're just going to return that list. So random here is going to make a random number within a range between 0 and 255. So we can have up to 256 possible numbers. Now, random, you can do seeds and all this other fancy stuff, and then we're not doing any of that. So what it's going to do is it's going to take the current system time and use that as a random number seed. If you wanted something super secure, you would have to do something different, but we're just going to leave everything as default for now. Now let's go ahead and print that out just to make sure we are getting, well, you guessed it, some sort of random list of numbers. So say def and display bytes. Going ahead and we're going to introduce a few concepts in this video here, some things we really haven't talked about. So I'm going to just make a string. Now I want to multiply this. So we're going to say times 20. That looks a little funny, but what we're going to do is we're going to say take this string and do it 20 times. So we're saying this string times 20. Now we're going to go ahead and print out our little list of bytes here. To do this, we're going to use the enumerate function. So I'm going to say for index, comma, item in enumerate. And what enumerate's going to do is it's going to pull that whole object apart into multiple pieces, things that we can use. And you see where it says right there, enumerate object yields pairs containing a count from start, which defaults to 0. So we're going to tell it to take that bytes list and enumerate it. And we don't want to start at 0. We want to start at 1 because people are not computers. We like to start at 1, not 0. We're just going to make this, human readable. Now we're going to go ahead and format out a print, and let's say index equals, and we want the item. Now, we've been working with a hex editor, so I want to show you a simple little trick here. We can just simply say hex, and we want to make a hex representation of this item so that we could later compare it to a hex editor and make sure that everything lines up exactly the way we would expect it to. I'm going to grab that little print function, drop back down, make sure that lines up so we're not doing it every single for loop, but after the for loop is completed. And let's test this. So I'm going to just grab our function random bytes and, whoops, grab too much of that apparently. There we go. And let's just say 10, just for now, nothing too crazy. Now I want to go ahead and display that list. Let's just see what this looks like. So sure enough, we are getting a list. It is 1 through 10 human readable, starting at 1. Under the hood, it's actually 0, but we're using this little start here to increment it. And then we have the decimal and the hex representations of that data. Okay, deleted our little test there, and we are going to now move ahead and we're going to write some bytes here. Now, we have to do this a little bit differently. We've been working with plain text and we're working with binary files. This is not human readable. So we have to tell Python, we don't want humans to work with this. We want computers to do it. So we're going to say def write bytes. We want a file name and the list of bytes. Now that list is just going to be a list of integers. So it's a little misleading where it says bytes. this function's going to convert those integers to bytes and store them in the file. We're going to introduce something a little bit different here. It's going to be the with keyword. So we're going to say with. With is going to take some code function that returns a variable and use the variable. So let's go ahead and demonstrate that. So we're going to say with open. We're going to open the file name. We need to give it a mode, and we want to write binary. If we just did a W, it's going to be plain text. So we want that B in there as file. So what we're really doing here is we're saying with this function, run this function, return a variable, and call it file. So with some function as file. Kind of reads like a book. With this as this variable. Now that we've got that variable, we can just work with it directly. I'm going to say for B in bytes. And we can use that variable we got from our with statement, file write. And we're going to take that individual little number, and I'm going to say 2 underscore bytes. It's a little misleading that it's a B representing bytes. This is actually a list of integers, so I very easily could have said I. Doesn't really matter what we call it. So we're going to convert that to bytes. Now we want to convert it to 1 byte, and if you're a computer expert and you understand this, we're going to give it a big order. So I'm going to say byte order equals big. If you don't know what that is, don't worry about it. We're just going to use this just for demonstration purposes. It really doesn't matter unless you specifically want a big or something else. All right, that's it. We're done. Now you may be going, now wait a minute, we have a file object. Don't we have to close it? Shouldn't we do something like file close? Well, no. That would cause an error, and that would not cause an error, but it's really not needed because with is going to destroy this when it's done with it. And when that variable is destroyed, it's going to call close automatically. So we're actually done. You notice as we get more advanced in Python, even though we're writing more advanced code, the code actually gets shorter and shorter and shorter. This is one of the really cool things about Python. And we could shorten this even more if we wanted to, but we're still in beginner land, so this is about as short as I'm going to make it for this video. Now that we've written the bytes, we want to do the exact opposite. We want to read those bytes back. And I'm going to intentionally make this function a little bit bigger than it needs to be just because we're still in beginner land and I don't want to confuse anybody. So I'm going to say def read bytes. And I'm saying that because you'll see people down in the comments going, well, this is very verbose. Why are you doing this when you could do? And they'll put a little one-liner in there and everyone looking at it's going to just be like, I don't understand what they're talking about. So we're going to say bytes. We're going to make a blank list. We're going to say with open, and we're going to get our file name. Now, this is the trick here. We need to do the opposite. We're going to read bytes, not read plain text. And I call it bytes, but it's read binary as file. Now I'm going to do a loop, and I'm going to say while true. Loops are big and scary for noobs, so don't worry. We're going to tell this when to stop looping, so it's not going to enter some infinite loop. I'm going to say b equal file dot read, and we want to read just 1. Now we're not reading the number 1, we're just reading 1 byte from that file. If not b, and I think we've talked about not before, it's the same thing as like something like that, not equals to, but we're just saying not b, and we're going to go ahead and break. Break will break right out of that loop. However, if we're still here in loop land, we want to say bytes append. Let's go ahead and take int from bytes. So we're doing the exact opposite here. Instead of 2 bytes, we're saying from bytes. So we're taking a byte and converting it to an integer. And it's pretty simple. We're just going to take our B that we read from the file, and we're going to set the byte order if we really, really want to. So let's just do that. All right, now, once we're in there, we're going to drop back down to this level right here, and we are going to return our finished list. Looks big and scary, but really we're just doing the opposite of write bytes. We're just saying, hey, make a blank list, and then with open, get a file, and then as long as we can read 1 byte, append that to our list of integer and return it. Looks big and scary, but it's actually pretty simple once you wrap your head around it. Now that we've got all the pieces together, let's see it in action. This is what I love about programming. It is a lot like working with Legos. Once you get the pieces together, you can make something bigger and better. So let's see it in action. The first thing we're going to do here is create the random bytes. So I'm going to say out bytes. You can call this whatever you want. It doesn't really have to be out bytes. And this is going to be our random bytes function. And we're going to head and let's just keep it at 10. I don't want anything too crazy because we're going to have to see it on the screen. Let's go ahead and display that just so we can see the out bytes. And I'm going to walk through this step by step here. So let's go ahead and run this. And we've seen this before. I've got this kind of split up here. So every time it displays, it'll have this nice, neat little bracket there. Now we're going to write all that to a file. So I'm going to say file path. And let's call this test.txt. Now this will make some people mad because what we're doing is we're violating some fundamental concepts of the operating system. People expect that a .txt file is a plain text, and I'm doing this for illustrative purposes to show you that the file name and extension have absolutely nothing to do with the data that goes inside them. So now that we've got a file name, I'm going to go ahead and say write bytes. And we can just simply take that file name along with our out bytes and dump that to a file. Let's go ahead and run this again. Uh-oh, file name is not defined. Oh, I've got file path, that's why. Shockingly, the variables have to line up. All right, let's try that again. Clear that, run it. Okay, doesn't look like anything happened on the screen, but over here now we have this little .txt file. And if I open it, I get kind of these crazy characters. Well, what is this? This looks like gibberish. Did we have a corrupt hard drive? No, let's go here, open with our hex editor and see what's going on here. So if we kind of scroll up here, you can see how we have 1 equals 84, but then we go into a panic and go, it's 54, what's wrong? Well, the hex version of 84 is 54. And then we have F1, F1, 4, 4. You see what's going on here. Somebody out there is going to ask, well, why does it say 0x? That's kind of like the universal representation that we're working with hex data. So in your mind, just kind of blank out that 0x and just pay attention to everything after x. So we have 54, F1, 4, E1, D3, and you can see it's just working as expected now. This is what I mean by a lot of people kind of get into a panic when you tell them you have to work with binary data because they don't really understand this and they think that they have some horribly bad screwed up computer or that their program did not work well because they look at it and go, uh-oh, it says 54, but I should have put 84, and they try to figure out what's actually going on. This is what I mean by we're not working with binary directly. We're working with a representation of the binary data. We let the computer figure it out for us. Continuing on here, almost done. Now we're just going to take that file and read it back in. So I'm going to say in bytes equals, and we're going to go ahead and read bytes. And we're going to read that file name. There we go. Once we have that, we're going to go ahead and display it. And now we need to go all the way back to the beginning of this video when we said we're going to use the operator import and we're going to compare them. So I'm going to say print, and let's say match. I just want to know if they're a match. Kind of like, what is that dating site? Match.com. It's a match. All right, so I'm going to say operator dot EQ. And now we need to feed it some lists. So I want to say bytes and in bytes. Again, it doesn't really matter what you name these. Now, because we are using a random number generator that the seed is based on time, these numbers will change every time I run this because time is constantly changing. Just wanted you to be aware. So if you're expecting 84, 241, 4, blah, 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 you're in for a very big surprise here. Or maybe not now that I've told you what's going to happen. Let's run this, see what happens here. It says match true. So what happened here, and let me scroll this up. We have our output and our input, and of course they line up. Every single thing works correctly, and the two lists now match. So what we've done, long-winded version of this, scroll all the way up here. We've created a list of random integers. It says random bytes, but it's really integers. Then we can display those, and then we can pump those out to a file and then write them as bytes. Then we can read them back and read those bytes into integers and put them back into a list and return that. And we can actually check to make sure everything matches. So what we wrote and what we read now match. The big question is, how would you modify this information? Well, let's say you wanted to do some sort of work. You would do that to your out bytes before you wrote it to the file, and all of your changes would be written to it. See, our file is right there, and if we go into open with our hex editor, and we get the nice, beautiful representation of it. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian, and this is episode 26. We're continuing our journey into Python 3, and we're talking about JSON files. Now, it's a little misleading. It doesn't actually have to be a file. What we're talking about is data. And let me just post some JSON data here. And I've got it in these triple quotes. That way the IDE doesn't get all mad. But really what we're looking at is this bit here. Everything between the brackets. So we have the start and the stop, and then we have key value pairs. Now, JSON can get a lot more complex than that, but I wanted to keep it super simple because we're not really trying to learn the complexities of JSON. We're just trying to learn how to use it with Python. First off, why do you even need JSON? What is this? What do you need it for? Well, it is for app to app communications. Now, when I say communications, this could be anywhere from network to remote calls to just simply writing and reading files. JSON is meant to be a data format. So it's not necessarily a file format. You can do all of this virtually across networks, across memory, however you want to do it. But it's an agreed upon format. So let's say I write a program and you write a program, and you want to be able to read what I'm creating. We have to have an agreed upon format, and that's what JSON really is. As you might have guessed, JSON can get a little bit complex. So before we deep dive in, we need some imports. Actually, we really only need one. We're going to import JSON. Makes it ridiculously simple. I know, it's so complex. But we need to import this module because we don't want to reinvent the wheel. We want to use code that's already written and we know works. Let's also go ahead and make a variable. And I'm going to call this file name. We're going to use this again and again. I'm going to call this JSON.txt. Let's start this off super simple here. So we're going to put some dictionary to a JSON formatted string. Say that 5 times real fast. It's a little confusing, but that's what we're going to be doing here. I'm going to make a variable called outd. You can name it whatever you want, but I just want to know that this is the output dictionary. This is what we're going to convert. So I'm going to say the dict function, and I want to make a dictionary that has key value pairs of name, Brian, age, 46, and pet, say cat. So we're going to take this dictionary here, and we're going to output that to a JSON format. So let's grab this, a little bit of copy action there. I'm going to say s equals, and we want to use the JSON module, and we want to dump s, not just dump. Now, if your IDE may show something a little bit different. You may see both dump and dumps with an s at the end. We want the s, which is short version for a string. So it's going to dump out a string. I'm going to feed it our variable there. I'm going to actually do the magic of copy and paste. Put a little note there, just in case somebody's confused about the difference between dump and dump s. Usually when you get dumped, it's a bad thing, but in this case, it's going to make us very happy. All right, so that was actually poetically sad, but we're going to say the string is going to be our output. Let's just run that and see what it looks like there. So sure enough, string equals, and look, it looks like a dictionary. This is what I love about dictionaries in Python in accord with JSON, is they look virtually identical. It's very easy to see that and see exactly what's going on because we have our key value pairs. Let's go ahead and take that and push it out to a file. Now, remember I said as we get more complex with Python, we actually write less code. And I found that to be very true. It's one of the bizarre things about Python. So I'm going to say with open, and we are going to say file name, our little variable there. And we're going to write that. And we're going to make a variable called f. Now we're going to say JSON dump. Notice how there's two of them. There's dump and dump s. Whenever you see that s, it stands for string. We want to dump this. And what do we want to dump? We want to output our dictionary to the file. And I'm going to put some notes in here just in case anybody gets a little confused as to what's going on there. Very, very simple, very easy to understand. Let's go ahead and run this, and it gives us the same output. Now we have this json.txt, and if we open it up, it has the string, I should say stringified JSON, or our actual dictionary in a JSON format. It may look exactly like a Python dictionary, and that's why people often get this confused. They go, oh, you're passing Python back and forth. Actually, we're passing JSON encoded data. It just looks very strikingly similar to a dictionary object in Python. Now let's do the exact opposite. I want to say from string. So we're going to go back up here, and we're going to take this s variable right here. Remember that JSON did a dump s, or a dump string, to this little guy right here. So let's take him, and I want to do the opposite of a dump, which is a load. I'm going to say nd equal JSON. And in case you're wondering about some of the names like dump, yes, Python developers do tend to have a sense of humor, so bear with me on some of these video. And we're going to load s. Notice it's not load, it's load s for string. And we're going to feed it that string. And I'm going to put some notes in here, just in case anybody gets a little confused. So load the dictionary from a string. I have this named nd. You can name this whatever you want. Doesn't really matter. And I'm going to do the magic copy and paste here. Let's go ahead and run this. And you can see our dictionary is now loaded up. Very cool the way that works, and it looks virtually identical, so yes, it will confuse a lot of people, but rest assured, we're working with JSON. Now, in the spirit of doing things backwards, we are now going to load this from a file. So we're back up here where we said with open file in write text as F, and then we did a dump, and we dumped that dictionary out. We're going to do the exact opposite of that. I'm going to say with open, and I want file name. We're going to just read that as plain text as F. And then let's make a variable we haven't used before, so it's strikingly obvious that this is loading it. So I'm going to say file dictionary, or FD, equals JSON. And we want to load, not load S, because that would be a string. We want load, which is going to tell it load it from a file source. And in case you're really curious, no, variable name does not matter. I could actually name this person or P or Brian, whatever I wanted to do. It does not really matter. So now that we've loaded that, well, now comes the complex part. We just work with it. It's really, really that simple. I'm going to say, when I say complex, I'm joking a little bit. This is so ridiculously simple, it's almost scary. If you're coming from other languages and other frameworks, you're kind of like, what? How is it this simple? It's just mortifying. So I'm going to call the type function here, just so we can see what data type P is. This is one of my little kind of gripes about Python is IDEs are great, but if you just open this up in like a plain text editor and not an IDE, you may be looking at this trying to figure out what is load really doing? What is it returning? So the type function is going to print out, or I should say give us back the data type there so we can print it out. And then let's go ahead and print out the actual variable. Let's run this again. So type class dict. So this is a class dictionary. Remember, classes are something we're going to cover in the near future. A class is a blueprint for an object. So this is a dictionary data type, and it is equal to, you guessed it, the information we just loaded back from the file, which is now a dictionary. Very simple, very easy. The main takeaway from this is JSON is a data format used to exchange data between applications. This is an app-to-app communication data standard. People all over the world, different countries, language barriers, doesn't matter, will say, hey, hand me a JSON file. And it's very easy to work with. When you look at it, it is a string. So it's very simple to just open this up in a notepad or a text editor and just modify it if you need to. But it's also extremely easy to work with at a programming level. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian, and we're talking about imports in this video. Imports allows our code to be used by other scripts, and it allows us to use other people's scripts. But most importantly, really, what importing allows us to do is simplify things. We can actually now structure our code and then import things as we need them. Now, the import system is actually pretty complex, so in this video, we are just scratching the surface. We're going to talk about some real high-level issues, and I want to show you how to split your code into different files. We're going to have to split this into multiple videos throughout this series, so we're going to continually go back to the import system and add to the complexity over time. Let's dive in. First things first, we want to make a separate file. So I'm going to just plop in some notes. We're going to create a file, and I'm going to leave this comment in there for anybody who just doesn't watch this video and just finds the code out on GitHub. It's just going to say, go ahead and look at mycode.py. And we're going to go over here, and we're going to actually make a new file. We're going to give it the name mycode.py. And inside of this file, well, we're just going to add some code here. So I'm going to say name equals whatever your name is. Boy, I horribly screwed that up. Can't even spell my own name right. Actually, I spelled it right. I just had it case sensitivity wrong. We're going to make a function called greet. And I'm just really freestyling this. I don't really have anything in mind. We're just going to add a bunch of code and functions here. So I'm just going to make a function called greet. What's going to print out hello and then whatever the name is. Notice the scope here. Name is actually up in the global scope of this file. I'm going to say def, and let's go ahead and say to file. We've already learned how to work with the file system in a previous video. If you missed it, go ahead and go back in the playlist and watch that video. I'm going to say file name, global name. Really don't need to say global because we're not trying to modify it. We're just trying to read it. Python's pretty lenient about that, but just to be safe, we're going to say global. And then open, file name. We want to write to that file. Again, if you completely skip that video, I would highly encourage you to go watch it. And we're just going to say f, write, and we're just going to write everything out to the file. In this case, we're just simply writing the name. We can take this very simple pattern and just change it around. So now we have from file, and we are going to open that in read mode. And then we're simply going to do the exact opposite here. Quick refresher, when we say with, it's going to remove this when we're done with it. So it's going to automatically close that file for us so we don't have to worry about any of that complexity. Okay, so our file is all done, and it's not super hard. It's just got a variable and some functions. Let's go back to our original Python file here. It does absolutely nothing. Actually, let's jump back here and make sure we save that. Now, what we're going to do is use import as. And I think we've touched base on this, but we haven't really dove into what's going on here. So I'm going to say import, and you want my code as, and let's just give it a name, person. Could be anything we want. We could call it ice cream cone, kitten, code, whatever we want. But what's really going on here is import is saying import this module. Now, module is a concept we haven't really covered, and we are going to cover in a future video. But right now, when I say the term module, just think about external code, code that's outside of our file. So import is going to look in, and invisibly, there is a little right there. It's going to look in the current directory for something named my code. And directory structures with imports gets a little confusing. We're going to cover that in a future video. So everything right now is in the same folder at the root of your project. So import this file. There's an invisible.py at the end of this, which is, of course, my code. Now, if you misspelled this, it's simply not going to find it. Now we're saying as person. So what it's doing here is it's importing this entire file, this thing that we've already written, as one variable. So it's now creating a variable called person. And you can see how person is now my code. So that entire file is now sitting in this variable for us to use. It gets way more complex than that, but that's about as simple as I can explain it. Basically, we're taking this entire file and converting it into a variable. Now, at this point, I would highly encourage you to test this. Just simply run it. It should do absolutely nothing, but if you had some sort of misspelling or something, you're going to get something like this. Module not found error. And then no module named. Named is your key here. The name is misspelled. So let's go ahead and fix that. Just wanted to demonstrate that. Let's talk about some scope issues. We can run this and see that it's working as expected. Let's go ahead and clear that out. Let's go ahead and use our global. So I'm going to say global name. Not name error. Thank you, IntelliSense. Global name. Go ahead and print this out. What's happening here? Name error. Name is not defined. Wait a minute. What? In our file, we have name and we're using it via the global scope. So what's really going on here, and what we're trying to illustrate, is that a module has its own scope. So the global scope of the module is not the global scope of your script or your application. They are two completely different scopes. So even though we can explicitly try to shove this, even though it's already a global, we can try to shove it into the global, it really doesn't help us. It's still not defined. Now, if I do something like this, comment that out, run this, what happens? Same thing. Name is not defined. So it doesn't really matter which way you try. Oh, that is super, super frustrating if you're a newbie. So how do we get the name out of here? Well, remember, we have taken this entire file and converted it into a variable. We have made pretty much our own data type. So we're going to go ahead and print person, or whatever you name that. And now we want the name attribute. And it automatically knows it's a string, so life is now going to be good. Let's plop a note in here just so anybody out in GitHub land can see easily what's going on. Clear this out and run. Oh, it's because I still got this in there. Sorry about that. Let's try that again. All right, so there we go. Brian Karen. So if you were like me and you forgot to comment that out, you're going to get that nasty error. Very good illustration of scope in terms of imports and modules. Anytime you have a new file, think you have a different scope. There are ways to jump between them, but for realistic purposes, they are two different scopes and you should treat them as such. Last thing we need to do is really just do some testing. So we're going to go ahead and test this code. I'm going to add some spaces there, just get some screen real estate. Let's go ahead and say person.name equals, and I'm going to switch this to Brian instead of Brian Cairns. And then let's go ahead and do person.greet, call that function. And let's just do person.toFile. Let's give this a very simple name, test.txt. It's just going to dump that name out to a file. Let's go ahead and say person.name equals Tammy. Go ahead and do the greet again, just so we can see that we did change that variable. Let's go ahead and load that file. Now, as long as our file name matches up, it's going to load it just fine. Go ahead and greet again, just so we can see that we did actually load that name from the file. Let's go ahead and run this, see what happens. So the original name is Brian Cairns. I switched it to Brian, switched it to Tammy, and then we loaded it from the file. We could see we now have this test.txt out here. So in a nutshell, just to recap, imports is a really, really great way of structuring your code, and it really simplifies things. It does have its complexities, which we're going to cover in future videos, and we've touched upon a little bit here with scoping issues. It gets way more complex than that, because what we're really touching on with imports is the cornerstone or the foundation of modules. And unfortunately, before we can dive deep into modules, we got to learn other things first, like, well, classes, which is coming up very, very soon. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to talk about the main function in Python. Now, in case you're wondering what a main function is, in most programming languages, you'll have something like this. And all this is a function literally called main. And when your application executes, it's going to be the first function or the entry point to run. And without a main function, your application simply won't work. Well, as we've seen with Python, you don't need a main function. This works just fine. So how do you get your code to run automatically? That's really what we're going to be talking about in this video. Let's go ahead and take a look at this. So first thing we need to do is determine how our script is running. If you've been following this series in the playlist on YouTube, you know that you can run your script directly and your script can be imported. So we want to make sure we know exactly how this script is being run. So let's go ahead and go print, and we're going to say F. So we're going to format this out and say name equals. Now we're going to use a special variable, __ name. Whenever you see that double underscore, this is built into Python. We're going to take this and print this out. Let's go ahead and change this to file. And I stated in a previous video, this may or may not work. So if you have problems with __ file, you're going to want to watch that previous video where I talked about using the system arguments that are handed to your script. This should just work just fine most of the time. Let's go ahead and run. You can see how our name is __ main. So remember, double underscore means it's built into Python. And the file is, well, the file name that we're currently running. This, spoiler alert, could change, so don't depend on this. And what I mean by that is if we are calling our code based off an import in a special way, the file name will not actually be the name of the script we're currently in. So you got to be a little bit careful there. But I want to highlight those things. The big takeaway from this is our name is __ main, which means we know Python is running this file directly. This is the main script file. Now let's go ahead and create some code here. Our script really doesn't do anything, so we want to do something. We're just going to make a test function. I don't really care what it does, just as long as it prints something out on the screen so I can see it's running. Now we're going to make a main function here. Notice the name is main. Go ahead and print this out. And let's just, for giggles, go ahead and call our other function here. So really what we want to do is we want this script to automatically run this main so we know what we're doing, and then call this other function and start some chain of events, do some code processing and things like that. So let's go ahead and let's clear all this out. And let's see what a lot of people who are new to Python make a mistake. They go, oh, I know what I'm doing. And they go ahead and run and nothing happens. Oh, that is a bummer. So yes, in Python, the main function really isn't called automatically. We have to call it specifically. Now you may be thinking, I know what I'll do. I'll just go down here and then call main directly. And it will work. Watch, we'll run it and ta-da, it runs. This is the main function, this is the test function. So we are calling it. The problem comes in with this name right here. We're going to demonstrate right after this section. We're going to show you what happens if we run this from a different script. We don't necessarily want this code to execute, meaning if we take this file and import it as a variable in another file, I don't want this function firing off. So we want this to run automatically, but only if a certain condition is set. Let's go ahead and say main. And we're going to print this code out automatically. This is my IDE. You may have to type this, but we're going to say if __ name equals main, then, and pass is just going to, well, do nothing. So I'm going to take this, call our main function directly. Go ahead, save and run. And sure enough, it runs our main function. So it's saying the name is equal to main. So we know Python's running this directly. A main. Go ahead and call this. Once you've wrapped your head around the difference between underscore underscore name equals underscore underscore main, and you know that means that Python is running this directly, we can do something a little bit different. We can actually take this code file. Let me grab some notes here. And we can run this from a different script just to see the difference here. So we're going to create a file called test.py, and I'm going to make some mistakes just to show you what's going on. I often make mistakes, but legitimately this time I am trying to show you what's going on. So the first thing we're going to do is we're going to import this file here. So let's go back here, and I want to say import Python. And notice how IntelliSense is helping us out as code. Now, from our previous video, you know that what we're doing is we're taking this file in its entirety and converting it into a variable which we can use. Before we go any further, let's run this. Notice how we get an invalid syntax. It's got this little, it's called a caret right here, is pointing up at this bracket. So what it's telling us is it doesn't like this. It's simply our file's naming convention needs to change. So what we can do is let's right click this and call this codefile.py. The functionality has not changed. So for example, we'll run codefile, which used to be the Python 3-28, and you can see it's working as expected. It's just the file name has changed. So the functionality hasn't changed, just the name. We're gonna have to go back in here and change the name. Clear this out. And let's run this test.py. You can see how right off the bat, what's happening here is name, code file name, code file. What is going on here? We ran test.py, but it's printing this out. So when we hit import, it's going to go through and start reading our file from the top down, and it's going to actually take some actions. So this is a little bit dangerous here. And just for illustrative purposes, I'm going to grab this, go in here, and let's call this test name and test file, just to separate those out. Clear this and rerun. Now you see they're both firing off. Even though I'm running test.py, import is happening first. So it's saying import code file. It's going over to code file, executing this code. It's not executing our functions. And because the name is different, it's not executing this. See, name is code file. So the name is no longer underscore underscore main. The name is, well, simply the short version of the file name, code file. Doesn't have the directory, doesn't have the extension of .py. That's why we need this if name equals underscore underscore main. So now in here, we can actually call this directly. Save, run, and see it in action. Sure enough, this is a test function. Main never fired off. This may seem a little bit confusing, so quick recap. You have to be a little careful how you name your files if you're going to use them as an import. Some characters are just simply illegal, like the dash you saw earlier. If you're going to run automatically, you want to check the name is equal to underscore underscore main, because if we're running this file as an import, it's going to give us the name of the file with no underscores in front of it. This is not guaranteed to be the name of the file. Python can send us anything we want. The point being, underscore underscore main means that Python is running this directly. And just to illustrate that, we're going to run the code file again. And see, name is underscore underscore main. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to talk about import madness in this video. And yes, we are going to deep dive into, well, insanity here. So what we're talking about is underscore underscore init. What is it and why do we need it? First things first, we need to make a subfolder and add some code to it. So I'm just going to plop some notes in there. We're going to make a folder and let's literally call it sub. So I'm going to go up here. I'm going to say new folder, sub. And inside of our subfolder, you got to make sure you got that highlighted. Your IDE may be different depending on what you're working with. We're going to add 2 files. The first file we're going to add is going to be called, well, very simply, test.py. And we're going to add some code, and just for the sake of time, I'm going to copy and paste just a simple function, do test, which just prints out do something here. Really not award-winning code by any means. Let's also add another file, and this file has to be named underscore underscore init underscore underscore dot py. Remember, whenever you see the double underscores, you're thinking something internal to Python. Now, there's a lot of debates out on some forums on whether or not you actually need this. And legacy versions of Python, you actually do. More modern versions of Python, it's debatable, but I'm putting it in here just so we understand it. I'm going to paste some notes here, and it's quite a bit of notes. This is needed because we are in a subfolder. Whenever you see folder, I want you to think in terms of modules. Remember, we've talked about modules just a little bit, but a module isn't just simply a file. It's an entire folder structure. And the problem with creating some sort of folder structure is that Python needs to understand how to work with that folder structure. So in its simplest case, init.py can just be an empty file, but it can also execute initialization code for the package. That's how complex this can get. So if we're working with something like a socket server or a database or something like that, we can actually initialize some code. We could say like port equals 80 or the username. You'd never do this in production, but like the username would be admin or something like that. You can actually specify all that right in this file. So we are using this very simply because we want to work with this file and we want Python to understand how to work with this file. So we're going to modify it just a little bit here. We're going to say from .test import star. We've seen import before, but we haven't seen this. What is going on here? So what we're doing is saying from .test import star. The from is just basically saying go out and find this. And we have this little period here. If we omit that, we may have some bad things happen. It may not actually know what we're trying to do here. So we have to put that in there in most cases. And then magically it knows this is the directory. If you're ever confused, dot is the current directory and dot dot is the parent. So basically what we're saying is from the current directory and then take a file named test. There's no .py at the end of it. Go ahead and import and then everything. So we're saying take the entire contents of this file and put it right into Python. Let's go ahead and play around with the imports a little bit. So we're going to flip back to our main file here and we're going to play with imports. So let's go ahead and try and import it a couple different ways that we've tried in the past. We're just going to simply say import sub.test as code. And now code.doTest. We can actually do this. Look at this. Now, if we run this, everything works just fine. But we have skipped over this initialization file. An older version of Python's this may not work. You might run into some little bit of trouble here. And if you try saying like from the current directory .sub .test you may, depending on your Python version, run into something like this, invalid syntax. So how do we import this file? And if we had other files as well, you guessed it, we need this initialization file. And there's a special way we have to do this. So what we're going to do is jump right back here, get rid of all that. And we're going to say from, remember when you see the from keyword, we're saying go find a location. So from sub is the name of the folder. So from this folder, go ahead and import star. So we're saying from this folder, import everything. Now that's big and scary because what if there's thousands of files out here? That's right, we're going to import thousands of files. And that's where this __init__.py really comes in, or the initialization file, we'll just call it for short, because it's going to instruct Python on what to do. There may be some files we want to import directly, and there may be some files we don't want imported automatically. We may want to set some variables or some settings or some file structure. We would do all of that right here, and we could call functions if we had to. It goes way, way deeper than that. Again, we're still in beginner land. And if we really wanted to, we could get a little funky with this. We could say something like from sub import and then a specific file. Now remember that would be test.py, but you don't need the .py as code. So we're saying from the folder, import a file as this variable. Looks a little verbose and it seems a little confusing until you really wrap your head around it, but it's super, super simple once you get it down. The major takeaway here is if you have a subfolder, you should include this __init__.py or the initialization file. If you skip this step, older versions of Python will just simply not work, and you may have some weird issues. And if you want to do any sort of initialization at all, this file is pretty much a must. Okay, once we've gotten to this point, really there's only one thing left to do is actually see it in action. So we're going to call the code here. I'm going to say def main. And if you are with me here and you try to do something, the IntelliSense in your editor may betray you. You got to be a little careful. So I'm going to say main. And for the moment, I'm just going to say pass. Remember, pass in Python means do nothing. And if name, let's go ahead and go down here, equals. Following along from the previous video, we're saying if the name is equal to main, go ahead and run this function automatically. That way, if we were to import this file, it's not going to kick off this code. Let's go ahead and get rid of this, and we're going to say print. This is the main function. And let's call our imports. Now, because we've done from sub import star, meaning import everything, it's going to go in here and it's going to read this initialization file and say from test import star, and it's going to import all of our code. And we've got this do stuff out here. So through the magic of old copy and paste, I can grab that, jump back out here and say do test. And we can just call it directly and it just works. See, do something here. And because we've done from sub import test as code, we can take this and we've just basically said do the same thing, but put it inside of a variable. Now I can say code.doTest. Very simple, very easy, works as expected. So which is the correct way? Which one of these should you use? Personally, I tend to lean towards this second line here, simply because importing from everything, what if you have a name collision? What if there's like a test2 file that also has the same do test function? You want to be able to separate those out into two different variables or two different scopes. Remember, each file is kind of an island in itself as far as scope goes. At least that's how you should think about it in your mind. So the major takeaway from this is, well, the initialization file matters. And if you omit that, you may have a bad time in Python land. You really need that to initialize how Python does things. And there are different ways to import, further muddying the waters on import madness. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian. We're going to continue our journey into Python 3. We've been saying for 30 some odd videos now that we're going to talk about classes, and well, today is the day. We're going to start talking about classes. Before we dive too deep, we've got some fundamental concepts we need to cover. First and foremost, you've heard of OOP, or Object-Oriented Programming. This is the cornerstone to that. Basically, a class is a blueprint for creating objects. You'll hear people say classes and objects interchangeably, and they're two different things. A class is a blueprint or a plan on how an object should be created. The object is when Python or another language actually creates the object or the instance of that class from the blueprint that we're going to make. Classes are also a big topic, way bigger than we can cover in the single video, so we're going to split this up into multiple videos. Let's dive in and take a look. All right, classes can get very complex. We're going to create a simple class. So I'm going to just paste a comment, create a class. We're going to do this in a separate file, but you can do it all in one file, as you're going to see in future videos. But I just want to show you kind of the real world approach to how people do this. So I'm going to make a new file. We're going to call this file cat.py because we're going to make our own cat class here. I'm going to paste in some notes. The cat class. Self is the first parameter. I want to put that right there because people often forget this. If you're from another language, it is equal to the this in another language. And what are we talking about here? This is why people get class and object confused. The class is a blueprint for how the object will be created. Once the object is created, it becomes an instance. So I'm going to put that. If we're in an instance, because you can have multiple instances, as you're going to see in this video, we'll make multiple cats, and you want to refer to the current instance, you need this, or in Python, self. So people often think that self and class are the same thing, and they're not. They're two different things. Whenever you hear class, it's the blueprint. So let's make the blueprint. Okay. That's it. It's really that simple. Now we're going to have to add some attributes here. So I'm going to say name equals just blank, and let's go ahead and say age equals, and everybody kind of has their own way of doing this. This is simply how I do it. Feel free to adopt your own style or your own company standard, whatever you're working with here, but this is how I do it. I want to know the variables, and whenever you see a class and you see this indentation, think scope. So these exist inside of the cat scope. And each instance of these will have independent variables. They're not shared, although you can share them. We'll talk about that in another video. I know you're probably sick of hearing me say, we'll talk about that in another video, but there's a lot to coding, so can't cover it all in one. So now we're going to say def init. Now remember, the double underscore means it's something baked into Python. This is the constructor. And what I mean by constructor is this is called when we make an instance of this class. So we can execute code. Think of this like the main function for a class here. As soon as Python creates an instance of cat, we will run this function automatically. You can feel free to omit this, and that's called the default constructor, where you just simply don't have one. Or you can actually define it yourself. Now remember, I said self is the first param, so we need to say self. That is the first parameter we need to have, is a reference to the current object. Now I'm going to just paste in some notes here. Basically just stating the obvious. Self is required. The other parameters are optional. And let's go ahead and fill this out. Because we want to reference the current object, we're going to say self dot name equals the name parameter. And then from here, it just simply becomes a lesson and copy and paste because we want to do the rest of these. So we're just simply initializing these variables. Just going to copy and paste these out. Maybe. There we go. So we're saying the self name, this guy, is equal to the parameter, or actually the argument name, age, color, becomes pretty self-explanatory. Now I'm going to print out something just so we know it was constructed. And I'm just going to say the constructor for self name. And from here, it's actually fairly simple. We can just define any real code or functions that we want. For example, we can say def meow. And if you do this, you're going to get really confused when nothing works. Remember, you have to have self as the first parameter there. Otherwise, you're just simply going to have a bad time. Nothing's going to work right. Indentation may drive you crazy. Remember, you just want to line up with your current scope. So class scope, function scope, so on and so on. And then I'm just going to say print f. Let's go ahead and say self.name and meow. And I'm going to speed this up just a little bit because we've covered functions before. But the main takeaway here is you have a blueprint and you can define what this object, once it's created, is done. Now notice how I've just intermixed those. We're defining a blueprint, but we're also defining the behavior of the object once it's created. This is why people get things so horribly confused. Go ahead and make a sleep function. And let's just go a little crazy here. Let's go ahead and say hungry and get rid of this. For X in range, I don't want to do anything too drastic, just 5. And we're going to say self.meow. So when we say self, remember we're taking the current instance of this blueprint, whatever's running in memory, and we're going to call this function. So if you have 2 cats, we're taking one of them and say, make that cat now meow, and we're going to call this function over here. So it becomes very simple how you can work in your own class. Now from here, I'm just going to say, go ahead and add a couple more just to show that you can do some stuff here. And I want to add just one more. We're going to say description. And here I want to print some stuff out. So we're going to print out the color out because I want to know what color this cat is. Is a proper English here. So we're saying the name is a color cat, comma, who is years old. Pretty simple little function, but basically what we're trying to demonstrate here is you can do pretty much anything you want. You can have functions call other functions, you can do hardcore math, you can actually create instances of other classes, do pretty much anything you want. But now we have fully defined a blueprint for a cat. And this cat will have a constructor where we're setting the variables, and it will meow, sleep, be hungry, and meow a lot of times because that's what cats do, and we can make it eat, and we can get a description of that cat. So far, our class doesn't do anything. It's because we haven't created an instance of this yet. Remember, the class is just a blueprint. Now we've got to actually create an object that we can work with, or an instance. So let's flip back to our file here. First thing we need to do is import it so we can actually work with it. Now we have to import this because it's in another file. If it was in the same file, we wouldn't have to import. But let's go ahead and go import cat. And now we can just work with that directly. Or if we really wanted to, we could say something like this, from cat import, and then we could import the cat class. So now what we can say is from the cat file, import this block of code. And when we go in here, it is the cat class. So if you had multiple classes in here, it would only import cat, whereas import cat would import everything in that file. So that's why you're going to see those two out in the wild there. Now the important part, let's go ahead and use the class. Now when I say use a class, what we're really doing is we're going to create instances of that class. I'm going to make a function called test. Now you may be wondering, why don't we have a self here? You've been saying self over and over again. Because we're not in a class, we don't have a current object. So there's no current object or no current instance. We're running right on the global scope. We simply don't need it. And if we try to use it, really all we're doing is creating a parameter that we'll have to give some object to that doesn't exist. So it would make no sense. So if that sounded confusing, it's because it makes no sense to put self there. So we're going to say b equals cat. Now you notice from other languages, you would have to put like new. You don't have to do that with Python. It does it automatically. You do need the brackets though. Now we need to give it a name, an age, and give it color. If you're wondering how I got those, it's because we define this in our file. In our constructor, it needs a name, age, and color. Notice we did not call self because Python does this automatically. What's happening under the hood is it's saying make an instance of the cat class, and then invisibly it's putting self right there, or X, that instance of that class. We don't have to do it. Python does it for us. That's one of the hidden little gotchas. You may look at this and go, where is self coming from? Python does it for you. All right, so we've got this cat. Let's make another cat here. And let's call this Othello. This was one of my cats. He was a really great cat. I miss him so much. He was a black cat. A lot of people don't like black cats. They think they're bad luck, but this is like the best cat I've ever had in my life. So we got two instances, B and C, and they are two different things. Let's go ahead and print out description for B and the description for C. And we could take this out just a little bit further if we wanted to. We could say C meow. And if you're wondering, yes, you could give it a more complex variable name. You could actually call it Kit Kat or Othello or whatever you wanted. Let's go ahead and call B sleep. C is going to be hungry, because the cat was always hungry. And then we're going to say, you know what? B's not hungry. B's going to eat. And if name equals, and we've done this before in another tutorial, but just in case, we're checking to see if Python is running this directly, and if it is, we want to run some code. Now, I've said this is the main function. We don't actually have to have a function called main. What we can do is, well, anything we want, and this is kind of the beautiful thing about Python. I'm going to say x cat, and we're going to give it a name of test. Notice how age and color already have a default value, and so we don't have to have them, but we do have to have a name. We covered all that in our functions video. Just going to go ahead and print out x. I'm not going to call this test function just yet. I want to show you something. Uh-oh. Name error, white is not defined. What did we screw up here? Let's go in here. We are on cat.py line 7. Oh, interesting. Name white is not defined. Name white is not defined. What do you think is going on here? So we have line 12, color white. That's what we're missing here. I was handing it some type of object that didn't exist. So if you ever run into that is not defined, kind of a little bit of explanation on the fly. That's why we simply, instead of a string, we were trying to hand it an object. Simple enough fix, but for a moment just kind of threw me for the loop. All right, now let's clear this out and run this again. There we go. So you're going to see this and you're going to think you have an error. But really what's going on here is it's telling us underscore cat, name of the file, dot cat. So we can actually go in here, and we can see exactly what it's doing. And then object. So now we have an object. We're working with object-oriented programming, or an instance of that object. And it is located at this. Now this looks really confusing, at this. This is actually a memory location. So if you're coming from a language like C or C++, something that actually where you play around with the memory directly, this is the memory location. That is really cool. So now we can know what's going on here. Let's flip back here and let's actually just print out B and print C. There we go. Let's clear this and let's call our test function as well. And let's see this whole thing in action. So now we know our horrible goof up in our code here is fixed. We know that class works and we can start making more instances of it. So pop quiz, how many instances of this class are we creating? You said 3, you're correct. 1, 2, and 3. Let's go ahead and run this, see it in action. All right, so scroll all the way up. Actually, I'm just gonna bring this whole thing up here. So we have cat object at this location, and then you see the constructors firing off for KitKat and Othello. So the constructor is called, even though we don't call it, it's called automatically. Think of that like the main function for a class. And if you're confused about what that is, quick recap, it's this def underscore init. That is our constructor. Flipping back to the output here, you can see now we have a cat object at this location and a cat object at that location, and you don't have to memorize these numbers, but if you just kind of look at the last few characters here, you can see they're in different locations. That's how you know they're different objects, because Python has created 3 different objects at 3 different memory locations, and we can treat them independently. KitKat is a tabby cat who's 1 year old. Othello is a black cat who is 6 years old. This is the cornerstone of object-oriented programming, and then we can work with those objects directly and do pretty much anything we want. So, major takeaways from this video. We are covering object-oriented programming, and we're talking about classes, which are the blueprints for objects. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian, and we're going to continue our journey with Python 3 with class inheritance. Now, when we talk about inheritance, we're not talking about a loved one dying and leaving us everything they own. We're talking about how a class can inherit or include the attributes of other classes. So, for example, you were born into this world, you have a mother and a father, you have a hair color and an eye color, and those came from your mother and father. You inherited those traits. That's really what we're talking about with classes. This can get super complex, and we're going to look at a few issues that can pop up. Okay, we're going to go through a lot of this at warp speed, just because we've covered this before, so I don't want to waste a lot of your time. We're going to make a feline class. Now, remember, class is just a blueprint. We'll say feline, and then I'm going to go ahead and define our constructor. Self, and let's give it a name. There we go. Notice one thing right off the bat. We're saying self name, but we've never actually declared a name variable. Pay special attention to that, because we're going to find out really, really hard how that's a bad idea. And that's why I said I try to declare all my variables at the top. That way I know instantly what the class has and it's been declared. This is going to come back and haunt us. And I'm going to say, creating a feline. So we have a constructor here. Now I'm going to just to speed this up just a bit. I'm going to put some functions in the feline class. It can meow and we can set the name. So really all we're doing is meow just prints out self name meow and set name, you guessed it, prints out setting the name. And then we go ahead and set that variable. Remember, we haven't declared this. Now I want to make another class that inherits the feline class. You notice how when I mouse over this, it says feline, feline. So it's just a self-contained class with no inheritance. We're going to make a class, and I need a snazzy name. Let me get my notes here. We're going to make the lion class. We're going to say class lion. And you may have been wondering why classes would even have a parenthesis here. Well, we're about to find out. Feline. That's all we're doing here is we're saying the lion will use everything in the parentheses. And the first thing it's going to use is the feline class. That is just simply how we inherit. Now we can say def, roar. Again, we have to have the self in there. And we can just print something out. There we go. Looks super, super simple. And well, let's go ahead and play around a little bit here with the code. So we can say C equals feline. And we got to give it a name, so let's call this kitty. Let's go ahead and print C out. And let's say C meow. Go ahead and run this. And it says creating a feline. So our constructor of our feline class was called. And we have a main. Notice how it's got the underscore underscore main. So we're at the main part, meaning this is Python at the root. It's created a feline object at this memory location, and the kitty is meowing. Now let's go ahead and make a lion. So I'm going to say L equals a lion. And let's call this Leo. Let's go ahead and print out that object so we can see what's going on under the hood. And let's also say L.meow. Now you notice something magical just happened. The lion class does not have a meow function. It is inheriting it from the feline. So in short, everything you inherit, you now have access to. This is extremely cool. And we can also add to this class. So we're saying the lion is not just a feline, all of this class, all this blueprint, but also this additional stuff that we can define. So now we can say like L.roar. Go ahead and run this. And sure enough, creating a feline. You notice how the constructor for the feline was called, and then the lion is created. Interesting how that works. We did not define a constructor for lion, so we're seeing the default constructor for the feline. Interesting. That is going to come back and haunt us here in the next section. I keep saying we're going to have a bad time, and that's coming right up, but I want you to understand what's going on here. Python is creating a feline and creating a lion. Those two are together into one object at this location. But it's simply going to say main.lion. Now, the main, of course, is this file right here. And then Leo's going to meow and Leo's going to roar. And if I just go up a little bit, you can see the kitty's meowing, the lion's meowing, the lion's roaring. So everything's working as expected. Now, fasten your seatbelts because things are about to get really, really bumpy. Let's go ahead and make another class here. And we're going to call this the tiger class because we are going to inherit the feline class. Almost said timer. That would have been interesting. All right, so we've got our feline class. Now, one thing I'm going to do here is I'm going to go up here and just grab this. And I'm drawing your attention to the default constructor. I shouldn't say default. The constructor for our feline class where we have a self and a name. And remember how I said we did not initialize that variable. We are doing it right here in this constructor. But what I'm going to do now is I'm going to go to this tiger class and, you guessed it, plop that in here. I'm going to get rid of the name because guess what? We're inheriting. The feline has a name, so I don't really want to mess with it with the tiger. So now I have a different constructor, even though what you can see is we are constructing a feline. So bad things are about to happen. All right, let's go ahead and say constructing a tiger. I want to plop some notes in here, and they may not make a lot of sense at the moment. Super allows us to access the parent. When I say the parent, we're talking about this right here, whatever we are inheriting from, or the base class, if you will. If we forget this, we'll have a bad time later, meaning we can say super, the parent, in this case the feline, call the constructor with a name, and we're just going to set no name. Now I'm going to comment that out, and we're just going to say creating a tiger. Oh boy, we've got some problems here. So now let's go ahead and make another function, and we're going to say stalk. Now, I'm trying to kind of like explain this as we go so you understand why this fails, because it will fail. What we're doing here is we are trying to rely on Python to do all of this management for us. And we have to make sure that name is set in the parent. When we say parent, we're talking about the super or the base class. This is considered look before you leap. We are dynamically adding the attribute. And what do I mean by that? Dynamically adding the attribute. Right here. We're adding it in the constructor of the feline. If we bypass that constructor using our own in the tiger and we don't call the constructor of the feline class, that variable never exists. What happens when you call a variable that doesn't exist? You get a not defined error. So let's go ahead and print, and we're going to do a formatted print, and we're going to say self.name. Notice how IntelliSense is saying it's valid because we're working with a blueprint, not an object. And to make things even worse, we think this is going to work. Let's go ahead and plop in yet another function. Let's say I want to be able to rename this. We're going to say super, because we know there's a concept of a super, which we're actually accessing the feline class, and we're going to call the feline class set name. In case you're wondering, yes, we could actually call tiger set name and just set the name directly, but I wanted to show you that you can go up to the super and call it directly if you wanted to the feline class. And if that seems super confusing, it's because it's meant to be. I'm trying to show you that super is a separate object from the tiger. Even though they're merged into one class, it is a separate entity that Python understands and tracks. So the difference between saying super set name and just saying set name is very subtle. Set name is setting the name in the tiger class, where super is saying, hey, go up to the feline class and call this function in feline. Because remember, when we create a class, the first thing that gets created is our parent, or the super. Man, that is super confusing. So this is one of the subtle complexities we're going to have here. So the major takeaway is we have horribly designed tiger. We have basically created our own constructor. And I want to plop a note right here. Override the constructor is a bad idea because we now have this chicken or the egg problem where self.name does not exist. That's not even defined. Let's go ahead and demonstrate all of this just to show that it will explode. So I'm going to say tiger. And I want to plop a note right here. Is a feline, but with a different constructor. I won't put the word with. Different constructor. So now there's no name. We've deviated from our class design here. Let's go ahead and print this out. Save run. in creating a tiger. Notice how main tiger object is created. It hasn't exploded. Now, go back up to stock. And remember, we're going to print out self.name, but we've never set the name. Oh, bad things are going to happen. Let's watch this fail and then understand why it's failed. Uh-oh, attribute error, tiger object has no attribute name. Remember, we are overriding this constructor, so we have to initialize that. And it's simply because we didn't do it like this. If we had it here, it'd be initialized right in the feline, and it's initialized for us whenever the feline is constructed. But because we didn't do that, we're relying on the feline constructor, and in the tiger, we defined our own constructor. It never gets called up here in feline. That is super confusing. So the major takeaway here is, unless you have no other choice, do not override the constructor in a child class. Always rely on the parent constructor. Otherwise, you have to make sure that you are calling either the constructor or you're initializing the variables in here. Oh, that's why this is called look before you leap, because we want to make sure that we actually can do something. We want to make sure the name is in the parent. That is the look before you leap principle. So this is what we're doing right here is we are making sure it exists, and look before you leap, there's a lot more to it, but that's the basis. Now let's go ahead and run this. Suddenly, no name stalking. Where's it getting no name from? It's getting it from right here. So we're saying tiger create, and then we're saying go to the feline and call that constructor, but we don't have a name, so we're just going to say no name. We could put anything we want there and it would work just fine. Let's go ahead and rename this now. So I'm going to say t.rename. And let's go ahead and call this Tony. And let's just say t meow, just to prove that we are inheriting the attributes of the feline class in t.stalk. Let's call that again. I'm going to bring this way up so we can see this in action, clear that out, and run. Okay, so what is happening here? Creating a feline, creating a tiger. The tiger is created, no name is stalking. We've renamed it to Tony. Tony is now meowing and stalking. If we go back into constructor land and comment this out, we're going to have a bad time. I want to really drill that into you. The reason why this is crashing is because we are bypassing this constructor and name is never defined. Let's watch it fail again. Sure enough, tiger object has no attribute name. Okay, so major takeaways from this video is that inheritance is extremely cool, extremely powerful, but has some hidden issues you really need to pay attention to. Do not override the constructor unless you absolutely know what you're doing and you want to make sure you take ownership of that process if you do. Easiest way is to call super init and call the constructor of the parent class. But there are other little gotchas as well, and you need to make sure you look before you leap or you do some sort of error checking or you're going to have some kind of crazy issue. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian, and we're going to talk about multiple inheritance. We've covered classes, we've covered inheriting from another class. But what if you have multiple classes you want to inherit from? That's exactly what we're going to do. Some languages don't even allow this because it gets so complex. Let's dive in and take a look. Let's go ahead and make a class here. So we're going to make a vehicle class. We're going to say class vehicle. And if you remember from the last video, I definitely love to make sure that the instances of the variables are actually created so we don't get that nasty not defined error. I'm going to go ahead and say drive. Notice how we're not putting in an it here. We just simply don't need it. We're going to leave the default constructor. And I'm going to say self, comma, and then speed. We're going to keep this just super ridiculously simple. We're going to say drive. We're going to set the speed. We're going to just copy and paste this. And I want another function called stop. We're going to just set the speed to 0. We don't need that parameter there. Now let's go ahead and make another function called display. And this is where things are going to get a little bit interesting. Take special note of this function because we're going to do this function again in another class. I'm going to say print. And we're just going to simply say driving at whatever the speed is, speed. Very simple little self-contained class here. Let's go ahead and make another very, very simple class. I'm just going to make a freezer class. And this thing exists solely to, well, freeze food. There's a freezer. And let's go ahead and make a variable. Let's call it temp equals 0. So we're just going to set the temperature to 0 by default here. Now I'm going to say def freeze. So we're going to be able to freeze some food at a specific temperature. I'm going to say self.temp equals whatever temperature we just handed it. And let's go ahead and print out freezing, just so we know that the freezer is actually going to, shockingly freeze the food. Now I'm going to actually grab this right here from the vehicle class, def display self, and we're going to modify this, but we're going to put it in our freezer class. You don't have to copy and paste it, just as long as the name is the same. What we're going to do is intentionally create a naming collision between these two classes. So both the vehicle and the freezer have a display function. I'm going to say freezing at self.temp, because there is no speed in the freezer class. Very, very simple, very easy to understand. So what we can do is call these independently and call display and see exactly what's going on under the hood. Now let's see what happens if we use multiple inheritance and smash these two together. Okay, let's go ahead and combine these two together. We're going to make a freezer truck class. I'm going to say class freezer truck, and we want a freezer and a vehicle. We're going to smash those into one giant class, and initially I'm just going to say pass. So we're just declaring the class and it does nothing else. That's what pass does in Python. And we're going to go ahead and create it. I'm going to say t equals the freezer truck t.drive, and we want to go at 50 miles per hour. I'm here in the States. That's actually relatively fast. And then we're going to say t.freeze. I'm going to put this at -30. Because whatever we're carrying, we don't want it to, thaw out on the way to the store. Then I'm just going to go ahead and print, and we are going to print out some dashes here, just to kind of separate. Now we want to say t display, and pop quiz. We have multiple displays. We have the freezer class display and the vehicle display. Which one of these is going to be displayed? So we're either going to see freezing at or driving at. Which one is going to happen here? Let's find out. Save run. Freezing at -30. And we don't get the speed. We don't see that driving at. So now we've got multiple problems. We want to be able to see both of those. But what we've defined, whether we realize it or not, is a new concept called the method resolution order, or the MRO. And you'll hear this time and time again. You'll see people in forums asking why you access it or why this is happening. So the order is very simple. It's first come, first serve. So we defined freezer first, therefore it's going to display the freezer. And if we just switch these around, we're still doing the same thing. We're still inheriting both of these. But watch what happens down here. Driving at 50 speed. So that is the method resolution order. It's first come, first serve. Ah, that is frustrating. So how do we get past this now? Let's say def display self. And let's go ahead and let's print these out. Let's say print f. I want to show you a little trick here. I want to make sure these are actually subclasses. So I'm going to say is a freezer. We're going to say is sub class. And we want freezer truck. So basically we're giving it the current class. We're saying, so it's freezer truck, a freezer. Then we're just going to say is a vehicle. I'm going to grab that. Go down here, bang. Watch what happens when we call display now. Is a freezer true? Is a vehicle true? So now we are calling our own function, and we can actually determine whether or not it's inheriting a specific class. The class you want to check is always first. The class you want to check against is second. So now let's go ahead and see how we would get around this. I'm going to say super. So we're going to call the parent. The problem is we have two parents now. So let's try calling them independently. Say freezer, self dot display. And I'm going to take the same thing but we're going to use the vehicle. So we're saying super, call the vehicle, super, call the freezer, using the self object, the current object, and call display directly. And see, let's just see what happens here. Uh-oh, we had a bad time. So let's look at this in depth here. So on line 42, T display. So this guy down here, and then it's jumping up to line 36, which is this guy right here. Super object has no attribute display. Now wait just a minute, we do. So if we look at freezer, it's right there. What is going on here? Well, again, method resolution order is popping in and saying, nope, can't do that. So just to prove it, let's comment out freezer as vehicles first. Let's run this again. Everything magically works. That is super frustrating. All right, so let's go ahead and just comment these out. This is not what I'd consider the correct way to do it, but I'm going to put some comments in here just in case somebody grabs the source code here. So what's the best way or the correct way of doing this? Well, we're going to call that class directly, and there are other ways, probably even better ways, but this is what we're going to do with our limited knowledge set of Python at this moment. We're going to say freezer dot display. Remember what I said, when we inherit an object, Python's creating it. So it knows that the freezer truck has a freezer in it. So we're going to call freezer display. We're going to call vehicle display. And let's watch this work. Now we can see we are freezing and we are driving. Oh my gosh, super confusing. So the major takeaways from this video is Python does allow multiple inheritance, but it has some gotchas, mainly naming collisions. For example, we saw that the vehicle and the freezer have a display function, but once we inherit both of them, MRO steps in and says we're only going to use the first one. So if we want to use multiple, we have to independently call them. Super challenging, but once we wrap our head around it, it's also very elegant. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to take everything that we've learned so far and make a pet shop application. This is going to be like a mini inventory system. So let's talk about the design real quick before we dive into this thing. First thing that's going to happen is Python's going to start our script. From there, what we're going to do is we're going to go out to the disk and we're going to load any existing file. Then we're going to go into a loop. And let me find a good representation of a loop here. And this loop is simply going to ask them, what do you want to do? It's going to do something like this. You have a few options that you can choose from. Any one of those options is going to go right back into the loop. So let me just grab this, go right up into here. And eventually, we will exit the program, at which point it will automatically save the progress. The end result is going to look something like this. Start, to load, to loop, some options, and then we're going to save when we exit. Let's dive in and take a look. Okay, moving right along, we are going to import. I'm just going to plop some notes in here so we can kind of see the structure from the image we had in the previous little section. We're going to make some imports, make a class. The class is going to have some functions. We're going to have our main function, then we're going to do some testing. But first things first, we need to import what we're going to use. So we're going to use two things. We're going to import JSON and os.path. JSON is going to be used to save and load that file. We want to have a dictionary. We want to be able to persist that out to the disk. And then import, we're going to use the os.path. There are more modern ways of doing this, but we want to be able to check if the file exists. So we're going to use os.path because that's kind of like the old school way of doing things. Once we have those imports in, we're ready to rock and roll. Now, inventory systems can get a little bit complex. So what I want to do is I want to make a class and I want to wrap the functionality in this class. So if we had multiple inventories, we could handle it separately. So I'm going to say class inventory. And let's go ahead and make a dictionary. And we're just going to make some functions. So we're going to do our initialization. And for these initially, I'm just going to put pass because we don't really want any code in here just yet. We're going to fill this in as we go. We're going to add. And we can speed this process up just a little bit here. So we're going to add, remove. I do want to be able to display what's in the inventory. We also want to be able to save, obviously, because we're going to put this out to a file. And because we can save, we also want to load this. Now you may be wondering, why am I not putting this into a separate file? I kind of want an all-in-one solution just to show you that we can actually do an all-in-one solution. Next step, now that we have our classes, we're going to start filling in these functions. All right, so far we have a class, and this is kind of a high-level view of this class. It's got init, add, remove, display, save, and load. We're going to fill in init and add. So let's go down to our init, and honestly, I want to keep this just ridiculously simple. We said in the very beginning, as soon as this thing starts up, we want to be able to load. So I'm going to say self.load. load. And we're just going to put all that functionality in that function. Now add is going to be a little bit different here. I'm going to get rid of this pass, and we are going to modify the function itself. We want to have a key and a quantity. The premise being, when we add, we're going to add some sort of animal, like a cat, a dog, or something, and a quantity that we're going to add into the inventory. So I'm going to say the Q, short version for quantity, is going to be 0. Now, if you look at our dictionary, there's absolutely nothing in it. So we can't just go out and grab the key. We have to actually test to see if it exists first. So if key in self.pets, then we're going to go ahead and grab the current value, like how many we actually have in the inventory. Self.pets, and we want the key. And we're going to update our quantity. So we're going to say, take that current value and add the quantity to it. Now we have the opposite of that. It just simply wasn't in the inventory, in which case we're just going to say Q equals the quantity. From here, it becomes pretty straightforward. We're going to say self.pets, whatever the key was, and we're just going to update that with our updated quantity. From there, I'm going to put, and just for the sake of time, I'm going to copy and paste, added the quantity and key, and the total is now whatever is actually out in our inventory system. So it's pretty simple, but there's a couple key concepts you have to wrap around here. First is, we don't want to trust that the key is actually in there. We want to test to make sure it exists, and we want to have some functionality in case it's not there. Back at the top of our file, we've done our imports, we've created the class, we've filled in init and add. Now we're going to do remove and display. So let's go down here, and remove and display just have pass in them. So the first thing I'm going to do is I'm going to go to add, and I want to kind of copy this. That way we have a very similar, very structured API. To add or remove, you just need a key and a quantity. We won't have any weird data that we got to figure out. So remove is, well, the exact opposite here, but we can actually pull parts of this out. So for example, we can just take this entire structure, just paste it right in here. So we're going to start off with 0. We're going to say if the key exists, then go ahead and get the key. And then the quantity instead of addition is going to be subtraction. And then we want some sort of other value here. So for example, I don't really need an else because Q is already set to 0. Actually, let me put that on the right line. So what we're going to do here is now test to make sure that we didn't subtract too much. Say if Q is less than 0, then we want to make sure that Q is equal to 0. In other words, you don't want a negative balance in your inventory. That just simply wouldn't make any sense. And then, of course, we are updating the inventory, and now we've got some sort of display going out to the end user. We're going to say removed, quantity, key, the total is now whatever the total is. Now for our display, this is going to be just very, very simple. For key, comma, value in, and we want to go into the self.pets.items. And if any of this that I've been talking about is just making you scratch your head, I'd highly encourage you to go out and watch the videos where we talked about these key subjects here. For example, we've talked about classes, we've talked about dictionaries, we've talked about for loops and things of that nature. We've also talked about JSON, and pretty much everything we're talking about we've done in the 32 other videos that we've done here. So, and let's go ahead and print this out. So I'm going to say print, and I want to do a formatted print, and I want to say the key equals, and then whatever the value is. Now, what I typically like to do at this point before we start getting into I/O is actually run this just to make sure we don't have any crazy errors. The script's going to do absolutely nothing. We don't even have a main function. We just want to make sure it doesn't have any weird syntax error or anything like that. Okay, in our class, we are at the save part. And let's kind of go down here all the way to save. we're going to handle save and load in separate sections. So we're just going to focus on saving. So I'm going to get rid of this pass. And I want to print out to the user that we're going to do something because we're working with Python, I'm just going to be brutally honest with you. We don't know what sort of end device this is going to be running on. It could be a high-end, blistering fast server. It could be a painfully slow embedded device. We simply don't know. So I want to tell the user we're going to do something. Saving inventory. And I typically do this whenever I'm working with anything I/O related. I will tell the user before and after, meaning I'm going to do something and I have done it or I had some error or something like that. So I'll start off with a structure like this. Saving and saved. And then I'll actually work with I/O. The reason being, if you're looking at a computer, the computer's hard drive is probably really fast, but if you get into like an embedded Linux device and the script is running on that, it may be really slow. Or what if the hard drive went to sleep? I'm sure you've had that before where you go to save a file and then you hear the hard drive spinning up. We want to make sure the user knows our application didn't freeze up. So we're going to say with open, and let's just say inventory.txt. Now this is where we're going to kind of break our own rules just for the sake of time here. We are talking about putting all this in a class so that it can be reused. The problem is now I'm hard coding the file name in there. Not a major deal breaker, but if you're going to use this for any sort of production, you're going to want to actually be able to dynamically set that string. All right, so with open, and we're going to open this file in write mode, plain text as F. F is shorthand for file. We're right here. Now we want to do a JSON.dump. Now remember, there's dump and dumps. You see the S at the end? We're going to convert it to a string. We don't want to do that. We want to actually dump it out to a file. So first things first, we have to give it the object, in this case, the self pets, and then the file that we're going to dump it to. And the great thing about the with keyword, we've covered this before in previous videos, is it's going to automatically close that file for us, so we don't have to worry about flushing the contents or closing the file or anything like that. So JSON's just going to take this dictionary, convert it into a JSON format, dump it out to the file, and then with is going to close the file for us, and then we're just going to print out saved. That way the end user knows, hey, we have actually done the I/O completely and there were no errors. We've only got one more, the load function. Oops, help if I selected it right. So here's our class. I've tried to indent it to make it a little obvious what the functions inside the class are. We've got one left, load, and of course it will load the file. We've already done save, so we can just kind of borrow this little structure here. So let's grab this and just paste it. And we can say, we can spell it right, loading inventory, and then loaded. And then with, and remember the file name's important, so we have to say with the same file, we're going to go ahead and read that as plain text. Now we want to do the opposite of a dump. So this is where we need to slow down. We've gotten a little ahead of ourselves here, and I'm wondering if you can see the problem. And in case you can't, with open file, we're just assuming that when we load, the file exists. And we need to be a little bit careful with that because that could cause some real problems. But that's why at the very beginning of this, we did an import OS path because we're going to check to make sure the file exists. So let's go back down here and we'll say if not os.path.exists. And here we want to make sure we have the same file name. So I'm literally just going to copy this and paste it. Then we want to say print skipping nothing to load. And then let's go ahead and return out of here. We're doing this because when the load function is called, it's going to print out loading inventory. And if we just, return, it's going to look like the program's hung because it's going to just say loading inventory and stop. So we want to make sure the file exists. And if it does not, then we're going to say skipping nothing to load. That way the user knows there just simply isn't a file there. And you could make this a little prettier. And then we return out. However, if there is a file, we're going to say with open that file up in read mode as file, And now we need to do a JSON load instead of a JSON dump. I'm going to say self.pets equals JSON.load. And remember, there's a loads s. If it ends in s, it's going to do it to a string, and we don't want that. So we want load, and we're just going to give it our file. And then last but not least, we're printing out loaded. That way the end user knows, hey, we successfully did our IO to completion, and we didn't have any bad issues. Again, I like to run. Script's not going to do anything, but if I have like a major syntax error, it'll definitely spit it out and tell me, and we're good to go. Looking at our little flow here, we've come a long way. We've done the imports, we've done the entire class, and now we're down at main. We're going to put a main function in here. So I'm going to go all the way to the bottom. And I'm going to say main, and it's going to put this in here for me automatically. Depending on your IDE, you may have to actually type that out. Or saying if the name is main, meaning Python is running this file directly, then I want to call a main function. Now, a lot of people will want to just use this as if it is some sort of function itself. I don't like doing that. I like actually making my own main function. That way I can actually just copy and paste this function and use it in other places, whatever I want to do. So we need to make an instance of our inventory, because remember, a class is a blueprint. It's not actually the object. So now we're going to take that blueprint and tell Python, take the blueprint and create an object from it, and give us that object in the form of a variable named inv, short for inventory. Now that we have that, what we can do is create a loop. And I know in past videos I've said loops are the root of all evil and you should avoid them unless you know what you're doing, but if you've been following along, we should know what we're doing at this point. So first thing we're going to do is prompt the user for some type of action. So I'm going to say the action equals, and we want input. And we're going to tell the user, hey, tell us what you want done. And I've already got this keyed up and ready to go in my notes off to the screen here. I should say off the side of the screen. So we're going to say actions you can add, remove, list, save, or exit. And these are the actions we're going to flesh out here. So first things first, if the action is equal to exit, then let's go ahead and break out of this loop. Notice I'm not returning because I want to actually do something at the end of this. And let me go back here, and we're going to say inv.save. So no matter what actions the user takes, once we're done with this loop, the inventory is going to save itself before the program exits. I'm going to put it right here, exit. The way Python treats a script is once it has nothing else to do, it simply exits out of Python itself, and that's why you see it stopping down here. All right, so once we've got this in place, now we just really flesh out the other actions. So I'm going to say if, and we can actually just copy this, make life a little simpler on us. Big fan of copy and paste here. I'm going to say if the action is list, then I want inv.display. If the action is save, we can go ahead and say inv.save. And you could do load and all that other stuff. You notice how I didn't put load in there because the inventory is going to load automatically in the constructor. But you could, if you really wanted to go crazy, you could put that action in there. Definitely put it in there if you wanted to. Now I'm going to put in right here a little bit of logic where we're going to say if the action is add or the action is remove, then we're going to take pretty much the same type of functionality here, because it doesn't matter if we're adding or removing, we have the same API. And let's kind of scroll up here. So remove, we want key and quantity. Add, we want key and quantity. So it doesn't matter which one we're doing here. So in here, I'm going to say the key equals input, enter, and animal. And for the quantity, input, we'll say enter the quantity. Now that we have those two, we need to figure out which one was actually called. So I'm going to say if action equals add, then do something. And if you already know a bit of Python, you probably know there's better ways of doing this, but we're just using what we've learned so far. So I've got to kind of, I don't want to say dumb it down, but I've got to make it a little bit rudimentary here. So, and this is where we're going to just branch off in our logic and say, if it's add, do one thing. If it's remove, do the other. There we go. Oop. Probably help if I actually called remove. Otherwise, we're just going to add it twice. This is the beautiful part about having the same type of API, if you will, is you can now start wrapping functionality in here and make it super streamlined, super easy to follow. So following our logic, and let me just grab some screen real estate here. When we go into the main, we're going to create an instance of the inventory, and then we're going to start a loop. After the loop's completed, no matter what the user's done, we're going to save that inventory. In the loop, we're going to continuously ask the user, what do you want to do? And then take action depending on what they entered. The only thing left to do is fasten your seatbelts and let's test this out. So if you have if underscore underscore name underscore underscore equals main, and you've got your main function and you don't have any syntax errors, you should be good to go. Let's go ahead and grab some area here so we can see the program in action. We're going to run this. And it says loading inventory, skipping, nothing to load because we don't have a JSON file here. And it's going to say actions, add, remove, list, save, and exit. So let's go ahead and add. And I want to enter a cat. And I want to enter a quantity of 6 cats because you have to have 6 cats in life. It's mandatory. And it's going to say added 6 cat, total equals 6. So let's add cat. And I want to add 3 cats here. So we've added 3 cats and total 63. We have a boo-boo in our program. Let's go ahead and let's kill this terminal. Let's figure out what we did wrong here. Notice anything funky about the output. It said 63 instead of 9. We need to convert this now to an integer. Remember, we talked briefly about casting, where think of casting like a wizard with a magic wand. He's going to cast a spell and convert it from one thing to another. Really what we were doing under the hood is we were saying quantity and then action add, go up here. And it's saying v plus qty. This is the blessing and curse of Python and other languages like this where you don't have a type. It knows that they're both strings, so it just adds them together as a string. So a string will look like this, which is exactly what we just saw. Okay, enough of that. Let's go ahead and rerun this. Now, because we killed our console, we still don't have a JSON file, which is exactly what we want at this point. So let's run this fresh. All right, let's try this again. Add cat 6, because you have to have 6 cats in life. Say it with me. We're going to add cat, and we want to add 3. Now we have a total of 9. So our logic is now working as expected. Let's go ahead and let's add a dog. Let's say we want 99 dogs. And then we realize that's a lot of dogs. We really can't have 99 dogs and 9 cats. So let's just take that down a notch and let's remove dogs. And man, you know, I like dogs just as much as I like cats. So this is a very difficult time for me. Let's go ahead and remove 98 dogs. I'm very sorry, dogs. Today was not your day. We've removed 98 dogs. We now have a total of 1. Now we could type save, but I'm just going to exit. Saving inventory save. So it automatically saved for us. And it put this inventory.txt. If we go out here, we have 9 cats and 1 dog, and everything works as expected. I'm going to clear our console. and rerun this, and something magical happens. Loading inventory loaded. Let's go ahead and call list. We have 9 cats and 1 dog. So it has now loaded that JSON file, loaded it up into the dictionary, and everything's working as expected. I'm going to go ahead and say, just enter, enter, enter. And you can see, because it doesn't have valid input, it just goes back into the loop. So I'm going to enter just garbage. Doesn't matter what we do. I'm going to go ahead and add fish, and I want 45 fish. I'm going to go ahead and intentionally save this. Saving inventory saved. And I'm going to go ahead and display. Basically, you can do this all day long, but display. I don't want display, I want list. You can see how we have 9 cats, 1 dog, and 45 fish. We could do this all day, but really what I'm getting at here is now we have some programming logic and everything's working as expected. So I'm going to go ahead and exit out. Going to save our inventory. We can go ahead and peek at it. And sure enough, everything's exactly the way it was when we finished the application. All right, major takeaways from this video. This is kind of the culmination of everything that we've learned so far. We've worked with imports, we've learned classes, we've learned functions, we've learned flow control, we've learned about main, we've done some testing, we've learned about JSON, the OS path, and kind of breaking this down here. Always, always, always initialize your variables, even if it's just empty, because you don't want to have something not defined. Constructors are your friends because you can set up some sort of default action. And when in doubt, always check your data types. Make sure you're giving the user some sort of visual feedback. And there are times where life is not that simple and you'll need to check to make sure whether a file exists or something like that. We've also covered things like the with keyword and how to read and write files in plain text. And I think we did cover binary as well. But one major takeaway, some minor tweaks to this is do not hard code the file name like I did. I kind of just did that to save some time. But you may want to actually ask, like if you wanted to really tweak this, make like another function and put it in the constructor and basically say, if we don't have a file, what file do you want to work with? And just let the user enter it, something like that. So I hope you found this educational entertainment. Drop a comment below and let me know what you think. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. In this video, we're going to talk about the underscore. The underscore is often ignored, has multiple uses, and just gets downright confusing. One of the hurdles of learning not just Python, but any language is the syntax. And Python's syntax is a bit different than other languages, so it often leaves people, even seasoned programmers, a bit mystified as to what these things are. For example, you could have a single underscore, you could have a double underscore, it could be before, it could be after, or it could be a combination of before and after. But each one of these different methods has, well, a slightly different reason for being, and we're going to dive in and take a look. The first use case we're going to do is a single, and it's going to be skipping. Now, when I was a young lad, I used to skip school, and it just did not do me any favors. But in this case, skipping is actually a positive thing. We're going to say for x in range, and I just want to print out hello. And I want to print out hello, say like 5 times or something like that. So I'm just going to put a number in here. Now, do you notice a fundamental problem? X, it's not used. The code runs just fine, but if you run this through any sort of streamlining program or any sort of interpreter that's going to try and tell you how to make your program faster or better, it's going to start complaining that X is not used. So what we can do is just simply replace X with a single underscore. Let's go ahead and clear our program out, and you'll see that it runs exactly as expected. Basically, by using an underscore as a variable, you're saying, I don't care, I just need a variable, and I'm not ever going to use it. Python, make a variable, and then get rid of it. That's really what we're saying. So in a sense, we are now skipping the whole variable process. Now, to really dive into the complexity of the underscore, we need to make a test class that we can play around with here. So I'm going to go in here, say person.py, and let's go ahead and say class person. And for right now, I'm just going to say pass. So all we're doing is just simply creating that class, and then we're going to go ahead and import it. Or say from person import star. Just note that we're going to be flipping back and forth between our script and our class because I want to really demonstrate a lot of the usage of underscore, and it's not really apparent why it's needed unless you're working inside of a class. First thing we're going to really look at here is called the weak private, and it is the single before. If you scroll up, this is what it looks like right here. And it's for internal use only. It's called a weak private because we're playing around with scope, and this is why I made a class, as we're about to see here. So I'm going to get rid of this pass. I'm going to say weak private. So when you get the image in your mind of a weak private, what are we talking about here? Well, we're talking about scope as far as internal or external. If something's private, it's internal to this class. If it's public, it's external to the class. A weak private means that it's internal to this class, but that safeguard is weak, meaning you can access it outside of the class, even though you really shouldn't. Let's go ahead and demonstrate here. So I'm going to say underscore name equals no name. What have we done here? We've made a variable called underscore name equal no name. That single underscore denotes that it is a weak private. We're telling the world that, hey, we want to use this internally. We don't really want the outside world playing around with it. However, we can demonstrate why this is a weak private because we can actually play around with this if we wanted to. Now, I would highly encourage you not to play around with your privates, but if you really feel inclined, just, make sure you keep that business to yourself. And we're going to say self.underscore name equals name. Fairly obvious what we're doing there. We're just saying the self name, this guy, is going to equal that argument. Now we can go ahead and print this out and just verify that it did actually change. Let's flip back here and let's see it in action. So I'm going to say p equal person, p, and we want set name Brian. Go ahead and run this, see what happens. Sure enough, name set to Brian. So it's working as expected. Now, oftentimes you'll get asked, if you go variable dot and your IntelliSense pops up, you see all these things with underscores. And there is underscore name. Interesting. So really now what we can do is we can grab this guy and do things with it, even though we really, really shouldn't. Let's demonstrate. So I'm going to say weak private, and let's go ahead and change this to p name. So now we can actually read the weak private, and even though we really shouldn't, I'm just going to say no, even though we really shouldn't, we can access and modify that weak private. I put no because you should never, ever, ever do that. If you see an underscore in it, do not try to modify it, even though Python will let you do it. Bad things could happen. That underscore, that single underscore, denotes its internal use only. And we say internal to its scope, in this case, the class. So yes, whomever made this class is nice enough to let you access it. You really shouldn't. You shouldn't rely on that. Instead, you should rely on functions to get and set values. Okay, let's just take a step back and let's think about scope for a minute. We've talked about internal use only weak privates, but now we're going to talk about the double, and it's before. This is internal use only, and it avoids conflict in a subclass. and tells Python to rewrite the name. It's also called mangling. So what are we really talking about here? Well, we're talking about a variable that starts with 2 slashes in front of it. What we're doing is we're telling Python we want it for internal use only, and take another extra step and change the variable name automatically. Ooh, that sounds kind of scary. So let's go ahead and figure out what we need to do here. So let's jump into our class, and I'm going to make a note here so I don't get lost. Strong private. This is what we're talking about here. You want to have a strong private. All joking aside, let's take a look here. So I'm going to say def, and I want __ think self. Seems pretty simple, actually, when you think about it. So I'm going to print thinking to myself. I mean, no one can really read your thoughts, and if you could, well, we'd all probably be in a lot of trouble. We're going to say def, and we're going to make another function called work. And I'm going to say self _ think. And because we're in the same scope, everything works as expected. But now let's introduce another class. Child. And we've talked about inheritance before, so this should be nothing new. Just going to inherit the person class. And we're going to say def test double. Just need a name. I don't really care what it is. And we're going to say self _ and notice how even though we're inheriting from person, it's not seeing __ think. It's just got that. Well, let's try to force it. So we're going to grab this whole thing. And let's see what's going to happen there. Let's go ahead and save our class and jump back to our script file here. And I'm going to make a new instance here. So I'm going to say p = person. Could have reused the other instance, but we're just going to do a whole new one. I'm going to say p.work. And let's watch this actually work. So thinking to myself, I can call it as expected. Now what we're going to do is try to do the same thing we did with a week, where we're going to go in here and we're going to say p.__ think. And notice how IntelliSense isn't even going to help us out here. We're going to just try and run that. And has no attribute. What's going on here is we've now made that a strong private, and mangling is happening in the background for subclasses. So we cannot even access that function. It's just gone. There's just no way to even see it from the outside world, but we can see it perfectly fine in our internal class. Oh boy. All right, so let's just comment that out, and let's play around with this a little bit further here. So I'm going to say C equals child. Remember, child actually inherits from the person. And in the child class, we have a test double, which is going to call self __ think, which is actually part of the person. Where are you? There you are. This is where mangling is really going to be demonstrated here. So I'm going to say C, and I want to say test double. Any guesses what's about to happen here? Let's go ahead and clear this, save run, and child object has no attribute child think. So that's really what's going on here, is we're saying that it's only allowed in that class in which it's declared. Pretty much, there's millions of uses for it, but really what you want to know is that if you want to make something private and to that class and only that class, you would do the double underscore. I'm going to go ahead and comment these out so we can move on. Let's go ahead and demonstrate a really cool feature here. We're going to talk about after any. Now, what are we talking about after any? Right here. Any number of slashes after. Really, there is a good use for this. Let's say I want to make a class object, and I'm going to call it person. Does anybody see the problem with this before I run it? Raise your hand. You in the back. Okay, class. You guessed it, invalid syntax because class is a key word. Oh, that is frustrating. I really wanted to name this class. Well, this is where we can do something like this. And really what we've done is we've created an entirely new name, but we can still call it class. It's just prettifies it. Is that even a word? Prettifies it, beautifies it. So we can use the word class, but we can still not have a naming collision with any of the keywords. And that's really what this is designed to do. Is it helps avoid naming conflicts with keywords. And then from here, we can just say something like print class, and then we can print it out, work with it as we'd want to. See, ta-da, made an object, and everything's going to work as we would expect. Wrap this whole thing up, we're going to talk about before and after, and we've used this before, and this is considered special to Python for functions like init and main and things like that. We've seen it before, but I want to kind of go into our class here and look at how we could actually use it. So let's go here. We're going to say before and after, and of course, we've done the init. In case you skipped that video, basically this is the constructor. But you notice the syntax here. We've got double before and double after. So basically what we're telling Python is this is going to be internal to the class, and we want to avoid naming conflicts, and at the same time, it will not mangle it for subclasses, but each subclass will have its own instance. That's how we can have a constructor for person and a constructor for child. We covered that in our video about the initializer. So let's go ahead and make our own function using before and after. I'm going to say def call. That would have been really cool if I would have spelled it right the first time. There we go. And I'm going to just say print call someone. So it looks pretty simple, and it's actually in the spirit of Python. It is dead simple, and it actually works as expected. So let's go ahead and say p equals person p dot underscore underscore, and you notice there's a lot of stuff in here that starts with underscore underscore. I'm going to say call, and we're just calling a function here. Say run and call someone. Ta-da, it works. Now, side note, I would not recommend starting any function that you want to be accessed outside of this class with an underscore, simply because the underscore starts with a weak private, which you're basically saying to the outside world, hey, this is going to be internal to the class. And it gets stronger from there, where you can actually start mangling it, or you can tell, everyone, hey, internal, don't want you to use it, but also don't mangle it. That's the before and after. When in doubt, double underscore is your friend, before and after. If you do it with the mangling effect for a strong private, you may start having some weird issues. So always keep that in mind. But the general rule of thumb is anything private is going to start with an underscore, and do not access anything private in a different scope. Even though we've demonstrated how to do it, it is not the best way of doing things. You should use a getter and a setter, which we've demonstrated like right here, set name. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. In this episode, we're going to talk about decorators. And no, it's not about making things prettier, although it does look a little better on the screen. So everything in Python is an object. That means even functions can be used as objects. And that's really what decorators are going to demonstrate. We can do some really cool things. At the heart, a decorator takes a function, adds some functionality, and returns it. Keyword returns it. All right, let's dive in and take a look. So I'm going to do a decorator, and I'm going to do it wrong. I'm going to do it intentionally wrong to show you how decorators actually function. So we're going to say def, and let's say test decorator. And I want to give it a function. Notice how that's just a variable. That's because everything in Python is an object. So say print, or then we're going to actually call that function. If you're a little confused here, we have a variable called func, and it is actually a reference to a function. That's because you can pass functions back and forth like variables. So it just simply says before, call our function, and after. So let's go ahead and say run, and nothing happens because we didn't call this function. Now, let's introduce the concept of a decorator. So I'm going to say def do stuff. And let's go ahead and say print doing stuff. Now, if you look at these two functions, they're very basic. I mean, this is very easy to understand. You have a function that has a function as a parameter. We're going to take that argument and then call it inside. So it's just, calling another function. So we've got our do stuff. Now, what a decorator is meant to do is say something like this. F equals, so we're going to get some function, and we're going to say test decorator do stuff. That's really what a decorator is meant to replace. So let's get rid of that and let's call the decorator. And this is where a lot of newbies really, really stumble. I'm going to say test decorator. It's really that simple to create a decorator. You just have an @ symbol with the name of the function over whatever function you want to decorate. Now, there is a sneaky little problem here. This test decorator is not returning something. So when I run this, guess what happens? And I'm going to go ahead and clear this out just so you can see it. Did you catch the problem? We never called either of these functions, but yet it executed. And that's because what Python's doing under the hood is it's taking this and saying @test decorator. It's going to take this and put it right here and then just immediately call it. So the code's getting executed even though we did not directly execute the code. That's a fundamental newbie mistake. So be very mindful of that. Let's take a look at an example of a real decorator. We're going to do this the correct way, and it's very, very similar. I'm going to say def, and I want to make bold. We're going to follow just kind of the same pattern here. And then I'm going to define an inner function. Now, before I do anything, I'm going to immediately return that inner function without calling it. So really what I'm doing is I'm passing a variable back. Very, very, very important you just kind of understand that concept of what we're doing here. We're making a function, and we have a function inside of a function, and we're returning the inner function. So in the inner function here, I'm going to go ahead and just pretty much take the same pattern here. So now we have a before and an after, and I'm going to, because we're making this bold, we're just going to say we're working with like some HTML. So we're just going to do the different codes for HTML. If you don't know HTML, basically what we're saying is start making this bold, stop making this bold. That's really all that is. All right, so now we can take that and say def print name. I'll capitalize that just so it looks a little better there. And then we're just going to go ahead and print whatever your name is. Now, we've learned from the last segment here that the @ symbol with the function name is the actual decorator, so I'm going to just copy that name, go @ and then make bold. Now, watch what happens when I run this. We're going to see this up here execute, but we don't actually see the Bryant Cairns. See? Ta-da! So really, what we're doing here is we're making an equivalent to, and I'm going to copy some stuff on the screen, or I should say off the screen. We're saying @makeBold is equal to function equals makeBold print name and then calling that function. But that function call is just returning this inner function. If that seems really confusing, think of it this way. @makeBold, so we're saying makeBold, take this function as the variable, and then we're going to say inner is going to be print, call our function, print, and then return the inner without actually calling it. So now we have this variable we can work with. Man, that seems super, super confusing. But in reality, it's very easy to work with here. Now we can just say something like this, print name, and call our function. And under the hood, remember, what's going to happen is it's going to go through all of this decorator, return this inner, and when we call print name, it's actually going to call make bold, and then call this code. Gets kind of confusing, but the results are pretty astounding. Okay, just in case you need a quick recap, @ symbol means we're using a decorator. We're calling this function. We're returning this to the function as the parameter. And then the inner function is going to run some code, and we're just going to return that inner function as a variable. So essentially, basically, what we're doing here is that we're calling that inner function, but we don't have direct access to it. And that's why people get so hung up on decorators. Once you wrap your head around that, they're actually pretty simple. Okay, if this was not confusing enough, now let's make it even more confusing. What if we wanted to pass parameters to this? How would we go about passing parameters to all these functions and inner functions and all this fun stuff? So that's what we're really going to look at in this little section here. Decorators with parameters. So let's say we want to make some sort of function called divide. And this function should, shockingly, divide things. So the problem we have with Python is, well, it is very weak typed. And what I mean by that is, what is A and B? Is it an integer? Is it a float? Is it a string? Is it a class? For example, can you divide A by cats? That's a really good question. So what we would need to do is something like this. Print A divided by B. Now, if we were to, and I'm going to just put some stuff out here, copy and paste. What do you think is going to happen if we do 100 divided by 3? What about 100 divided by 0? You're going to get division by 0 error. What about 100 divided by a string? Well, you're going to get some really bad results. Let's just run this and see. Yep, division by 0. Boom. Let's just try to bypass that, and let's do it again. And uh-oh, unsupported operand type int and string. Super, super frustrating. So what we want is a decorator that will check to make sure if we can even do the division, and if we can to actually divide and return the result, which means we're now doing type checking and we're passing parameters. Let's go ahead and make it real quick. So I'm going to say def, and let's call this numcheck. I almost wanted to call it numchuck, but gotta behave. All right, so numcheck, short for number check. This is going to be our decorator, and we're going to have two functions in here. I'm going to say def check int. Doesn't necessarily need to be an int, but just as an example, we're going to check to make sure it's an integer. And I'm going to immediately pass. And then let's say def inner. And in our inner, we want an x and a y. and you notice this has a defined number of parameters. What's going on here is we are matching the function call. See how we have 1, 2 and 1, 2. So pretty much we have 2 parameters. We want to make sure we are lining up with 2 parameters. We're going to show you how to get around this in the next segment, but I want to show you how to just pass the parameters, and that's why I have this at a specific number, 1, 2 and 1, 2. All right, so in our inner, I'm going to say simply, if not check int, and I want to check x, and we'll say, or not check int, and I want to check y, because we're going to check both of those, make sure they're both numbers. If they're not, we're going to return. Now notice how we're not returning inner. We're just returning, so it's going to take no action whatsoever. Then we're going to drop out here and say otherwise. We're going to return the function. And if you're confused about where we're getting that, it is the parameter for our decorator right up here. And we're going to return x comma y. Now let's go ahead and return our inner. And if this seems confusing, it's because this is bloody confusing. I'm sorry, it just is. I love decorators, but these are so confusing. So once we make this a decorator, and let's actually just do that right now. So Python's going to say numcheck, and then it's going to say divide, pass divide to this, which is going to go down into our inner and all this other stuff, and it's going to get passed around like hot potato and try to figure it out. That's confusing. That is so ridiculously confusing. Let's go ahead and do our check int, and then we'll step through this whole thing step by step, make sure we understand the logic here. So we'll say if is instance 0, comma, int. So we're just doing some type checking here, some real basic type checking. And then beyond type checking, we had that division by 0. So if it's an integer, we want to make sure if O equals 0, I want to let the user know something happened here. Print cannot divide by 0. Then we just want to return false. Okay. If we've gotten past all this, let's drop out here. We're going to go to return true because it is not 0 and it is an integer. So we should be able to do some sort of division. If we've gotten to this point and we haven't already returned true or false, I'm just going to say print, this is not a number. That'll get rid of our pesky string problem, and then we're going to go ahead and return false. Okay, so the base logic here. Man, fasten your seatbelt for this one. So our decorator is going to be numcheck some function. Our inner is going to come down here and say, okay, we've got 2 parameters, x and y. If not, and then check int on x and check int on y. Check int is going to say, is it an integer? If it is an integer, then we're going to say, is it 0? If it's 0, then we're going to return false. However, if it is an integer, we're going to return true. And if we have not returned out of there, we're going to return false and say it's not a number. There's probably a vastly prettier way of doing this. I was just hashing out some code real fast. Once we've said, okay, it is not an integer, or it does not pass this check int, then we're just going to return nothing. However, if we are able to, then we're going to return the function x, y, which means it's going to actually do our division for us. Wow, that's crazy. All right. We've got our decorator in there. Let's just test it with 103. Save, run. Sure enough, it returns 3.3 repeating. Let's try our division by 0. Cannot divide by 0. So it caught that. Now let's try to divide 100 by cat. And cat is not a number. Very cool, very functional design. without having to do a whole lot of back and forth, we can just simply define a decorator and then, you guessed it, use it. And we can use this over and over and over again. It makes it so simple once we get to this point. Okay, the last little section there was really, really confusing, but the main takeaway here is that you can get some really complex functionality out of a simple decorator. The big problem was we had 2 arguments, and only 2. What if we wanted to have an unknown number of arguments and we want to chain them together? Let's take a look. So I'm going to make 2 decorators, say def and a little outline. And initially, I'm just going to pass. We can take this, copy, paste. Let's call this list items. Now we're going to make another function, and let's call it display. Display is just going to display a variable called message, or MSG. Very simple, just going to print it out. Not sure where copy and paste has betrayed me there. There we go. All right, very simple, very easy to understand structure here. We're going to take these 2 and chain them together. And when I say chain, what we're talking about is something like this. So we've created a chain, and it looks like a chain because you got these little @ symbols or links in the chain. And these could, just to kind of give you a graphical representation here, it looks like you have a chain going down the screen. Really, it's first come, first serve, so outline will get called first, and then list items will get called second, and we could just keep adding and adding and adding if we wanted to. But this is the main reason why we have to return our inner function. So let's start fleshing these things out. Now I want to say args, which stands for 0 or more arguments, or 0 or more keyword args. If you skip that video, I highly encourage you to go back through the playlist. Link is down below. Watch the video and understand the difference between args and keyword args. And then print, we're just going to print out tilde times 20, because outline is going to shockingly just outline whatever we put out here. Now we're going to call our function with our star args and keyword args. Once we've gotten to this point, very simple, just return our inner. We've got our first decorator pretty much done. All it's going to do is outline our function. Very straightforward. Now, list items is a little bit more confusing, but not by much. First off, let's go down here and fix this. MSG, there we go. Make it a little more apparent what display is actually going to do. So we're going to def inner, and we can just go right up here and grab this. Save us a smidge of typing. There we go. So first thing we're going to do is just, well, I must have clicked something. There we go. First thing we're going to do is just call our function. Then we want to be able to list it out. But before we do that, I'm going to just print f, and we're going to say args equals, and I just want to see what Python is actually handing us. That way you can kind of wrap your head around this. We can do the same thing with our keyword args. And let's go ahead and return our inner. So now we have 2 different decorators that do 2 totally different things. We can then just call our function. And see them in action. So we got hello world args, and this should actually be keyword args. Notice what's happening. If you were expecting hello world with a bunch of tildes underneath it, no. So basically, list items is being called inside of outline. That's part of the chaining. So outline is being called first. And because we are now passing this other decorator, it's now forming that chain. See how that works? Here is our end right here. And to just kind of break that up, we could actually turn this into like a plus symbol or something, just so you can see the start and the finish. See? Tilde, plus symbols, start, finish. Very, very interesting the way that works. I absolutely love it. But notice right off the bat here, args is a tuple. Keyword args is a dictionary. Oh, okay, so that tells us exactly how we need to iterate through these things. So I'm going to say for x in args. Let's go ahead and print. And we're going to format that. Oops, format that. And I want arg equals, and then x. And we can do something very, very similar for our keyword args. Except for that's a dictionary, so we're going to do a key value pair. If what I just did on the screen looks like black magic, go back in the playlist. Link is down below and watch the video on the for loop on dictionaries. And we're going to do the keyword args.items. And then we're going to say key equals x and value equals, actually not x, sorry about that. Key is k and value is v. There we go. Save and run. And sure enough, arg hello world. Notice how it's not got anything in this dictionary here. It's because we have no keyword args. See, we're just adding a normal argument. So let's go ahead and do something a little different here. We're going to say def birthday, and I want some keyword args. Name equals whatever, and age equals 0. And I'm going to say print, format, happy birthday, whatever their name is. You are, whatever their age is, years old. Now let's go ahead and call our function with the keyword arguments. And we can go ahead and just reuse these decorators. So I'm just going to literally copy and paste. Notice how they're two different functions, two totally different things, and they even have different parameter types, but we can use the same decorators. Let's see it in action. Happy birthday, Brian. You are 46 years old, and now we have no args, but we have this nice dictionary, and we can get the key and value out of that. And if I just go up, you can see how it fired off both of them, and everything's working as expected. So decorators, main takeaway here is, well, they're complex, and they get really confusing really, really fast. But the biggest takeaway you should really understand from a decorator, going all the way back to the very beginning, is it's going to call this function right here. And if you don't return your inner function, it's just going to execute the code. So a real decorator looks something like this. You have your function, you've got your decorator. The decorator is going to have an inner function, and you're going to return a variable that points to that inner function. From there, really, the imagination you have is your limit. You can do just about anything you want, and these become highly, highly reusable, and you can make them as simple or as complex as you want, and you can reuse them across many different types of functions. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. In this episode, we're going to talk about iterators. They make counting easy, and we've actually worked with these before, but we're going to really dive under the hood and see what makes them work. So, for example, if you're really confused about what an iterator is, let's just say 1, 2, 3, 4. We've got a simple tuple here, and we're going to say 4x in t. Go ahead and print x. Run this. Voila, 1, 2, 3, 4. But how does that actually work? How does Python know how to go through each and every single item and how to treat each item? That's what we're really going to dive into in this video. Let's pop open the hood and see what's going on here. So we're talking about iter basics. Well, lists, tuples, dictionary sets, even strings, and vastly huge amounts of other objects are iterable. We use a function called iter to get the iterable object. Let's take a look here. So I'm going to say people equals, and we're just going to make a simple list here. Brian, comma, Tammy, and our family dog, the old lazy, stinky dog, Rango. And we want to iter through that. So I'm going to say I equals iter. And we're going to use that list right there. So if we go ahead and print this out, let's take a quick peek at what I actually is. It is a list iterator object at. So this is a separate object from our list. It's not the list, it's an iterator, which tells Python how to maneuver through that list. Okay, great. Now let's actually go through this. I'm going to say print, and we're going to call the next function, which is going to tell the iterator, hey, move to the next position. Assuming that this started at the very beginning, the next position is, well, Brian. So let's go ahead and run this. And sure enough, there's Brian. And now instead of knowing some sort of index, we can just say next, next, next. See, Brian, Tammy, Rango. And it's just going to keep moving or iterating through that list. Now, an interesting little bit here is if we try to go beyond the scope of that list, notice how it throws an error. It's a stop iteration. This is what Python's using under the hood to tell itself it needs to stop moving through this because it's simply hit the end. So we can continue on. I'm going to comment that out. But it's very important you understand what a stop iteration is and why it's there. It simply tells Python, hey, we've hit the end, stop processing this. Now that we understand the basics, we're going to make our own class. So we're going to say 4x in our custom class, iterate through it. And under the hood, it's going to call next and all that fun stuff. And we're not going to play around the stop iteration, but I wanted you to understand that exists. So if you're trying to push through next and you get some sort of error, you know what it's doing. Older tutorials, you would actually have to raise that yourself, so it gets a little confusing. We're going to do it the easy way, or I should say the Python 3 way. We're going to say import random, and we're going to make a random number generator, or a lottery class. A lot of people want to win the lottery. I know I do. Man, the things I would do if I won the lotto. So we're going to say def. We're going to init self. This is just simply our constructor, and we're going to say self dot underscore max equals 5. If you have no idea why there's an underscore again, watch the previous videos. All right, so def, and then we want to call iter underscore underscore self. And this is where we're really deviating from other tutorials out there, because other would have the iter plus you'd have a next function and you have to track where you are in some internal list. We're not going to do any of that because we simply don't need to. So in the iter function, we're going to use what's called yield. And yield is incredibly cool. I'm going to paste some notes here. The yield statement suspends the function's execution and sends a value back a lot like how a return would return a value. However, instead of returning out, we stay right here where we are, and we retain enough state to continue on where we left off. This is extremely powerful. So instead of returning, which is going to break out, and then we call this function over and over again, we're going to say for underscore, because I don't need a variable, in range. And we're simply going to say self._max. We're going to go ahead and call our yield, and we're going to create a random, and we want a rand range between 0 and whatever number the lottery commission would want as a maximum. All right, now we want to allow them to tweak this if they wanted to. So I'm going to say, just because I'm a nice guy, def set max self value. That way, whoever's using our little lottery class can set the maximum if they want to. From here, it becomes ridiculously simple to use. You're going to see other tutorials out there where they got all these functions and you're tracking some internal counter. Yeah, we're not going to play around with any of that. Go ahead and print. Just want to separate this out on the screen. Go and create an instance of our Lotto class. And let's go ahead and say lotto.setMax. And I want maximum of 10 values. Now comes the fun bit. We're going to say for x in lotto. Print x. So let's go ahead and run this, see what happens. Ta-da! We have got our random numbers. And we can even, if we wanted to, say we want, say, 50 of these. So it's going to kick out a lot of numbers here. Let's go ahead and clear that, and bang, there's our 50 random numbers. Extremely cool the way this works. So quick recap. What we're doing here is we're just simply making a class, calling the constructor, setting some internal values, and then we have this iter function. Other tutorials, you're going to see something similar to this, but it's also going to be followed up with something like next. And then you would have some code. We don't need that because we're using yield. And unlike return, yield will return the value, but then stay right here in this current context. And when the execution pops back, it will just continue on its merry way. Very cool, very powerful feature. Makes life very, very simple compared to how it used to be. Gotta love Python 3. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to continue our journey into Python 3 with the exceptions. So basically, bad things happen, and we need to know how to handle them. We've already seen that in these videos, and I'm sure you've seen it millions of times working with a computer where it just says like error, unknown error, access denied, or some other crazy thing. But we need to understand a subtle difference here. An error occurs mostly at runtime, and it belongs to an unchecked type. This is things like your hardware failing or your network connection dropping or something like that, something completely unexpected. There's really nothing we could do about it. Exceptions, on the other hand, occur at runtime and compile time, and occur mainly by code written by developers, meaning we are now creating our own problems. So, yes, we can write code to defend against errors, but we can never truly defend 100% against an error. Like how you defend against your CPU exploding. You just can't. Your code will stop working. Exceptions, on the other hand, would be like division by zero, wrong data types, things like that. So that's what we're going to really dive into in this video. Also, before we begin, I'm going to put a simple decorator in here. We covered this in a previous video, but just a quick recap in case this looks like ancient Egyptian algebra. A decorator is a function call that is used by another function call to decorate it. And basically we have a inner function that is going to return a function with any number of arguments or keyword arguments, and we're simply going to print out. And when I say print out, so you're going to see a bunch of dashes before and a bunch of dashes after we call that function. And just for a little bit of flavor, I put in the function name, and we're going to use this on every single function. To begin, we're going to look at the try, except, and finally. Now, this is going to be a little challenging to really wrap your head around at first, but what we're really doing here is we're creating some special scopes, and those scopes have special reasons for existing. So first things first, I'm going to create a function called test1. We're going to give it parameters of x and y, and I'm just immediately going to call pass. We're going to go ahead and use our decorator. Again, if you have no idea what a decorator is, or if this looks horrible, or if you don't understand this, watch the previous video I've done on decorators. But basically, when we call this, it's going to print, call the function, and then print again. That's really all we're doing, even though it looks kind of confusing. All right, so to dive in here, we are going to use try, and you notice we get some options in our IDE. Your IDE may look vastly different, and these look confusing. Try except else. Finally, so on and so forth. We're going to go over all of these, but the first thing I'm just going to do is just try. And got to end it in a colon. I'm going to go ahead and pass for the moment, drop down, and we are going to accept. We're going to pass again. Just going to flesh this out. And then finally, I want to talk about each one of these in turn. If you're coming from another language, this is basically a try, catch, finally. So try means we're going to try some code. It may work, it may not. So for example, we could say z equals x divided by y. And then we're just going to print out, whoops, we're going to print out, see what I mean? I'm creating my own errors here. The result. This code looks just, well, boring. It's just basic division, but what could we do here? Horribly, horribly wrong. We could do like a division by zero. And because Python isn't really strongly typed, we could send non-numerical values to this and crash this whole thing. We've seen this before. I've done this in this series before. So we're going to have to defend against that. So we want to do except, which is the basic version of like another language's version of catch. And I'm going to actually put that right here as a comment, catch. So if you're coming from another language, this is catch. It's easier to explain in other languages because it's like catching the ball. You're catching the exemption, or somebody's dropping the baby and you're catching it before it hits the floor. And the program, of course, is your baby in this analogy. So we're going to keep our program or catch our program before it fails. And we're going to now execute some type of logic. Something bad happened. Now, the problem with this is we don't really know for sure what happened. We just know that something bad happened. And we're going to look at later on in this video how to determine what happened and then take specific actions based on that. All right, but right now we're at really, really newbie land here. We just want to know something bad happened. Now, finally is going to be called no matter what. So try is an attempt. Except is, hey, catch it if it falls, something bad happened. We got to catch it before it meets a horrible, untimely death. And moving along is what I call finally. It doesn't matter what happens up here, finally is going to be called. Let's take a look. So I'm going to just print out complete. And in case you're wondering with my horrible typing, yes, most of the programming bugs are misspellings, mistypings, things like that, or just bad data types, things of that nature. So let's see this in action. We're going to say test 1, and let's do 5 and 0. What is immediately standing out? That 0. Very ugly. Let's check it out. Uh-oh. Function test 1. Something bad happened. So immediately, instead of having a division by 0 error and our program crashing, we were able to catch it and do something. Now let's give it another untimely death here. I'm going to say test 1. And let's say 5 and cat. How do you divide 5 by cats? I'd be really interested in knowing that. But let's try it again. And sure enough, test 1, something bad happened, 5 and cat. So we know that it's not doable. Let's just take this and let's divide. Copy and paste has failed me. There we go. Let's divide 5 by 2 and see what we get here. So the result is 2.5. So we know our function now works and we can defend against, well, exceptions. The biggest takeaway from this segment of the video is that you have a try, which is an attempt, exempt, which is a catch, and a finally, which is going to be called no matter what happens. You can see in each one of these examples, whether something bad happened or successfully ran, finally was called. That's your cleanup code. So we're going to change this to clean up. So think about this in terms of like I/O. You're going to write to a file. You're going to attempt to open the file and write to it. Something bad happens, and then you would close the file regardless. There are tons of built-in exceptions, and we're looking at the official Python documentation. I'm just going to scroll down. We're not going to go through all these because we'll be here all day. But there's the generic high-level one, and then it gets into very specifics like arithmetic buffer, assertions. Now, we're going to talk about assertions right now, but I want you to understand what's going on. Assertion is not a true error. It's something that we're actually creating. So we're going to assert that a condition is true, and if it's true, nothing happens. If it's false, though, an error is raised. See, raised when an assert statement fails. We're going to do that right now. Also understand that you can have tons and tons and tons of these, and you can even define your own. So, wow, lots of information to take in. But I'm going to leave a link to that out there, and we're going to just take code from the last one and just copy it. And we're going to do a bit of surgery here. Call this test 2. All right, so we've got our attempt, catch, and finally. And let's kind of change these around a little bit. First thing I want to do is add in an else. So think of this now like a giant if statement. We're saying if, and then if, and then else. So when we get to else, we trust this code and this code should run. I don't like doing this because what happens if something blows up? So then you end up doing another try exempt block in here, and I don't like doing them inline over and over. It just gets really messy. So we're going to move that here. I'm going to call this trusted code. And personally, I don't trust code. I usually do it up here, but you'll see this out there where people are going to say, else just do this. And when it gets here, you trust this implicitly. It can do no wrong. So attempt is now something we have to do some testing. So we're going to assert. Now, if you're a parent, you know exactly what an assertion is because you walk up to your child and say, you will clean your room right now. And if they do not comply, if you get a false back, then, well, bad things happen. They get grounded. So we're going to say x is greater than 0. Assert's going to go in and evaluate this condition. If it's true, nothing bad happens. However, if it's false, bad things happen very quickly, meaning it's going to say it's failed, and it's going to raise an assertion error, which we'll call exempt, and any other catch condition that we put in here. So let's just grab the previous tests that we had, and let's rename these. Gotta love copy and paste. making life simple. All right, so we're gonna do 5 divided by 0, 5 cat, 5 2. And let's go ahead and test this out. Move this up. All right, so we can see now that our assertions are working. So function is test2, something bad happened. So it's immediately saying assert failed and then printing this out. Assert is a powerful tool, but it's not perfect. We want to know exactly what happened, and we want to be able to handle things on a case-by-case basis. So typically what I'll do is I'll change this to exception as E or error or whatever you want to put in here. And then I will actually add in the issue. And then E, of course, has other properties if you wanted to dive into them, but we're just going to leave it as E, and we're just going to print E out here. And let's clear this out and rerun this. Let's see what's going on. Okay, so something bad happened. The issue is that is not supported between instances of string and int. So now we have some sort of typing issue. But notice how division by 0 never got caught. So we have a couple choices here. We can leave that in the catch-all, or we can do a division by 0 error, or we can make a custom error, however we wanted to do it. So if we wanted to catch a specific condition here, we're going to say except assertion error. Then I'm going to say print f and failed to assert x and y. When you look at this now, we have two exceptions that we're handling. We have the assertion error and just the general catch-all. So I'm going to put here specific. And you can chain these out to infinity. I mean, you can basically do every single error. But what I'll do is I'll do things that I would expect. Like if I fail an assertion, I want to know it's just garbage data the user gave us. Or if something higher level happened, I want to be able to catch that. But I want to be able to distinguish in the application the difference between the two. So if we fail an assertion, that's going to get called. If something else happens, this is going to get called. All right, let's try it out. All right, so something bad happened. All right, and then failed to assert. So you can see the two different ones firing off here. Failed to assert, meaning we failed our test. Assert y greater than 0. Let me see if I can get some room here. That failed, which triggered this off. But then you notice how y, if this was cat greater than 0, how does Python even begin to evaluate that? It can't. So it skips over and says, bad things happen. We cannot compare these two. So then it jumps down to the exemption code right here. So for our assertion logic, it's going to do this one. For other things, our catch-all is going to get fired off. That is actually really, really powerful. But one thing I want to really caution you on is not to go overboard with this. So for example, if you try to do like a exempt, what am I looking for here? Type error. And then we could just say like wrong type. And let's clear and rerun. And you see now it's saying wrong type, X and cat can't be compared. But what I'm doing here is my code is getting longer and longer and more complex. So I would say look for the specific errors that you absolutely must handle and let everything else fall into a catch-all if at a minimum you have just a catch-all that's still acceptable. But you want to be able to catch things. I rarely use else because now I am completely trusting all of this code to run without any single issue. And what happens if we do something like that? I just hit space. There's just a blank space right here. Go ahead and clear that out and let's run. Notice how our program, even though we have all the security baked in, has now crashed. and my IDE is not showing me, hey, there's a problem right here. This is why I tend not to use else. Let me go ahead and fix that before we move on and make sure everything's working. As you can see, this can get very complex. I mean, our little function here is now bigger than the screen. I've got to either zoom out, which will make the code small and hard for you to read, or I've got to, well, figure something else out. So we're going to add another complexity here. We're going to make a user-defined exception, and we're going to raise it, meaning we're going to create our own error and then catch it and show why you'd want to do something like that. So this is pretty typical in file IO. But first off, let's go ahead and make a class, and let's call this cat error. Because every cat has some kind of error. Why not? And so cat error is going to inherit a runtime error. So we're going to use the built-in class runtime error, inherit it, and now we have all of that functionality baked in. Let's go ahead and say def, and we're going to init self with and args. And I'm just going to say self.args. I always like that word, args. Sounds like a pirate. Anyways, we're going to say that is the args. So very, very simple class. You can feel free to make that as complex as you want, but just know that these error classes are meant to be very short-lived. The lifespan of these is basically from the time something happened to the time it's caught. You don't want these things lingering around. Their sole purpose is just to carry information about what happened. All right, so I'm going to say at outline, because we're going to use our decorator again. And I'm going to define, let's call this test cats. And we're going to test a quantity of cats. And then I'm going to do a try. Now you start to understand what all this gibberish IntelliSense was popping up in the very beginning. We can do a try exempt. We can do a try exempt else finally, blah, 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 and any other combination. I'm just going to pick try exempt finally. And it's going to do the code for us. Now, I don't really need all of this stuff. So I'm going to just change this a little bit to suit my needs. IntelliSense is great, but it doesn't always have to be the way they want it to be. So now I just have a try, exempt, and finally. What we're going to do in here is I'm going to say in our try, if not is instance, then we're going to test to make sure that QTY is actually an integer, because you could, hand it a string and we don't want to take some sort of mathematical operation on a string. Now, if it's not an integer, we want to raise. Now, raise is basically like throwing a ball. We're saying, you know what, this is an error, you go fix it. And we're throwing a rock or a ball at a window saying, here, go catch it. And if you don't catch it, your program's going to break and crash, much like a window would. Maybe I just made a joke about Microsoft Windows. I don't know. Anyways, interpret that as you will. So we're going to raise some type of error. And when I say type of error, I don't mean this, the class type error. I mean, this could be an assertion error or anything that inherits basically a error or runtime error. But for this case, we're going to do a type error because we know that there is a specific issue. And then from here, we're going to say must be an int. So you want to be very careful when you're raising an error that you raise the correct type. And this is one of the few times where Python really, really, really cares about the type. If you try to raise like a string or something, you're going to get some weird results, although I suspect you could probably do it. All right, so now we're going to check for a quantity. So we're going to go back here and say if QTY, and if we got to this point, we know, because this has not been raised, we know that this is an integer and we can work with it mathematically. So now I can say if the quantity is less than 9, then, well, who in their right mind would have less than 9 cats? So I'm going to raise our cat error and say must own more than 9 cats. Because I don't know what lunatic in their right mind would have less than 9 cats. That's why the cat error exists. But now what I'm really demonstrating here is we can make our own custom class as long as it inherits the runtime error, and we can throw it, or raise as it's called, just like any other except type. Very, very cool. Okay, so now that we've got this, I'm just going to say print, and we're going to format that out. I'm just going to say oops, because this is our catch-all. We're going to just say like, oops, unknown error, sorry, my bad. And we're going to say e.args. Now for our finally, I'm just going to say print complete. Notice how this is much more streamlined than this big bulky thing up here. This is what I'm talking about. Error handling can get very complex very fast. So general rule of thumb, try to keep it short, simple, and to the point. All right, let's go ahead and test out our cats class. I'm going to say test cats, and we want to, there's some crazy person that only has 3 cats. There's some crazy person that has 12.3 cats. I don't know how you would get a 0.3 cats. That's kind of gruesome. And then we're going to test for 11 cats. And we could, if we wanted to, even just really throw this thing for a curveball here and say ABC. Let's clear out our results and fire it off. All right, so we see must be an int. Must own more than 9 cats, must be an int. I mean, so this is now working as expected. So this must be an int, must own more than 9 cats, must be an int, and then, ta-da, finally, we have some sane person out there who did follow the directions. And I'm just going to, for clarity, you own X number of cats. Clear this out, fire it off one last time. You own 11 cats. You can see that you own 11 or you own whatever is not in there because we threw and caught the exceptions. So whenever you see try, think of this like playing baseball or some sport. They have the ball, and if something happens they don't like, they're going to throw the ball, and it's up to something else to catch it. And regardless of what happens, the sportscaster is going to, well, call it like he sees it and says, and we're done, folks. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everybody. My name's Brian, and in this video, we're going to talk about pickle, everybody's favorite. So, what the heck is a pickle? What are we even talking about? This made me giggle so bad when I first was reading about it. So, pickling is a way of saving food. It's a very old way of doing it, and we're going to do the same thing with objects. So, we're going to serialize them, which is a more modern term, but we're going to preserve an object, and that object can be saved and stored in another location, for example, on a disk. So that's right, you can make an object, save it, start your program back up, and reload that object like nothing happened. This is incredibly cool. This is called serialization, and it gets very, very complex. Pickle, while being great, is not perfect. It does have some limitations. I would encourage you to go out and research Dill, D-I-L-L, and there are other serialization tools out there as well to overcome some shortcomings of pickle. We're going to go over just the very, very basics of pickling. So, what can you pickle? First off, pretty much most Python data types and top-level classes, meaning if you make a class and a class and a class in a class, you're going to have problems. So, first things first, let's go ahead and import pickle. Okay, diving right in here. First thing we're going to do is we are going to put in a decorator. Same decorator that we've used in the previous videos. And if you missed my decorator video, hit rewind on the playlist and watch the decorator tutorial. In case you missed it, all it's going to do is print a line, print the function name, call the function, and print a line. All right, so our class is going to be overly simple because I'm focused on serializing and deserializing this. We're looking at just the basics of serialization. So we're going to say cat, and then we want to go def, and I'm going to init, and we want to init self with name, age, and info. So name and age seem pretty self-explanatory. We're looking for like a string and an integer. But what is info? That's why we want to really dive into this video. Things are not always what they seem. So we're going to say self.name equals name. And then we're just going to, through the magic of copy and paste, probably be best if I just grab it right out of the top there. And whoopsie, we don't want to mangle those. There we go. Almost created a little headache for us. So we're going to say self underscore name, self underscore age, self underscore info. Again, the underscore denotes that these are internal to the class, and we don't want other people playing with them. So from here, we're going to make a display function, and we want to display some type of message. Let's go ahead and use our decorator just to decorate that, make it look nice and neat on the screen. And then we're going to just print out the message, whatever the message is. But now we also want to print, and we want to put the name along with the age. Is a, or I should say is years old. That doesn't make much sense, does it? Probably help if I spelled all of that correctly. There we go. So name is a age, years old cat. There we go. Makes more sense now. And then we're going to take info, and that's going to be a dictionary item. So I'm going to say for K, comma V, in self underscore info items. That way we can iterate through those dictionary items and print them out. And then we're going to just say that equals that. Pretty self-explanatory what's going on here. So as you can see, this is not a super complex class. Just wanted to cover the basics of it so you knew exactly what we were doing. I'm going to go ahead and make an instance of this. I'm going to say Othello. This was the name of one of my cats. Unfortunately, Kitty passed away. He was probably the best cat I ever had, but I loved him to death. All right, so Othello, 15. And then we're going to make a dictionary. And color equal black. Weight, whoops, weight. He was a very fat cat, and he loves eating. It was like his hobby. It was almost like a competitive sport for this cat. And then we're going to say Othello.display. Just want to test this out before we do anything else. So we're going to say display, testing. Save and run. Uh-oh. Self-info. What do we got here? 38. Line 30. Ah, yes. A little bit of an issue there. See the previous tutorial I did on error handling. All right, so let's go ahead and clear that. There we go. So function, and we can now see our decorator is working as expected. There's our line. There's the function name, our message, and then Othello's 15-year-old cat. Color black, weight, loves eating, and then end decorator. So everything is now working. What we're going to jump into next is actually serializing and deserializing this object. Notice how we're not talking about serializing the class, because the class is a blueprint. We're going to serialize the actual object. All right, fasten your seatbelts. Here comes the pickle. I almost feel like I should have like a pickle with a cape on it or something. But so I'm going to say SC, which is short for serialized cat. And we're going to say serialized cat is pickle. I always giggle when I say that. So we are going to dump S. If you remember from a previous video, if it ended in S, it was a string. So that's exactly what's going on here. Same convention. So we're going to dump to a string. And we're going to dump the Othello instance of that cat to a string. Now I'm going to go ahead and just print this out. Save run. This is what Othello looks like after he's been pickled. Man, that sounds really morbid, pickling a cat, but so you can see some familiarity here, underscore underscore main, so you can tell exactly where that object is, and then it's got like name, and then you see Othello, and there's some data in here. So this is really what pickle is doing, is it's dumping it into a pickle format. This format is not compatible with applications outside of Python, and it's not what you would call backwards compatible, meaning you can't take the newest version of pickle and then serialize something and load it with an older version of pickle. That's a more advanced video that we'll get into in the future, but just keep that in mind, that pickle will try to use the newest version. So let's go ahead and save this. So I'm going to say with open, and we want some sort of file name. So I'll say cat.txt, and we want to write binary, because this is a binary file. We're going to write this out as f. Remember, if we do with, it's going to open it, give us a variable called f, which stands for the file, and it's going to close it automatically when we're done. All right, so we've got this, and we're going to say pickle dump. So this is the difference between dump s, dumps, versus dump with no s. Dump is going to say, what do you want to dump? I'm going to give it an object, and I'm going to tell it where. So we're going to dump that to a file. Let's go ahead, clear this out, and let's run it. So now we have this cat file, and it says file's not displayed in the editor because it uses unsupported text encoding. All right, so we're going to right click, and we're going to open with. And in a previous video, I showed you how to install the hex editor, but just in case, you go out here and you just type in hex, and there's a hex editor. You just install it. So flipping back, we're going to actually get rid of that. We're going to right click, open with hex editor. And this is what the serialized object looks like. You can see it is verbatim the same thing, but we've written these bytes out in a binary file. We can now take this file and say email it or transport it across the network or leave it sit on a hard drive, whatever we wanted to do, and have another Python program deserialize or open it back up. Okay, now that we've serialized and we wrapped our head around the serialization or the pickling process here, we're going to deserialize, which is the exact opposite. It's reading the information back. So I'm going to say my cat equals, and I want to say pickle dot load s, because we're going to load a string. And the string is the serialized cat that we did up here. So we're just going to grab him, plop it right there. And I'm going to print from string, just so we know where we are in the console. And we can actually just say my cat dot display and from string. So really what we're doing is we're taking the string representation of that cat, and notice how it's got a B in front of it. That's denoting that this is binary. So it's going to, I should say bytes, but it's going to take that as a string, put it into pickle, and then load it back into a usable object that we can call functions and run code on. This is extremely cool. So, ta-da! From string, and it's exactly the way it was. Othello's a 15-year-old cat. He's black, 15, and loves to eat. So we have revived my cat back from the dead, as crazy as that sounds, we've unpickled my cat. So this is really, really cool. And just to prove that we can do this from a file, we're going to literally take this, copy, paste, and we're going to say, instead of write binary, it's read binary as file, and we're going to pickle load instead of load s, and we want to load that file, and I'm going to say disk, short for disco cat, why not? And we're going to take that, and then we're going to say disk cat display from disk. And so what this code's going to do is going to go out, open this binary file. We're going to open with hex editor. It's going to load the bytes from the file, create an object, and then we can now work with that object. But these are now different objects, even though they're coming from the same data source. Okay. From disk, Othello, color black, weight 15, loves eating. Now, if we do something a little bit interesting, just to wrap this up, I'm going to print these out. So I'm going to print my cat, and I'm going to print this cat, just to show you what's going on here. You can see cat object at, and then they are two different memory locations, meaning these are now two different objects. This is one of the little cautionary tales of serializing and deserializing, is you can actually save an object and then reload that object multiple times. And you may not want two Othellos. Personally, I'd love to have two of that cat, but it may not be your intent. So be a little bit careful when you're deserializing your objects. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian, and we're going to talk about the map function. Specifically, this is looping without actually having a loop. And under the hood, maps a function call to a collection of items. And it looks something like this: map function to whatever collection we have. So for example, we could have a list, and each item in that list, we could pass it to the function. Let's dive in and take a look. Let's start off with some basic usage. So we're going to get a list of people, and in that list of people, Matt, Brian, Tammy, Marcus, we want to pass this to a function and count the length of each item. And we want to get another list that has those lengths. So we're going to cover an old way and a modern way. So let's do the old way first. So the old way would be something like counts equals, and we're just going to make a blank list, and then 4x in people. Then we would just want to go something like counts.append. Pretty simple what we're doing here. We're just going to say len. And we want to get the length of each element. Then when we're done, we just want to print it out. So we're going to say print old way. And let's just go ahead and print that out. Pretty simple, pretty easy to understand. Works exactly the way you would think it would. It's a little wordy. Now the modern way is going to use the map function. And we're going to shorten this. Remember when I said at the very beginning of this, as code becomes more complex, what we have to write actually becomes shorter and harder to understand. This is a great example. So I'm actually going to start off with print, and then we're going to format that. Say mapped. I want to actually capitalize that just so it stands out. Now we're going to say list, which is literally going to convert this into a list. It's going to list through every element. We're going to call it the map function. And inside the map function, we're going to call len and people. What? This looks crazy. Let's run this. Sure enough, it works as expected. So what's going on under the hood here is we're saying, okay, call print, and then we're going to list map. Now what map's going to do is it's going to take all of these people right here and shove it into a function. In this case, we're using the built-in length function, or len, which is going to get the size. So essentially, we're replacing all of this code in one line. It's very, very cool. The main takeaway from this little segment, though, is we're taking a collection of items and going through each and every single item and sending it to that function one at a time. We're getting back a map object, so we have to convert that to a list. Let's go deeper still into complexity land, and we're going to make this a little bit more complex. We're going to combine elements. And I put some notes. Notice different links, and we're also passing multiple arguments. So what we're going to do here, and I've got some stuff already queued up, ready to paste. First names and last names. We have two tuples. And we're going to combine apple and pie, chocolate and cake, fudge and brownies, and notice how pizza does not have something we can partner it up with. We're going to examine how this works and how it behaves. We're also going to define our own function. So I'm going to say def merge. And in merge, we're going to have an A and a B, which is just simply going to return A plus some sort of space plus B. Very simple function. That's all this needs to do. So our function call just simply needs to return something, and whatever we return is going to get added to the map object. So let's go ahead and say x equal map, and we're going to use our merge function that we just wrote, this guy right here. Now we're going to merge the first names and the last names. So really, when we look at this, it should actually be something like this. Args. So we can have 0 or more arguments. I should say 1 or more arguments. So that's why I didn't do args initially. So we're going to map our merge function to these two arguments, first names and last names, which are these tuples right here. Let's go ahead and print out x and see what we get back. This is where newbies often get tripped up. They go, what is this? We have a map object. Well, how do we work with this map object? The thing is, you don't want to work with it directly. What you're going to want to do is actually convert it into something that we can work with. So we're going to say print list, and we're going to just simply list out x. And what this is going to do is it's going to go into the map object and say, give me every single item, and then it's going to convert it or cast it into a list that we can then use. For example, apple space pie, chocolate space cake, fudge space brownies. Notice these are individual items that have been merged together, and there is no pizza. So because it didn't have anything we could partner it up, it just failed out silently, and we don't have to worry about it crashing our program. Okay, I'm just going to say, if you're a newbie and you've skipped any of the videos, you're about to have a bad time. So we're going to do multiple functions, meaning we're going to combine functions and call multiple functions in one map call. And if you have not been following along, you are about to have a really confusing time. So I'm going to paste some functions: add, subtract, multiply, and divide. They're very simple. Add adds, subtract subtracts, multiply multiplies, and divide, well, shockingly, divides. I don't want these to be complex because I don't want to focus on the mathematics here. We are going to make another function, though. Call it def do all. It's going to have func and num. Func is going to be a function, and num is going to be a list of numbers. And we are going to return the function call with num0 and num1. So all we're doing is we're saying get the first element of the list and get the second element of the list. So matching this up, basically add num0, num1. So it would be something like add num0 and then num1, something like that. And then subtract, multiply, and divide, and so on. In production level apps, you're going to want to make sure that this actually has two elements and that they're the right data types, etc., and so forth. But I don't want to focus on the complexity of any of this. I just want to show you this is the basic structure we're going to use. Now, we're going to make a list, or actually in this case, a tuple of functions. We're going to have add, subtract, multiply, and divide. And these are the functions we have pasted earlier. Remember, functions in Python are proper objects, so we can treat them as variables, as objects. So I'm just making a tuple filled with those functions. Now I'm going to make some values, and I'm going to just, this is going to be a little confusing. We haven't done this before. We're going to put a list inside of a list, and I'm going to say 5, 3. If that looks confusing, it's because we have a list inside of a list. And this is the one and only element in that list. It could be something like, so you would have 1, 2, 3, 4 items in this one list. So yes, you can put lists and stuff like that inside of lists. Very cool how you can do that. We haven't really touched on that complexity yet, but today is that day. Now I'm going to make our numbers, and I'm going to take values, convert it into a list that is going to be multiplied by the length of our functions. So basically, I'm going to take this guy right here and say, how many functions do we have? 1, 2, 3, 4. Add, subtract, multiply, and divide. And I'm going to multiply it by that number. From there, let's just hit the pause button. Let's print out what we have just to make sure what we're doing actually makes some type of logical sense. So we're going to print out f. Those are our functions. And then let's go ahead and print out n, just so we can see what this is. Save, run. Okay, so f is function add, function subtract, function multiply, and function divide. And you can see the memory locations of each one of those. Now we have our list of data here. This is list values times the length, and it is 1, 2, 3, 4. This is important because if you scroll up and you remember when we were combining first and last names, if it doesn't have a matching partner, it will just skip over it silently. So we want to make sure that we have a list for each and every function call. So this would be add, subtract, multiply, and divide. And that's where we're getting this num0, num1. So 0 in this case would be 5, and 1 would be 3. Hopefully that makes sense. If not, you may need to rewatch that. I tried to explain it the best I can, but if you've been skipping videos or haven't been watching them all the way, that may make absolutely no sense. So now we're going to say m equals map. We're going to call the map function, and we're going to map do all to f and n. What is this witchcraft? What did we just do here? So basically what we're just saying is map the do all function to our list of functions, and the data we want to put on each function is, well, this big list of lists. So each function gets its own little list of data. Wow, and it's going to return back a map object. So we're just going to go ahead and print out, and we want to convert that map object to a list. Go ahead, save, run, and the result is going to be 8, 2, 15, and 1.6. So what is going on here? Well, 5 and 3 is 8. 5 minus 3 is 2. 5 times 3 is 15. And 5 divided by 3 is 1.6, big long number here. But this is really, really cool. We've just basically said, do a ton of functions in one little call and gave it the information each function's going to use. So super quick recap before we close this video down. The map function is very, very powerful once you wrap your head around it. You're going to have a function and then you have some sort of iterable, and you can have multiple iterables, but they have to line up in order for them to call. For example, first names and last names, we just simply didn't have anything that lined up with pizza, so there was no like deep dish pizza or anything like that. But we had apple pie, chocolate cake, fudge brownies. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. In this video, we're going to cover the filter function. And this is very similar to the map function we covered in the previous video, where we have some sort of function. I actually put this as fun because I think filters are fun, and some sort of iterable containers. It's going to return true if it matches the filter. This is important. If it matches the filter, it will be placed in the result. Otherwise, it will not. This is a really powerful way of filtering things. We're going to look at two example usages of the filter function. The first one is just simply getting a subrange. And when I say simply, this is actually pretty powerful. So I'm going to import random. We've talked about random before. And then I'm going to say some values, and we're just going to make a blank list of values. For x in range, and we're going to make 10 items. And in those 10 items, we want to get a random number. So I'm going to say v.append, and we're going to say random dot rand range. This is going to take a range from 1, or I should say 0, all the way up to whatever. There we go. So we're going to say rand range, and then we're just going to print this out, just so we can see what our range actually returned. Let's go ahead and run this. So we're just getting some random numbers, 96. I mean, you see they're just all over the place. If I run this multiple times, you can see the numbers are changing down there. So what we're going to do now is say, I want to know the lower half of this. Boss walks in the room and says, I don't want anything over 50. Okay, so I'm going to make a little function. We're going to take our value. I'm going to say if value is less than 50, then I want to do something with it. I want to return true, because the boss said he only wants to see values less than 50. Otherwise, I'm going to say else, and we're going to return false. This is about as simple as it gets. This is basic filtering. That's really what a filter does. Does it match yes or no? That's it. That's really as complex as it needs to be. So I'm going to say f equals, and we're going to go ahead and filter using the lower function. Remember, we had this conversation in the last video. So we have our function call, and then we have our values, this list of values right here. Each one of these is going to get called in turn. So it's going to call it on 57, 72, and so on. And the logic here is it's going to say, is that individual value, like 57, is it less than 50? False. 70, false. 2, true. I think you understand the logic here. So let's go ahead and print this out. I'm going to say print f, and I want to say less than, I help if I put that in the actual quotes there, less than 50 when your keyboard betrays you. Okay, so we're going to convert that into a list. Otherwise, we're just going to get back a function object, which really doesn't help us out a whole lot. So here's our number set and the items that are less than 50, 17, 33, 45, and 11. So this is what I mean by it is extremely fun and powerful. Very quickly, can you just take some sort of data set here and just say, you know what, I only want to see certain items, and then build some sort of custom logic. to get a sub-range of that data. Now, even though this video series is aimed at the complete newbie, I don't like to stay in newbie land very long. So we're going to jump into a little bit more of an advanced topic, and we're going to actually filter types. So when I say filter types, we're talking about classes. So we're going to filter an animal. And we're just going to make a class real quick here. I'm going to say name, not name error. My keyboard has betrayed me. And we're going to say constructor here. Bear with me super quick as I make some little plumbing code. Get our constructor up and rolling here. Self.name equals name. All right, now that we've got our animal class, and I'm not going to make this super complex, we can just take this, copy, paste. Let's call this cat. It's going to inherit animal. And because we're inheriting, we can get rid of this, and we can get rid of this. And it's super simple from here. We just say super. Get it? Super simple. Anyways, I won't quit my day job. We're going to go ahead and initialize it with the name. I could actually spell name. There we go. And because I know there's also dog lovers out there, we're going to make a dog class as well. And anybody who knows dogs and cats know they typically don't mix well together. Although I've been pretty fortunate in life where every dog and cat combination that I've had, they've just really gotten along together really well. So animal. We have a cat, which is an animal, dog, which is an animal, but these are two different classes that don't even know the other exists. So this is where the complexity comes in, and you're going to see this time and time again. What have we just done? Well, we're making a list that will be called animals, and we're going to dump cats and dogs into the same list. So I'm going to say for x in range, and we want from 1 to 10. I should say 0 to 9, but we're going to go ahead and let's say if, and then we're going to do something a little funky here. We're going to say x mod 2 equals 0. Basically what we're doing here is we're saying we only want the even number. Then we're going to go ahead and say animals.append. We're going to make a new cat, and we're going to give it some type of name. So let's go back up here real quick, and I'm going to say name equals animal plus whatever the number is. All right, so once we've gotten to this point, then if it's not even, it is, well, you guessed it, odd. And we can just simply grab this. And maybe I should have done that backwards because cats are just odd. Dogs are usually pretty even, but cats are usually really weird. All right, so anyways, we've got that. Now we're going to go ahead and print out our animals just so we can see that we have a mixture of them. And sure enough, a bit of gobbledygook on the screen, but we have cat, dog, cat, dog, cat, dog, cat, dog. So very simple, very easy to understand what we've just done. We've made a list that contains both cats and dogs, and it's just a jumbled mess. Now, I want to sort this out a little bit. We can say for a in animals. And I'm just going to print this out, make it look nice and pretty on the screen. And I'm just having a good day, enjoying my coffee. And we'll say animal. And super smart of me to do this. Now it looks super great. And I'm going to impress the boss, and I'm going to get a raise. And uh-oh, name. Yes, because we hard-coded it. Very easy to fix this. Ah, yes, my boss is walking around the corner. I'm going to show him this. I'm going to save the company millions of dollars. And sure enough, I have my nice little collection of animals here. And the boss says, that's great. But I only want cats. And then I only want dogs. I want two different lists, but you have to maintain this single list. Oh, now I got to write all this code. Well, this is where the filter function comes in, as you might have guessed. So I'm going to say def cats. And we're going to make a cat filter. It just sounds really, really cool, a cat filter. So we're going to turn is instance. And I'm going to say is that value an instance of the cat class. That's it. That's really as complex as we need to make this. We just want to make sure it is an instance. We can do the same thing for dogs. And then we can use that filter function to utilize these two functions to their fullest extent. So I'm going to say for C in, and then I want to make a list. And we're going to filter, because remember, filter is going to return a filter object. We need to convert that to a list. We're going to filter the cats using the animals. Slowing way down so it makes sense here. We're going to go ahead and print. Actually, I'm going to say cat. And I'm going to explain this in case you're completely lost. Don't worry. All right, so what we're doing is very similar to our for A in animals, except for we're saying for C in, and we're going to make a list from whatever filter gives us. And we're telling filter, use the cats function and use the animals collection. Remember, animals is a mixture of cats and dogs. And we're just going to say for each item, determine if it is a cat. We're just going to return is instance. And then we can do the same thing for dogs. Very simple, very easy to understand. And when we run it now, we have beautifully separated these. Now we have cats, and those are the evens. And then we have dogs, and those are the odds. Okay, pretty much sums it up for this video. Main takeaway from this is filter is going to return a filter object. We need to pass it a function and some sort of iterable container. From there, it just really needs to return a true or a false. If it's true, it's going to end up in the result list. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian, and in this video, we're going to talk about logging basics. Now, what is logging? We're not cutting down trees or anything. So far, we've been using the handy print function, but logging is way, way cooler than printing, and it is kind of the de facto, but we really haven't been able to have this conversation because we haven't covered all the technology we need to build up to this conversation. So what makes logging cooler than printing? Well, printing just prints something out on the screen, but logging, you can have levels. For example, you can say it's a debug message, info, warning, error, critical, and some of these should be self-explanatory. Debug is just for you, the developer. You want to know what's happening. Info is just, hey, something happened. You may want the user to see this, you may not. Warning is, hey, something bad may happen if this continues or if it's not fixed. Error is pretty self-explanatory, and critical is worse than error. So these are the different levels. To start off with, we are going to import the logging module. You could also do something like this from logging import, and we're going to import the root logger. The reason why I add this is you need to understand that logging by default has a root logger. And when I say root, I mean it's the top level. You can define other loggers, custom loggers, but we're going to be working with the top level logger. Okay, so I'm going to just comment this out just so people don't get confused about which one we're working with. We're just importing the entire module here. And I'm going to work with basic logging. Notice how they do not get displayed by default. This is the main takeaway of this segment. This is going to be super confusing if you don't pay attention to that. So I'm going to define a function, and we're going to use this over and over again. It's going to just simply be test. And we're going to print some lines. And let's just do 20 of them. Why not? And then I'm going to grab that Give it the good old copy and paste. That way, all of this is going to be separated out when we print it. Now, from here, we want to do a few things. I want to say logging dot, and we want to debug. Now, this is a little confusing because we're not actually debugging anything. We're saying logging, make a debug message. Or more specifically, we're going to message something with the severity of debug on the root logger. Remember, we're talking about levels of logging here. Debug being the lowest, critical meaning, hey, your program's just exploded and here's what happened. So we're going to say debug message here. And then we can take the same pattern and just, you guessed it, copy and paste time. Say info. Now, informational are, well, just that information. It's not really anything super important. It's just, hey, the file was changed or something modified. Warning, however, this is when things are starting to get a little serious. You ever give like your kid a warning, hey, you better go clean your room or else? Don't condone beating your child, but sometimes you just got to make them clean their room. So we've got debug, info, warning, and as we go further, this number's changing. There's a number in the background that we're going to really review later on. Now, what's higher than a warning is, you guessed it, an error. We've talked about error handling and error conditions and things like that. And that's exactly what we're doing here is we're saying, hey, some sort of error happened, but using this will not throw an error. We're just logging that an error occurred. And last, but certainly not least, is critical. When you hear the word critical in computers, you need to believe that it is critical, meaning everything you know has just ceased to exist and you need to focus on this. Or everything you know has just disappeared because it has died. That's basically what critical means in computer lingo. Now we're just going to call this test function and see what happens. Notice how they do not all get displayed by default. Let's go ahead and run. All we see is warning, error, and critical. But where's debug and info? To really understand this, we need to set the level. And when I talk about level, we're talking about this: debug, info, warning, error, and critical. Under the hood, each one of these has a number assigned to each level. Think of it like levels of a building, starting at the bottom, going all the way to the top. Most important to least important. Okay, so we're going to say level equals, and I want to go logging. We're going to use the logging module. We're going to get the level name. What this is going to do is convert that number in the background to a string representation. But of course, it's not that straightforward. We now have to go logging, get logger. And what this will do is get the root logger, which ironically we're already working with. But the thing is, you can specify a name. So you can have different types of loggers that do different things. We're just going to get the root logger. And then we're going to say get effective level. Get effective level is going to return what level of logging we're currently working with here. From here, we're just going to print that out. So I'm going to say print f, and let's say log level. All right, so our log level is currently at warning. What we're going to look at the next section is how to specify that level. But what I really want to talk about is what the level really means. What it means is warning, meaning anything more critical is going to be included. So we're going to do not just warnings, but also errors and critical. But we don't really care about debug and info. And this is one of the little gotchas about the logging class by default is people will start with this and start doing debug messages and then nothing happens and they go, well, why? And this is why we need to set the level. Now that we understand the concept of logging levels, let's look at how we can manipulate them. We're going to get and set the logging levels. This allows really for filtering. And the reason why you want to do this is in a typical application, you're going to have a lot of information whipping around and you don't want to see all of that on the screen at once. You only want to see what's important to you. So first thing we're going to do here is we're going to get the root logger. Now the root logger is included by default, but I want to actually go out and get it just to show you that we are getting an object. So I'm going to say root log equals logger, or I'm sorry, logging dot get logger. See how that's a little confusing there? Now, if you had multiple loggers, you would have the name of the individual logger. If you don't have a name, it's just the root or the main logger here. From here, we're going to just grab this because this is just horrible looking. I'm going to say print. And we're going to print the level. I'm going to paste that out here. So we're saying logging get level name. This is a little misleading because we're not working with the main logger. We're working with the logging module. So we're saying the module should get the level name. Now we want to get that from our root logger. So effectively, instead of saying this, we can replace with that. So logging module get level name of whatever log we're working with, get the effective level. And under the hood, the level is just a number. Let's go ahead and run this. So level warning, I'm going to actually put something in there to split that up. So we know we're at the warning level, and we've known that all along, but now we're going to set it to debug. Now, what does that mean, set it to debug? Well, it means we're going to include debug and anything more critical, and since up at the top here, debug is the top of the chain, anything's going to be included, not just debug. So we're going to say root log set level, and then we're going to say the logging module debug. Then we can just call our handy test function that has all those beautiful little loggers going on and run. Sure enough, now we're seeing the debug info warning error and critical. So it is working as expected. I'm going to grab this and we can very quickly start changing the level as needed. So I'm going to change this to critical only. Remember, critical is, well, critical. It means like something has exploded or is about to. And we're going to run this, and you can see logging level is now critical. There we go. It's pretty easy to understand here what's going on. What you need to understand, though, is that the levels do not make those magically disappear. It just means that we are not logging them or capturing them. Those messages are still being fired off. Okay, now let's just do it one more. And I want to set this to warning. Right back where we were. And critical root, critical message here. You might be wondering what this root is. What is this root? Well, that is the actual logger we're working with. That's why I've been calling this the root logger, because we're working with the root logger. If we had a different logger, it would be the name of the logger right there. It's actually pretty elegant the way this works, and you can flip these around as you need to. So if you're getting a lot of verbose information and you only want to see what's critical, you can set it to critical. Then you're not getting warnings, so then you set it to warning, and now you're getting the appropriate level of information you need to see. Now, as cool as this is, what would be cooler is if we could log this directly to a file. So as events happen, it gets dumped directly into a file, and that's exactly what we're going to do. But I want to show you something that will just infuriate you time and time again. If you go out to Google and you type in how to use the logger, you're going to get something that looks like this. Logging.basicconfig, setting to a file name. Everybody gets all super excited. File mode, right? Yes, this is going to work. You can even define the format. This is super cool. So we're going to say the level and the message, and then we're going to say level equal logging.debug. Notice what this is doing. This is setting the config. It's setting some handlers and all this fun stuff. So people get super, super excited, and they do something like this. Logging.debug. And we're going to send a debug of just hello. So in theory, when we run this, logging is going to call debug with the message of hello. It's going to create the file app.txt in write mode, and then it's going to write this out in this format. And we know that because we're setting logging debug. So drum roll. Nothing happened. That's right. Absolutely nothing happened. So then people get very frustrated and they do something like Google, why is logging not logging? That's literally one of the most popular Google searches for this. The reason why is very simple. Basic config will not work if we've already configured the logger. It needs to be done before we take any action. And so because we've already been working with the root logger and we've already configured it, basic config does nothing. That's right. It does absolutely nothing. It's so frustrating. So I'm just going to put in some notes. And then I'm going to comment these out. We're going to show you how to get around that. Now, if this was actually the first line, like if we had this way up here, it would work beautifully. But because we've done all this, it's just simply not going to work. So we need to get a handler. I'm going to say logging dot, and we want a file handler. And all a handler does is it says how to handle the log information as it come in. I'm going to say file.log. You can name it whatever you want. It really doesn't matter. Now we want to define a formatter for that handler. And I'm going to say formatter. And you notice these are constructors. So yes, under the hood, we're actually creating classes. Now, this is where I'm going to get a little copy and paste happy just because we'll be here all day watching me try to type this out. What we're going to do is we're going to take the time, string representation, the name, the level, and the message. If you're wondering what name is, it's the logger name. So it's going to say time, logger name, the level, and the actual message. And you can define whatever formatting you want. The guide is out in the official documentation for this. Point being, once we have a handler and a formatter, we're good to go. From here, we can say handler.set formatter. And that's going to tell the handler how to format the information it is handling. Then we can simply say root, and we're going to say our root log dot add handler. Now, what we can do is we can go in and say something like, let me get this back up to debug level. Now we can set that to logging debug. Then we can say root log dot debug test. Save run. And sure enough, our file.log was created and it is in the format that we wanted it in. This is extremely cool. And we can even call our test function. And because our log level is at debug, and because we have set the handler in the formatter, we can go back out to our file log, and there is all our information. It is beautifully formatted. So we have the date time, we have the logger, we have the level, we have the message. And you can see how it even color codes it for us. This is just super impressive. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian, and we're going to make a simple application called dir stats. And what this thing's going to do is it's going to scan a directory recursively. If you're new to programming, you're probably going, what does that even mean, recursively? Well, let's say you have a directory, and that has subfolders, and those folders have subfolders, and so on, and so on, and so on. And you have this nice tree structure, similar to how we see over here. We want to be able to scan all the way through that tree. Let's take a look at a simple diagram here. And don't worry, I'm going to zoom in. But we have a start and an end. And our overall logic is going to be very linear, very easy to understand. Let's go ahead and zoom in. So we're going to start. We're going to go to our main function. We're going to get some user input. And we're going to validate that that actually exists as a folder somewhere out on the operating system. If it does not, we're going to jump right to finished. However, if it is actually in existence, we're going to go into a for loop. And this is the recursive bit right here. We're going to say for each item, if it has sub-items, go back and scan those items, and so on, all the way down the directory tree. If we run out of items, then we're done, and we're just going to display the results to the end user. Pretty simple, pretty easy to understand logic. Let's dive in and take a look. Okay, first things first, we want to do some imports and make a global variable. So our import, we're just going to simply use OS. Now, OS in itself, this module really allows us to deep dive into the operating system and get some details. We're going to use this to get, well, the folder structure along with the file sizes and things of that nature. So let's go ahead and now let's make a dictionary. I'm going to call this stats. And we want a very simple dictionary here. I'm going to say path equals. Personally, I'm not a fan of global variables, although they do have their usages, and I believe this is one of those times. So we're going to say path, and then folders, files. And in case you're wondering, really all this is going to do is just hold the metrics that we're going to scan. Say links, and then the total size in bytes. Go ahead and run this just to make sure we didn't misspell anything. We got no errors, so we're good to go. Okay, starting point, we need to get the user input. We have to have something to scan. So we're going to say def get input. This function is going to be very simple, but there is a bit of complexity we got to explain a little bit here. So first thing we want to do is use this global variable. So we need to use the global keyword. So global stats. If we forget to use the global keyword, we're now making a new variable. And then Python will, depending on the version of Python, selectively choose to use the global variable or create a brand new variable inside of the function. So we want to tell Python, use the global variable. From here, we're going to get the user input. So we're going to say ret equals, and we're going to do this a little bit different. Instead of just saying input and then get the input, we want to convert that to a path all in one line. So I'm going to say os.path. We want the absolute path. Now we want to get the user input. And we're just going to simply do this all in one line. We're going to say, take the user input and convert it to the absolute path. Very cool how that works. Now that we've got this little guy here, we can just check to see if it actually exists. We're going to use os.path.exists. Notice how we're saying if not, meaning if it does not exist, if this is going to return false, then we want to take some sort of action. And in this case, I'm just going to let the user know, hey, you screwed up, and we can't really move forward with this program, so sorry, that path does not exist. And then I'm going to exit our little application here. Now, if you don't know what an exit code is, typically when you run an application, it will run, do its thing, and then exit. And when it exits, it tells the operating system what happened. 0 means that there were no problems. This worked as intended, but clearly that's not the case. So we're going to give it an exit code of 1. And this is really up to you as the developer to determine what these exit codes are. It could be 1, could be 99, 91, whatever we wanted. We're just going to do 1. That tells the operating system this did not work as expected, and if we have an end user, they can say, oh, the program gave me exit code 1, and you can say, oh, yep, you gave me the wrong path. Okay, now we want to say if not OS path, and we want to make sure this is a directory, because sometimes our users are not that smart, and they're going to hand us a file or something like that. So we're going to say, sorry, that path is not a directory. And then let's say exit code 2. And we could define whatever we wanted. Now that we have reached this point, we know that we have a valid path, and it exists, and it is a directory. So we're going to update our global variable. And in here, we have path. So that's what we're going to update here. I'm going to say stats path equals that. So we're just setting the dictionary value for path to whatever folder they entered. Very simple, very easy to understand logic. Now that we've got the user input and we know what path they want to scan, we want to scan that path recursively. And we're going to do this in a function. So we're going to say def scan, give it a path. And again, we want to use that global variable. So we're going to say global stats. I like that word, stats. Reminds me of like a doctor or something. If we want to be super nice, we can actually print out what we're doing here. So we're going to say scanning, and then whatever our path is. Now, you may be wondering why we would use a variable when the path is actually in stats. And the reason being is we're going to do this recursively, meaning this path variable right here is going to change over time, where the path inside of our dictionary is the root. So this could actually be a folder of a folder of a folder, something like that. So that's why, just in case you're wondering. Now comes the fancy bit here. We're going to use something called os.walk, and I want to just preface this with there are a million different ways to do this. We're just using one way. So I'm going to actually put millions of ways to do this. And I'm sure people down in the comments will go, well, you shouldn't use oswalk, you should use this other way, or glob, or whatever. We're just going to use oswalk because it's simple to understand. So we're going to say for, and walk is going to return 3 values. It's going to say root, dirs, and files. So root is obviously the root, dir is a list of directory, and files are a list of files. I love how this is just super self-explanatory. So that is going to be in os.walk. And this is why I like using walk, because it's super simple to use. It's super simple to understand. We're going to scan that path, if I can spell path correctly. And then I want to say on error. We're going to set this to none. We have to do this because there's going to be some folders you just simply won't have access to. Like you'll get an access denied, or you'll have some sort of weird hard drive error or something. You don't want to crash your program. So we're going to say on error equals none. We could set that to a function or whatever we wanted to do, but we're just going to say none. So take no action. And then follow links. We're going to set that to false. What this means is if you had a link, think of it like a shortcut that points somewhere else. If that was set to true, you could scan way outside. So like if you had a folder 1, to comment this out, let's say you had folder 1, and inside of folder 1 there was a link that pointed to folder 3. You kind of see what's going on here. As you're scanning folder 1, if you're following that link, you're going to jump to a completely different folder, even though, say, folder 3 is at the root level, like up here. So we don't want to do that. We want to make sure that we're not following those links. All right, from here, we're going to say stats, and we want to update our metrics here. So we want to know the folders. And the folders are going to be plus equals, and we want the length of, you guessed it, dirs. So this is going to be a list, and we want to get the length or the number of items in that list. I don't remember if it's actually a list or a tuple, but IntelliSense is telling me it's a list, and files will be a list as well. List or tuples, I don't care. We're just going to get the length of it. Now we're going to say files. We're going to update the files metric as well. Got to be a little bit careful that it is folders. Files, we're spelling those correctly, otherwise we're actually adding a different key altogether. Now from here, what we want to do is say for name in files. And we're going to go through and scan each one of these files independently. We're going to say full name equals os.path.join. And what this is going to do is allow us to join the root or the folder name with the actual file name. Because these are going to be two different things. This will be like the actual path, and this will just be the name without the directory name attached to it. So this could be something like s.txt, not the actual full path. So we want to make sure that we are joining those together. And os path join does exactly that. Joins two or more path name components. All right. Takes care of a lot of the headache for us, so we don't have to worry about it. From there, let's go ahead and get a size. And we're going to say os.path. You see how we're using os quite a bit, especially path. So os.path, and we want to get size. This is going to get the size of that file. And we're going to use the full path name rather than just the name. Once we've got that size, we can go in here and we can say stats and jump up. Let's see what key we used here. Size. So we can just go size and let's increment that. So starting at the top, we're going to scan a path. And we're going to go ahead and just keep scanning that path over and over and over and over and over. This is what I love about this. Now, one thing you should know is this is a bit misleading. We could have actually have done our stats if we wanted to, but I wanted the ability to use this somewhere else if we needed to by allowing us to jump into that path. You'll see what I mean here in a little bit. Now that we have scanned recursively, we just simply want to display to the user what we've done so far. And this would actually be right before the program exits. So we're going to say def display. And again, there's a bunch of different ways we could have done this. Let's go ahead and lowercase that. And really all we want to do is just print out our dictionary. That's why I put everything in a dictionary, because it's nice, neat, and compact. So we're going to say global stats. By now you know what the global keyword does. We're going to print word results. And then we're going to print out the key value pairs in that dictionary. So I'm going to say for k comma v in stats items. That's going to get us the key value pairs. And then it's just very, very simple from here. Print. And we're going to format that. And I want to print the key with an equal sign and then the value. Very, very simple function, but it's going to look really elegant on the screen. Okay, it's time to wrap things up here. Let's do our main function. So let's go ahead and say def main. And some Python noobs are going to say, do we actually need to make a main function? I mean, we could technically, if we wanted to, do something like if name equals, and we want to say underscore underscore main, and then we could do our code here. You absolutely could. I don't like doing this. I like putting everything right in a nice, neat function in case I want to swap out functions later. Then I'm not copying and pasting and doing a bunch of other stuff. So instead, I'll just actually call our main function right there. Now remember, what we're doing here is we're checking to see how this file, this individual script, was run. If it's run directly by the Python interpreter, its name is going to be underscore underscore main underscore underscore. And we've talked about the underscore in the past, but these are special characters that Python uses to determine, hey, this is internal to Python. So if Python runs it, the name is going to be main. If it's anything else, that means another script is calling this, and I don't want to fire off this main function. Instead, the script, the calling script, may want to call display or scan, which is why I left that there instead of doing this global. Ah, man, lots of explaining, but I think you wrap your head around it now. So once we've got this far, we can say global stats. And actually, I don't need those. So we're going to tell it, hey, we want to use the global variable. From here, we're going to go ahead and get the user input. We could have done this a little differently. We could have had get input return a value, but instead I wanted everything encapsulated in there. That way, if some other function called it, it's all baked right into our global variable. A little bit of a design choice, and you may have to tweak that depending on your needs. Now let's go ahead and scan. And notice how we have a path now we have to feed this. And we can just say stats path. We're getting the path from the get input. And we could very easily hard code that into the app if we wanted to. And then finally, let's go ahead and display the end result to the user. And we can kind of condense this down a little bit, make it a little easier on the eyes. So the main logic is very simple. We're going to use our global variable, we're going to get the input, we're going to scan that path, and then display the results. Let's go ahead and fire this thing off and see what happens. All right, so enter a folder path. If I want to just scan my current path, I can just press dot, because remember, dot is the current directory where dot dot is the parent directory. And it says, sure enough, our current directory is this guy right here, Python 3. There are 2 folders, 2 files, 0 links, and the total size in bytes is 2594. Whew. All right, so this is a pretty beefy little program that we've got here so far. It's simple, it's easy to understand and use, but at the same time, it's doing some pretty complex logic for beginner land here. The main takeaways from this is, yes, you can use a global variable, although it may not always be the best design choice. Always, always, always validate the user input. You never want to just trust the end user. I mean, for example, what if I ran this and they said cats? Sorry, that path does not exist. What if we just tried scanning for cats? You know, your program's going to crash. Now, scan, the major takeaway from this is there are millions of different ways of doing this. I used OS Walk. Use what works for you. I personally prefer OS Walk because it allows me to easily break out here if I need to, because it's in a nice, neat for loop. So if I just wanted to go so many levels deep, I could bake that logic in. Display, we're pretty much just using the directory items to get the key value pairs and then print them out. And then we covered our naming convention internal to Python. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian. We're going to continue our journey into Python 3 with timers. So we're going to execute code at timed intervals. This is the first step in learning threading, and threading is a very complex topic. There's no way we're going to cover it all in one video without having a much longer video. But in case you're wondering what threading is, it looks something like this. So you have CPUs, each CPU has multiple threads in it. So a thread, think of it in very loose terms as a slice of time. So think of the CPU as like a parent, like your mom. And your mom has 3 children. Well, she can't pay attention to all 3 children at the same time. So a thread is a slice of time that the mom pays attention to the child. Now, you think about that in terms of how fast computers are. They do this blistering fast, and then you get into virtualization and virtual CPUs and things like that. It just gets overly complex. And if you want to make it even more complex, this is what it really kind of looks like under the hood. So you'll have physical memory, or RAM, with some memory space that's allocated towards the process. Each process can have multiple threads, which works with stacks and registers and things like that. The thread scheduler in the operating system will then push that out to the physical processor. Now notice the scheduler. So what we're really talking about here is layers of complexity that go way beyond Python. I mean, this is computer engineering right here. Really what we're looking at is we want a part of that processor's attention. But really what we can do is run multiple things at the same time. And I'm going to demonstrate that. So you see this cursor blinking right here. Notice how if I open a menu, it stays blinking, but I can navigate the menu while it's blinking. Those are two different threads. If they were on the same thread, that cursor would stop blinking while I'm navigating the menu, or the menu would stop working while the cursor is blinking. There's all sorts of complexities and issues you run into with multi-threading. So let's dive in and take a look. To start things out, we're going to do some imports and a display. So we're going to import time. I like to import time. I wish I had more time in the day, but we're going to import the time module, and then we're going to say from threading import timer. Now, one question I'm often asked is, which is the correct format? Well, if you're going to use most, if not all, the module, do it this way. If you're going to use just one part of it, use this way right here, where you're only going to import just what you need. Threading is a big topic, a big module, so we really only want this right here. Now, if we mouse over this, you're going to see a thread module emulating a subset of Java's threading model. Wait a minute, Java? We're talking about Python. Well, Java really nailed down threading in the threading model, so Python's kind of emulated that. They're kind of, I don't want to say blatantly copying it or stealing it, but they're really doing it very similar to Java. So if you're used to Java, you're going to be right at home here. So we're going to say def display, and we just want to display some kind of message to the end user. And I'm going to actually, because this can get a little convoluted depending on what you're looking for, I'm going to put a link to the documentation right here. But we're just going to basically say print, and there are, as you guessed, a million different ways to do this. We're going to print out the time. Notice we're using the time module, and we want the string format time, which whenever you hear the word format, that means we've got some funky symbols we need to put in here. And I've got the format queued up off the screen here. Very simple. Hour, minutes, seconds, and this is on the 24-hour clock. You can get all this from the documentation link. There's tons and tons and tons of different formats you could do this in. I'm going to keep it just very simple. Hour, minutes, seconds. All right, let's go ahead and make a basic timer. When I call this basic, it's kind of a fire and forget solution. So we're going to say def run once. And as the name would imply, it's going to run one time and one time only. So let's go ahead and let's look at this. We want to call our display function. We're going to say display run once, just so we know, hey, we're actually in this function. Then we're going to make an instance of the timer class. So I'm going to say timer. And we've got a couple of parameters we need to put here. So timer needs an interval, and this is going to be in seconds. Then we have a callable. Whenever you see callable, really it's just a function or a callback or whatever we want to do. And then we have some arguments or keyword args. So let's go ahead and say we want to wait 5 seconds. When this is done, we want to call our display function. And notice our display function has some arguments, so we need to give it a list of arguments that's going to be passed. And we're going to say timeout. So really what we're doing is we're saying create a timer. When the timer starts, wait 5 seconds, call the display function with, horribly misspelled, timeout, there we go, with a parameter of timeout. Now we can go ahead and say t.start. So we're going to actually start that timer. Under the hood, what happens is threading is going to make a new thread with a timer class and pump that out to it, and it's going to start that out there. This is not going to work the way you expect it to if you don't understand threading. So for example, we're going to do run once, and then let's go ahead and say print waiting. And I'm putting waiting, even though most people would say something like this. Let's go ahead and run it like this, just so you can see what I mean here. See how it says done? Well, wait a minute. Where's our timer? Drum roll. There it is. So what's going on here is we're calling run once. It's calling display, so we see that, but then immediately it's jumping out here, even though this code hasn't executed yet. This is the beauty of threading. You can tell the computer do something some other time or do it at the same time. So in the background, we're creating a timer and it's ticking away time, counting down until it can actually fire off. And when it fires off, it's going to say, all this with this. That's why this was waiting, not done. So basically, when you start a thread, the context of execution is going to move forward instantly, and the code on the other thread will move to the other thread and work out there. All right, so let's see it in action again. Now it looks a little better. Run once, waiting, and then we're going to get a timeout. I'm going to put some notes in here just so we don't confuse people who decide to skip through this video. Notice this is run immediately, but it also only runs once. Now we're going to make a timer that runs on an interval, and this might have been what you were really expecting. So far, we've talked about a single shot where it only fires off one time. We're going to make it fire off over and over and over again until we stop it. Got to paste some notes. So we're going to wrap this into a class, and this is where they're really emulating Java, and we're going to make it run until we stop it. You can have multiple timers at the same time. Remember, your computer is absolutely filled with timers. Here is the official documentation. It is not for the faint of heart. If you go out there and don't understand it, don't beat yourself up. Threading is very complex. So first thing we're going to do is say class repeat timer. And we're going to inherit the timer class from the threading module. This guy, ta-da! Now that we've inherited that, we've got everything it has, so we can just work with it directly. So I'm going to say def run. And this is a little confusing. What is run? Well, run is called automatically. Let's go back up here to our run once. We're saying create an instance of the timer and then timer start. In the background, run is called. So start is called, they do some stuff with threading in the background, and then they call the run function of the class. So when you see start, automatically understand that run is going to be called. So run is fired off when they actually start your class. So we're going to say while not self finished, we're going to go ahead and wait. And this is a little bit confusing, and admittedly, I did take this from a post on Stack Overflow. This is probably the best class I've seen so far. And you'll see why in just about a second here. So we're going to say while self is not finished, we're going to go ahead and wait for whatever interval we've set. And then in here, we're going to say call the same function over again with the same args and keyword args. And then once we're done, we can just go ahead and print this out. It's so simple and elegant. If you actually go out and look at how to do this in other areas, you're going to have this big long class with like init and all this other stuff. You don't need any of that. This is all self-contained and it's only a few lines long. It's very elegant. It just works. I absolutely love it. So what we can do now is, well, you guessed it. We're going to start controlling this. So we're going to say timer equals repeat timer. We're going to do this every second. We're going to call display. And we're going to give it an argument of repeating. So because we're inheriting this class, it is identical to if we were just calling it directly. Absolutely love that. Now that we have a timer, we can go ahead and work with it directly. So we're going to say timer start. Now remember, this is going to call run. So when we say timer start, run is actually being called, and then all of this happens. Now before run is called, it does some stuff in the background with the OS scheduler and all that stuff, and actually creates a thread on the operating system and works with it directly. We don't have to worry about any of that complexity. We just know that start will call run. Now, this is where we're going to get a little confusing. I'm going to say time, not timer. So time, sleep. What we're doing here is we're putting the main thread, or the thread this program is running on, to sleep. So this thread will run in the background, but our main program is actually going to go to sleep. And we're going to go sleep for 10 seconds. So I'm going to plop in some notes. So we're going to suspend the execution for a given number of seconds. So I'm going to just print out threading start. Actually, let's say started. And then finishing. Just so we can see what time sleep does. So if we mouse over this bad boy, it says the module time provides various functions to manipulate time values. So it's a little misleading how this actually ropes into our execution. Let's break that up just a little bit. Now we can go ahead and say timer dot cancel. So we're going to cancel this timer. Basically just shut it off. Let's go ahead and run. Now remember, when we do this, we also have this other timer from run once. So it's going to fire off timeout. You're going to see that in the results. So waiting, thread started, repeating, repeating, repeating. And then we're going to get a timeout. There's our timeout, and it's going to keep going. And then after 10 seconds have passed, it will stop. See? Now, had we not done this right here, we're going to get drastically different results. And this is really one of the minor complexities. I say minor because it can get really complex. But one of the minor complexities with threading, you can see how immediately it says done. Now, wait a minute. It didn't work as we expected. Now we get a timeout. That is super frustrating. So we have to suspend the execution of our current thread while the other thread's running, or we get drastically, horribly bad results. Okay, so we have just scratched the surface of threading and what threading can do. Really, what you need to understand is that you can execute code at the same time on different threads. This is extremely cool and extremely powerful, but it comes with a level of complexity you're going to have to start wrapping your head around. Threading is, well, in any language, some of the hardest code you're going to ever work with. The big takeaway from this video is that threading in Python also has a timer class, which we can use, inherit, and manipulate. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. In this video, we're going to look at how to move a function to multiple threads, and we want to wait for all of those threads to complete. So let's dive in and take a look. Okay, the beginning step of pretty much any application is imports. What are we going to be using? Now, in the future videos, I may just copy and paste these just to save time, but because we're still technically in newbie land, I want to slow down. So we're going to import logging. So we're going to log to the screen. We've covered that in a previous video. And then we're going to import the thread class, but threading is a big module, so I want to import just the thread class. So I'm going to say from threading import thread. And I get a lot of questions about why wouldn't you just say import threading? Well, you can. It's just going to take a little bit more time and it's going to use more resources because you're importing the entire module rather than just the one class that you need. And we're going to go ahead and say import time. Time has a special function called sleep, which puts the current thread to sleep. Now, when we say current thread, we're talking about the current thread that's running. The main issue with multi-threaded programming is you can have multiple threads running at the same time. So current thread really talks about which one you're currently focused on, or the one that's currently running. I'm going to say import random, because we're going to work with the random number generator. The next step is we need to make our function that's going to actually perform the work. Now, this function is just a normal function. We can call it on the main thread or on separate threads. There's really no special magic to this. Now, I want to kind of just have us take a nice leap of faith here because we're going to set up logging in the main function, but we're going to use logging in this function. So I'm going to call this long task, and let's give it a name. And we're going to say max equals, and we want random.randRange. This is going to make a random number between a range of two numbers. Covered this in previous videos, but just in case we missed it. And then we're going to say logging. Now, we haven't set up logging yet. We're going to do that in the main function in the next segment. So just leap of faith time. We're going to just assume that logging is set up by the time this is called. I'm going to say info, and then I want to format this. I want to say task. I want to print out the name. That's the variable, or I should say the parameter that we got sent here. And then let's go ahead and say performing. And then we want to know how many times we're going to be performing this work. So I'm going to convert that to a string. Max, really don't need to convert it to a string, just showing that we can do that. We're going to do this X number of times, or I should say the maximum number of times here. So what are we actually going to be doing? Well, for X in range. Oh, if I spelled range right, there we go. Max. And then we're going to log. Let's go ahead and do that in a format. And we're just going to simply say task, and then whatever our name is. And then we want to just print out X. This is where things get a little bit interesting. So far, this function's really not super complex, but we're going to introduce a stumbling block here. We're going to say time sleep. And this is going to put the current thread to sleep, meaning it's just going to stop functioning. If you were running this on the main thread, it would appear as if your application has completely locked up. I know you've seen this before when an application becomes unresponsive. We're going to simulate that using sleep. And this is really the main reason why you would use a thread, is some sort of action that's going to take a really long time. And we're going to say random, and we want to randRange. We're just going to simulate some sort of activity. And anywhere between 1 and 3 seconds, we want this thread to go to sleep. Now, I have to say when this thread goes to sleep, because we don't know what thread we're calling this on. Let's go ahead and just say logging.info. We're going to format this, and we're going to say task, whatever the name is, complete. That way we know this is now done. So how do we know what's going on here? Well, when we jump into the long task, we're going to have some sort of range here between 1 and 10. That's going to be the number of times that we're going to loop. Each and every loop is going to put the current thread to sleep, meaning that current thread is going to just stop working for a random number of seconds between 1 and 3. This is going to simulate long activity or make it look like the application's crunching a lot of numbers. Okay, let's go ahead and do our main function here. So I'm going to say, actually, let's say main. Let's see if IntelliSense will help us out. It will. Go ahead and make a main function here. Now I'm going to do a little bit of copy and paste just because, well, we've done this before. So there's really no sense in you watching me type this out for 10 minutes straight. So I'm going to copy and paste our logging config. And if this looks big and ugly, it's because it is. Remember, we've covered logging in a previous video. We have to do the basic config before we do anything with logging. Otherwise, it will ignore the config. We're going to format that as the level, the time, the message, and we want to specify the date format for the time into hours, hours, minutes, seconds. We also want to set the logging level, being a little tricky there, to debug. So we're capturing pretty much everything. Modify that as you need, but I wanted you to be aware of what's going on there. From here, I'm just going to say logging.info. And let's go ahead and say starting. And I want to wrap this up with this right here. Finished all threads. The basic premise meaning we're going to do something here. And that do something here is going to take a very long time. So we want to push that off to multiple threads. So for example, if we were to take our long task here, let's just call that main, and let's run this, see what happens. So you can see it's taking a long time. It's going to do that 8 times, and it's just taking forever. This is called a single-threaded application. We haven't done any threads, but we do have one thread, and it's the main thread. That's what's called a single-threaded application, and that's why some apps are very slow, and that's why people want multi-threaded applications. So we're going to go ahead and comment that out. And now we're going to run on multiple threads. And it's not really as hard as you think it would be. I'm just going to say threads equals, and we're going to make a list of threads here for x in range. And we want 10 threads. I'm going to say t equals, and we want to make a thread. And in the thread, we want to specify a few things. So we want to specify the target. And the target is quite simply just the function the thread is going to run on. We're going to call the long task function, which we created. Now we want to give it some arguments. So I'm going to say args. I always love that word, args. Sounds like a pirate. We're going to give it a list. We're going to say thread. And let's go ahead and give it a string representation of x. So it's going to say thread and then whatever x is. Now we want to go ahead and say threads.append. And we're going to add that to our list of threads. And of course, we're going to start each individual thread. So I'm going to say t.start. Really? That's it. It's not super hard. So let's go ahead and clear this out. And let's run this and see what this looks like threaded now. You can see it goes much faster. And we can see some completes in there, which means now we see the actual individual threads completing, and we can see, 0, 1, 6, all these individual threads are firing off, and each one's going at random intervals. We have a subtle problem though. Our application's running, even though when we look at this, logging info finished all threads, we want to wait till the end. And if we scroll up here, all the way up, you can see it fired off, well, about a quarter of the way into it. So we got starting, some threads kicked off, and then finished all threads. So how do we actually wait for all these threads to complete? We're going to use something called join, which is a lot like joining a meeting. You ever sit in a meeting and you just kind of wish you weren't there? Well, that's exactly what we're going to do. So we're going to say, wait for all threads to finish. This is why we put them in a list to begin with. So we're going to say for t in threads, t join. We're going to say, hey, you know what, thread, you're off in thread land doing your own thing. I want you to come back and join the main thread. Or more specifically, it tells the main thread to wait until that thread's finished. Because we're doing this in a loop, we're saying wait until all of the threads are finished. Let's go ahead and save. Let's clear this out. Let's rerun. And we're just going to wait just for a second. And what do you want to talk about while this thing's running? I don't know. I like coffee. I like my coffee black. Some people say only psychopaths drink it black, but I really like black coffee. I just can't get into like cream and sugar. Hey, there we go. All right, enough of the coffee conversation. You can see finished all threads is the very last thing. So yes, this did work as expected. So if we scroll up, and I'm actually going to just pull this all the way up here, you can see starting, and then we are firing off, and right away, the threads are firing off. So you got 0, 1, 2, and then so on. And then you can see each individual thread is spinning up. Each individual thread is working. So like we have thread 0, 1, 2, 3, 7. Notice how it skips right there. This is really the cool feature about threading, is you're going to create these threads and the operating system's going to decide what to do and how to do it. And then it just works and it just goes and chugs away at these numbers. And you can see that's all kind of haphazard and out of order. And it's because each thread is working independently. At the very end of this, we're calling join on all those threads because we want to wait until they're all done. And we get this very final finished all threads. That is how you would join everything back together, and you would know that all of your threading is done and you can continue back on a single thread. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to talk about thread pools. So what is a thread pool? Well, it's reusing existing threads because creating threads are expensive. And let me explain just a little bit here. So when you create a thread, it's very simple in Python, but what happens under the hood is a lot of calls to the operating system. The operating system has to allocate CPU, RAM, all this other great stuff that you need, and it gets very expensive in terms of, well, computing power. Now, think of this in terms of you have thousands, and I mean thousands of things you want to throw onto a thread. Your computer's not going to handle that many threads. Actually, most computer operating systems will cap the number of threads a program can run. So eventually your program will crash if you try to create too many threads. Don't worry, that number is absurdly large, more than you're probably going to use. So a thread pool looks something like this. You have a bunch of work producers, and these could be classes, these could be network sockets, keyboard input, any sort of work, anything that's going to be created. That becomes work that sits in a job queue. Think of this like a list or a tuple or a dictionary or something like that. And then you have a predetermined number of thread pool workers, or these are individual threads that sit in a pool. Think of a pool like a list of threads, very similar to what we did in the previous video. You are going to have a set number. The difference here is as these threads finish their work, they become available for more work. So you can then basically just create a factory where you're pushing work into this thread pool and work gets completed by whatever worker that's free, and the work stops and waits for a free worker. It's actually incredibly cool. Let's dive in and take a look. Okay, first thing we need to do is imports. I love importing things, so we're going to import logging because we're going to be, well, logging things. And we're going to import threading. We're going to import that entire module just to show that you can do it. It really doesn't have some severe impact on your program, even though it is kind of poor form to do it this way. And we can say from concurrent.futures import the thread pool executor. What in the heck is this? Okay, so we're saying from the concurrence module futures, we're going to import a thread pool executor. Concurrent, when you hear the word concurrency, really this is a high-level version of threading. It's a way of doing threading with hiding all the ugly thread details. Future basically means we're going to work with a value, but we don't know what that value is. We're going to get that value in the future, which is why it's called a future. And then we're going to import the thread pool executor. This is a very fancy term for saying, hey, Python, create a thread pool and execute some code. Now, I think, somebody correct me if I'm wrong, you have to have Python 3.2 or higher in order for this line to work. So if you start getting a unknown, can't find it, blah, 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 that's what's going on. You need a newer version of Python. And then we're going to go ahead and say import time, because we're going to stop time using the sleep function. Now, when I say stop time, we're stopping the current thread. Remember, these threads are going to run in a pool of threads. And we're going to, last but not least, import random, because we're working with the random number generator. Now that we've got all our imports in, we need to make a test function. This is the function that we're going to run on a thread. So we're going to say def test, and we want an item that we're going to be handing to this. From here, I want to get a number that we're going to pause this thread. And I want it to be random. So I'm going to say s equals random rand range, and we want between 1 and 10 seconds. And I'm going to say time.sleep for whatever that number is, effectively putting the current thread to sleep. Now, this is not abundantly helpful because it doesn't really tell us what's going on, so we're going to use logging. Now, we haven't configured logging yet. We're going to do that in the main function, so leap of faith, let's just assume that if we're running this function, logging has been configured. So info, let's go ahead and say thread, and now we want to know what item we're on, because each thread's going to be a different item. We want to know the ID of the thread, and this is not something we assign to it. It's something the operating system tells Python and Python tells us. So this is going to be different on every single app, every single platform, every single operating system, and even in specific versions. So do not get attached to this. It's not going to hang around long. So I'm going to say threading dot, we want to get underscore IDENT, short for identity. So we want to get the current thread's identity. So get ident, return a non-zero integer that uniquely identifies the current thread amongst other threads that exist simultaneously. This is basically how the operating system determines what the thread actually is. We also want kind of like a user-friendly way of doing it. So we're going to get the thread name. The name doesn't always exist, but because we're running this in a thread pool, it should be there. So I'm going to say current and underscore thread dot name. And in case you're wondering, yes, the current thread does actually hand you a thread object. So return the current thread object corresponding with the caller's thread of control. Oh man, that gets super confusing. But basically what you need to understand here is we're getting an ID that the operating system uses to determine what it is, and we're getting the name, which is basically a friendly version of the ID. I shouldn't say it's a friendly version of the ID because they're two totally different things. The name's not guaranteed to be there, but the ID pretty much is. All right, now let's go ahead and just grab this. And I want to say, probably should fix this, or we're going to have a bad time later on. There we go. Sleeping for, and then I want to know how many seconds we're actually going to sleep for. Then we're going to go ahead and put that to sleep. And then I want to know when we're actually finished here. So I'm going to say whatever the item is, and let's go ahead and say finished. So looking at our test function, it's abundantly obvious this does, well, nothing but just kicks out a bunch of logs and then goes to sleep and then lets us know when it's done sleeping. And that's fine. We're really just simulating activity, but now we're going to make this work in a pool. So let's go down and we're going to make a main function. Go ahead and fill this in. We've talked about all this before, so if this looks really confusing, I humbly suggest you just rewind the playlist, go back and watch previous videos, but we're basically saying if we're running in main, meaning if Python's running this directly, go ahead and run the main function. This function, we're going to go ahead and we're going to configure logging, and I'm going to, for the sake of time, just copy and paste the configuration because we've done this before. There's no sense in repeating it. So we're saying logging basic config, and we're going to have a format of level, time, message. We want to specify the logging format is hours, minutes, second, and we want to get the logging level of debug because we want to capture everything. From here, it becomes very, very simple. I want to say logging info, go ahead and start, and then I want to know when we're finished. So in here is where we need to actually do our threaded code. I'm going to say workers equals 5. And this is the number of actual worker threads we're going to do. Now we want items we want to work with. So I want to say 15 items. Notice how we have more items than we have workers. This is why a thread pool exists, because we want to work with these items in, well, chunks of 5 because we only have 5 workers. So we're reusing the workers. As each one of these becomes free, it'll grab another item and so on and so on. From here, we're going to say with, and we want the thread pool executor. We're going to set the maximum, and actually want the max workers. There we go. To our workers number. This tells it, hey, use a maximum number of threads, and we're setting that to 5 from our workers variable here. Now we're going to say as executor. There we go. I like that word, executor. So now that we have this, we need to work with the map function. I'm going to say executor.map, and we've covered map before. There's a reason why I covered it earlier. It's because we're basically mapping a function to a list of values. So we're going to say take our test function, and we just want to just simply say range items. We're going to let range actually build up that list for us. And that's really it. We don't have to do any fancy joining. We don't have to monitor the threads or anything like that. So really all we're doing is say thread pool, make a pool of threads, give me a variable that represents it, and then do something with it. Go ahead and run this and see this in action. Oh boy, this looks kind of crazy. So we're just going to give this a minute, let it run, and you can see at the very end, finished, and maybe. There we go. Application finished. So let's actually flesh this out a little bit better. Say app start and app finish. That way we know exactly what's going on here. Let's clear this and let's actually get some real estate here. Let's see what's going on under the hood in Threadland. You can see the app start. Now we have all these threads that are spinning up. You notice they only go in chunks of 5. Started at 0, went to 4, and now it's just kind of random numbers. There really is no guarantee on how these threads are going to be run. That's the operating system's job to figure that out. You can see we're getting thread IDs along with names, and they're named thread pool executor 0 underscore something. The naming convention is internal to the thread pool executor. Don't really rely on that. You can change the names if you want, but I would not recommend it. The IDs are given to us from the operating system. And then sure enough, you can see finished, and then finally all the threads from the thread pool executor are joined and the application itself finishes. Scrolling all the way up to the top, you can kind of see the order. The app started, then we have thread 0, thread 1, 2, 3, 4. Those are our 5 workers right there. And then something magical happens. That work gets put into a queue, and the thread pool executor waits until it has a free worker. In this case, it was thread 2 popped up and said, hey, I'm available. So the thread pool executor said, hey, thread 2, go perform this work. It's actually a very delicate dance, and it's highly efficient in terms of memory usage. So if you have a large body of work and you want to make it multi-threaded, do not create a thread for each item. Instead, use the thread pool executor. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian. We're going to continue our journey into Python. All right, so we're going to talk about a few different things with threading, and we're really leaving beginner land and just jumping headfirst into advanced territory here. So we want to avoid a few things. For example, the dreaded race condition and deadlocks. If you don't know what these are, a race condition is the same resource, notice I didn't say variable, the same resource modified by multiple threads, pretty much at the same time or close to it. We have to have something called locking, and that's what we're going to cover in this video. Now, the problem with locking is you can create another issue called a deadlock, which is multiple threads waiting on the same resource. So think of it this way. Think of your computer as a giant cookie jar. Now, the problem is the mouth of this cookie jar is only big enough for one person to reach in at a time. So if you have multiple people trying to reach in at the same time, either they're going to reach a deadlock, meaning neither of them can get in, or they're both going to magically get in, but then neither of them can pull their hand out. That is confusing. We're also going to touch on another subject, and I'm going to just copy and paste this giant text wall here. Bang! It's going to be out on GitHub in case you want to read this whole thing, but I will summarize. We're going to talk about the GIL, or the Global Interpreter Lock, and Python gets a lot of flack for threading because it handles threading differently than other languages. And to just dispel with some myths and rumors, yes, Python is truly multiple threaded. What I mean by that is when you create a thread, you can actually see on the operating system a thread is created. The problem is all of this bottlenecks into Python in the GIL. And what this is basically one thread, one CPU at any given time. It just does it blistering fast. So from our program's perspective, we can have multiple threads and they appear to be all working in unison. But really under the hood, CPython supports multiple threads within a single interpreter. Meaning so far we've been working with just one instance of Python, which means these threads all go through one GIL. There's one door they're all trying to run through at the same time. To kind of circumvent all that after reading all of this, you have to use something called multiprocessing, which is using multiple Python interpreters running in tandem. Highly advanced topic we're going to cover later, but I want you to understand, as we talk about threading, someone's going to say, oh, Python's not truly multi-threaded. Well, it is. It just has this global interpreter lock, and there are ways around it. You have to use multiprocessing, which is blistering fast, but uses more RAM. So let's dive in and let's take a look. First things first, we need our imports, and we're going to make a global here. So I'm going to, just for the sake of time, so you're not watching me type all this crap out, there we go. We're going to import logging, threading, and the concurrent features. We're going to import the thread pool executor. We've covered all these in previous videos, which is why I'm not taking the time to really dive into each one of these. We are going to stop the current thread, and we're going to use a random number generator. But additionally, we want to use a global variable. And that's why I wanted to slow way down at this point and say, this is where we're going to have problems. Counter equals 0. This looks very innocent, and we've done this before, but now we're talking about multiple threads. So take a moment and just really absorb what we're doing. We're making a global variable called counter. we're going to spin up multiple threads and increment this counter. What could possibly go wrong? Remember, what we're talking about is thread locking. A race condition is multiple threads accessing the same resource. What are we doing here? We're making a single resource that multiple threads are going to access. Let's take a look at how Python actually works with threads. Let's go ahead and set up our test function. This is what we're going to call the threads on. Or I should say, the function is going to be called on the thread. So I'm going to say def test, and we want some sort of count that we're going to increment our counter with. We're going to use that global variable, counter, and we're going to go ahead and get the thread name. And this is going to be the threading, and we've done this before, so I don't want to spend a whole ton of time on this. If you missed the videos, definitely go back and rewatch. There are 45 other videos in this series so far. I'm going to make a lot more, but we've talked about what the current thread is and how to get into it. Also, we're going to make a wild assumption that logging is actually set up at this point. We covered that in a previous video, where you have to configure logging before you work with it. We're doing it a little bit backwards here. We're going to start using it before it's really configured. We'll catch up with that in a moment. So we're going to say starting, and then whatever our thread name is. And we're going to mess around with this function a little bit over the next few segments, but I just want to flesh this out really quick so you get an idea of what we're going to be doing here. So we're going to say for x in range, very simple. And we're going to range on the count, which is the argument that we're given. And then we're just going to say logging, and I want to do count thread name plus equals, and we want the count, just so we can see what's actually going on here. We're going to play around with this, and I'm going to show you locking and unlocking and acquiring and releasing and all that, but I really just want to show that this is what's going on. So now once we're done, we just want to say completed, whatever our thread name actually is. So this is going to be our test function. Now, right in here is where we're going to do some work. I'll put a note, work here. Okay, now that we've got a test function, we're going to go ahead and do our main function. So, done all of this before, so I'm not going to spend a ton of time explaining what all this is. Highly recommend you go out and watch the other videos just so you understand what's going on in case you skipped any of them. So we're just going to make sure that Python knows if we're running as main to run the main function. And then inside the main function, I'm going to copy and paste some config code here. So we're going to configure our log using basic config, and we're going to say level sync time. Now, one little bit you should notice is instead of just string, I have dot and then the milliseconds, 3 decimal places. So I want to know the actual milliseconds, and we're going to log that. And then the rest of it's just the same thing we've been doing with the hours, minutes, seconds. It'll have the milliseconds behind it, and we're logging debug, so we're collecting everything. Now from here, I'm going to, the old copy and paste, my mouse wants to work. We're going to say app finished. And then in between, this is where we're going to actually kick off our thread pool executor, which we've talked about in the previous video. So I'm going to say workers equals, and we just want 2 threads that we're going to use in the pool with, and I want thread pool executor. Go ahead and set our max workers equals workers. That way we're telling the thread pool executor use only 2 workers as, and I'm just going to say as ex. And then for x in range, and I want to do the workers times 2. So basically I want to do more work than workers. That way we can actually see the thread pool in action, and it does, well, exactly what it's supposed to be doing. And missed a little, there we go. Now I want to get a value, and we're going to say just a random number. And I want a rand range. We've done this dozens and dozens of times. But basically we're making a random number between 1 and 5. Now I want ex.submit. And we haven't talked about this before. We've talked about map, which does the map function. Submit is a little bit different, similar syntax, but different. So we're saying a function and a parameter. So we're directly calling a function here. See? Some sort of callable function with arguments. So really, what we're doing is saying thread pool, submit to this function a value. And it's going to call this little guy right here. Beautiful how that works. I absolutely love that. It's so simple to use. It's just ridiculous. So this is to a function with an argument. And then from there, it's very, very simple. Let's go ahead and just run this just to see what happens. And you can see we have no errors, and it actually does kick up some threads in the thread pool. Okay, if you've been paying attention, so far we have a multi-threaded application that's doing, well, basically nothing. We're starting a thread pool, we're submitting to a function, and then this is being called up, but we have this work here, so we haven't actually done anything yet. That's going to change. We're going to look at the global interpreter lock, or the GIL. What is it and why does it exist? Think about what we're doing here. We're taking a global variable across multiple threads, and we're going to modify it. This is very, very bad. So I'm going to say counter plus equals. And let's go ahead and increment this by, what do I want to do here? Let's go ahead and just add 1 just to see it work. Now, if you've come from another programming language and you know threading, you know this is very, very bad. Because what have we just done here? Well, we've created a race condition. Because multiple threads are hitting this simultaneously. You can see down by our hours, minutes, seconds, milliseconds, this is firing off at the same millisecond. So race condition is notorious for crashing programs because what happens is the program doesn't know the value. Let's say the program's in the process of modifying this and another thread comes in and tries to modify it. What's the actual value? That's when the program gets confused and ultimately just crashes. Let's see it in action. No crash. Notice that. No crash at all. Application finished. So what's going on here is, well, you may have guessed, the global interpreter lock is coming in and saying, nope, only 1 thread at a time through the door. And we can even test this by getting that actual count, just to make sure this is an actual integer and nothing has exploded here. So let's just clear this out and run again. So we have a count of 7. Now you can play around, and this is admittedly a bit watered down or simplistic or almost silly example because we're doing basically no work, but I want to dumb it down so we understand the concept of the race condition and what we've just done. This is why the global interpreter lock exists. It makes threading in Python ridiculously simple. We don't even have to worry about locking this, even though we should. So we're going to cover locking in the next segment, but just understand what we've done here. Multiple threads at the same time are hitting this resource and modifying it. So far, we've been trusting Python to take care of all the murky details for us, but I'm not a trusting individual, so we're going to do this the right way. We're going to use what's called locking. And this is kind of intimidating, but we now control that resource. So I'm going to say lock equals threading dot lock. And when you see the word lock in context of threading, think of it literally like a lock on a door. We are now shutting that door and locking it so no other thread can go in and mess with it. But to do that, we have to actually acquire the key. Now, because we've acquired the key and locked the door, we have to unlock the door now before anything else can be done. So let's do this. We're going to say try finally. And we're going to literally just copy this code here. And then we're going to say lock release. And release is, well, literally unlocking the door so other threads can now go in and do it. Notice the structure here. Only the resources we're going to modify are between lock and release, or I should say acquire and release. because we want this window of opportunity to be very, very small. That's what's going to keep our applications nice and fast. Now, doing this is great and all, but there's another little issue. Let's go ahead and run this just to show you that it does actually work. Ta-da! Now, let's go ahead and we're going to actually create a deadlock. So let's say we accidentally did something like this. So this is a deadlock. What we're doing now is we're saying we are now waiting on resources. Because this is locked, the door's locked, we can't get in. But now someone else is saying, hey, try and open the door is locked. Oh, that is super frustrating. So what's going to happen here is, you notice how it just stops. So whenever you see a multi-threaded application just stop like this, how it's just sitting here forever and ever, and it's not going to crash, it's just going to sit here, you have just ran into a deadlock. So if you're ever sitting around at work and somebody says, hey, why is my thread stopping? It's a deadlock. That's really what's going on. Now, so far, all of this has been great and all, but it's also very ugly. So we're going to do something called locking simplified. And if you played around with this code a little bit, you'll notice that, well, Python takes care of a lot of the details for us, so we don't even have to worry about it. So let's go ahead and comment all this out. Just going to keep it here. That way, if anybody grabs the source code, they can see what I did. So locking simplified. We're going to stay away from this try finally, and we want to lock and immediately unlock. So I'm going to say lock equals threading.lock. And now I want to say with lock. And we could have said with threading.lock, but I'm just showing you that we have some sort of variable here. So with lock, and what's going to instantly happen is we're going to acquire that resource and then release the resource when it's no longer needed. This is incredibly cool. So I'm going to just grab this, and we're going to paste some code in there. So I'm going to say, let's change that to +1 times sleep 2. So each time we do this, we're going to sleep. I'm slowing this way down. So just to scroll up, I know we got a lot of comments here. Going to enter test. We're going to grab that counter. We're going to grab the thread name, do some logging, and then 4x in range count. We're going to go ahead and say, get a lock, lock and acquire, do something, go to sleep, and release. So I'm intentionally slowing this way down so you can see it in action. Save and run, and you can see it's going. It almost looks like it's locking it because we're putting all the threads to sleep. And eventually this will finish out. Ta-da! Everything's working as expected. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian, and we're going to continue our journey with Python. And we're talking about daemon threads. Now, what are these things? Are they demons? Are they possessed? What is a daemon? So basically, in terms of computing, this, when you see this word, daemon, it means it's something that runs and executes in the background, but is also controlled. We're going to quit a thread when the app quits. So if you've played around with threading and you kick off a thread and you quit the app, the thread's still going to run. And we're going to demonstrate that in this video, how it'll just run forever. We're going to show you how to get around that. Okay, we're going to speed run right through this little part here. What we're going to do is imports, and we're just going to do a little copy and paste action. Just because we've done these before, we're going to work with logging. We're going to configure logging in the main function. We're going to work with threading the entire module. And from threading, we're going to import thread and timer. That way I don't have to explicitly say threading.thread or threading.timer. And then import time. That way we can actually stop the current thread. Test functions, we're going to have two of them here. So I'm going to say def test. And then we're going to go ahead and let's make another one called def stop. And stop is going to just literally say logging dot info. We just want to let the user know we are exiting the application, and we're going to go ahead and say exit 0. So we're exiting as expected. We've talked about exit codes before, but basically we're telling Python we're done, shut everything down. Now inside of test, this is where we're going to say thread name. We want to get the actual name of the thread. Go ahead and get the name there. And we're going to say logging info, and we want to know what we're actually starting here. And we're just going to put the thread name in there. And then I can grab this little guy for the copy and paste fun stuff. We're not going to do anything kind of crazy here. All we're going to do is just simulate some sort of thread. So I'm going to say 4x in range. And we're going to say 60, just to simulate long activity here. And I want to logging. Let's go ahead and say counting. Actually, let's just say working. And then let's put this thread to sleep. We're just going to sleep for 1 second. So if you're doing the math here, we're actually sleeping for 60 seconds because we're going to sleep 1 second intervals times 60. From there, I want to know, hey, we are now done. And there you go. Super simple little test function, but let's look at the two different ways of running this. All right, we're actually almost done here. So we're going to do our main function, and I'm going to do a fair amount of copy and paste just to speed this up because we've done this multiple times here. And I'm going to just grab some stuff off the screen. Bear with me. All right, so we're saying if name main, then call the main function. If we're in main, then we're going to configure our logger, app start, and then main thread finish. Actually, let's say main thread start. Now we can look at the real differences here. So first thing I want to do is stop in 3 seconds. So to do that, we're going to grab a timer. And we're going to call our stop function. We covered timers in a previous video, but basically what we're doing here is we're saying, hey, go ahead and kick up a timer, and in 3 seconds, go ahead and call the function stop. See, timer 3 stop. So it's going to go up here and say, exiting the application, and it's going to exit. Go ahead and test that real quick. 1, 2, 3. And exiting the application. So that is working as expected. Now let's make a normal thread. So I'm going to say t equal thread, and we want the target to be our test function. And we want to say daemon equals false. Now, by default, this is false, but I'm just going to explicitly say false just so you can see. Let's go ahead and say t start. So this is kind of the default or the normal way. We are not going to run the daemon. Let's go ahead and clear this. I want you to be able to see this output and definitely watch. So a main thread finished, exiting the application, but look, our thread is still running. So our application thinks it's actually done, but this thread is just going to run forever and ever and ever. Oh boy, that's bad. So let's go ahead and kill that. And now we're going to grab this, and we're just going to flip it to true. It's just literally just how simple it is. So if you ever have a thread that's running and it goes past the application exit, you really just need to set daemon to true. Let's go ahead and demonstrate. Ta-da! So when we exit the application, it's going to go ahead and any thread that's running as a daemon is going to also exit as well. Really simple, really easy to use, and simple to wrap your head around. This is one of the easier concepts in threading. Now, why would you want to shut your thread down when the application closes? Well, because it's expected behavior of an application. To have a thread continue to run after an application has stopped is considered very bad and very harmful, and some people would actually consider it a security breach of some kind. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name's Brian, and we're going to continue our journey into Python. We're going to talk about queues and futures. Now, what is a queue and what is a future? This is a little confusing here, but really what we're talking about is getting a return value from a thread. So far, we've been doing threading, and it really hasn't returned anything back to us, and that's what this video is really going to focus on. So a queue is a lot like leaving a message, like leaving a voicemail or an email or something like that, where a future is actually saying, hey, we're going to synchronize the program execution. And there's a lot of science that happens in the background, but really they're two fundamentally different things. You can almost think of a queue like, well, a mailbox, and you're going to leave a message, where a future is going to just say, hey, we're going to synchronize the execution. Let's dive in and take a look. To begin, we're going to kind of combine two sections we usually do different all into one. We're going to do the main and the import. And we're just going to flesh these out because they're so simple and we've covered them before. There's no point in separating them out into separate sections. So I'm going to do the old copy and paste. We're going to have a whole ton of imports. We have covered all of these. We're going to be doing logging, threading. We're going to use the thread. I have that separate because I don't want to do threading.thread. I just want to be able to say thread, time, random, concurrent futures. We're going to import the thread pool executor. You, of course, need Python 3.2 or higher. And we have from queue, we're going to import queue. Now, our main function is, well, pretty simple, actually. This is kind of why I wanted to do it right now, just to get it out of the way. And we're going to go ahead and say main. Now, inside of our main, this is where we're going to do a bit of configuration. So I'm going to do the old copy and paste because we've already covered logging. We're going to do logging, basic config, and then we're going to have our level, time, milliseconds with a message, and then our format. We're also going to have the log level of debug. So pretty much that's it for our boilerplate code. We're going to actually start diving in and fleshing out the rest of this application. Okay, now is when we slow way down and you get to enjoy the soothing sounds of my voice while I try to type horribly, because lately I just haven't been able to type well. I don't know why. All right, so we're going to talk about the queue first. So think of a queue as passing a message back and forth. We're going to make two functions. We're going to say def. Let's call this queue queued. Boy, say that 5 times real fast. I'm just going to pass on that. Probably choose a better function name. And let me scroll down, get some screen real estate here. And then we're going to say def test, and we want to test the queue. And I'm just going to do pass on both just initially so we can start filling this in. We're going to say name, and we want a queue. So really what we're going to do here is we're going to call a thread in this function, and it's going to actually call this function on the thread. A little confusing why we have these split up, but basically this creates the thread. This is what runs on the thread. So let's go ahead and let's fill this guy in first, because this is going to be our code that's running on the thread. So I'm going to say thread name equals, and we want threading dot current, and we want the name. From there, we can say logging.info, and we've already set up logging in our main, so we don't have to worry about setting any of that up. And I'm going to say starting, and we just want to know the thread name. From there, a little bit of copy and paste action. Save just a millisecond of typing this out. We can know that we have finished. Now's where we do our actual work. What I want to do here is I want to say time sleep. We're just going to simulate like we're doing some sort of long activity. Say random, rand range. And if none of this makes any sense, you need to go back and watch the previous videos because we've covered all this ad nauseum to the point there's really no sense in covering it again, or this will be a much longer video. So now that we have all this, we've simulated that we're doing some sort of long operation on a thread because 1 to 5 seconds in computer time is just an eternity. What we're going to do now is put something into a queue. So I'm going to say ret, this is just going to be a value, hello, and then the name, and there's a bunch of different ways you can do this in Python. Just use whatever works for you. Your random number is, and this is basically all we're doing, is just creating some kind of random number generation. We're going to make a string representation of a random, rand range. I like that term, rand range. Sounds like something out of like The Shining, that movie. Boy, that scared me when I was a kid. Anyways, so rand range. Now that we've got this big long string, we want to return this, but we're not going to do a return. Instead, we're going to put it in a queue. So we're going to say queue, because that's our queue object that we're going to pass onto this function. And we're going to say put. And this may cause subtle issues. I actually don't use queue very often. This is kind of like the older way of doing it. But if you're working in multi-threaded applications, you'll have to make sure you lock and unlock if you really need to. But because we only really have one thread that's going to be doing this, I'm not going to really worry about it too much. Realistically, though, you should lock that up and make sure you're not going to cause any sort of issues. All right, now that we've got all that, let's show you how that we can get the value from the thread. So we're going to say queue equal, and wow, boy, like I said, I just cannot type. Queue equal, and we want our queue. We're going to create a new instance of a queue. P equal thread. Now in our thread, we want a target, and this is going to be that test queue function right up here. So we're just going to grab him. And then we're going to say args. I like that, args. Always cracks me up when I say that. Pre-COVID, when I was in an office setting, people used to look at me funny when they just hear me down the hall go, arg, I'm a pirate. But anyways, so now that we have this, we're going to say t.start. So we're just going to start that thread off. Then we're going to do a little bit of logging. We're just going to basically say, you know what? Do something on the main thread. We're just going to go about our normal lives. And then when we're ready, we're going to say, you know what? We want to join that thread to the main thread because we want to get the information back. And this is where if you're in a truly multi-threaded environment, you need to lock, acquire, and then release. But for demonstration purposes, we're just going to ignore that. We're going to say get. And I did read somewhere, I'm not an expert, but I did read somewhere that it does it automatically in queue, but don't trust me on that. Again, I think there's a better way, and we're going to show that when we talk about futures. So logging.info f dot, and we want returned, and we just want to see what value we got back. Let's just grab this function, go down here, and we're going to call the queued function. Now, I'm just going to say it before I run this. I do not like working with queue. I just don't. I don't like the way you have to put and get. You got to kind of track what you're doing. And then what do you do if you have multiple things? And then it gets into this whole thing where you're deep diving into the documentation, and it sucks. And I have misspelled something. Oh, actually, nope. There we go. There we go. So do something on the main thread, and then after a period of time, blam, Returned. Hello, Brian. Your random number is 43. That would have been super cool if that was 42. If you've ever read like Hitchhiker's Guide to the Galaxy, the answer is always 42. But anyways, we got 43. So that is a very simple way of working with threads and getting information you would put to a queue and then get from the queue. I personally don't like this. I think there's a better way, and it's called futures, which we're going to cover right now. Okay, futures. I love working with futures. It's just like, have you ever just made a complete mess of your house and you look at it and go, you know what, this is a problem for future me? That's exactly what a future is. You can just do something and then worry about it when you actually need to worry about it. It's so much cleaner than working with a queue. But we're going to grab this guy right here, do the old copy paste, and we're going to call this test future. I'm going to do a little bit of surgery on this, so bear with me here. So we don't need this queue because we're not passing a queue object back and forth. And that means we don't need this right here. So we can just say return like we would normally return. This is why I like futures, because you don't have to like super depend on some other class. And then everything's just going to work the way you'd expect it to. You could call this like a normal function. It would return a value. So now what we're going to do is actually work on a pool. And this is why I love futures. So we're going to say def pooled. I like Deadpool. Anybody watch that movie Deadpool? I like all of them. All right, so workers equal 20. So we're going to have 20 threads. We're going to do this 20 different times. We're going to get 20 different return values. This is insane. Comparing this to a queue, this is way, way better already. And we haven't even started. So we're going to say with, and you guessed it, thread pool executor. And we want the max workers equals workers, and then as ex, and then for x in range, not random, range. Thank you, keyboard. Workers. Maybe I need a new keyboard. It's December 2020, possibly one of the worst years ever, but hopefully maybe Santa Claus will bring me a keyboard this year. So we're going to say value equal random dot range. Oh, I said worker. Random range. Rand range. There we go. Boy, I'm just making all kinds of mistakes in this video. So we're going to get just a random number. Now we're going to call the executor submit. So let's go ahead and say future equals, and we could have called that like F or something like that, but ex.submit, and we want to send this to our callable, which in this case is our test future function. And we want to say the name. And because we've got 20 of these, we want to know which one we're doing here. So we're going to make a string representation of X. So there'll be Brian 0 through 19 because we're doing the X in range workers. Workers is 20. All right. Now what we're going to do is we're going to build up this list of return values. Here's the catch-22. Because we're working with threads, those values don't actually exist. This is why we need a future. We're saying that value will exist in the future, but it doesn't actually exist right now. When you think of futures, think of it as like a placeholder for something we're going to work with. So we're going to say ret append, and we're going to append that future. So basically what we're saying is Python, we're going to work with a value. We don't have the value yet, but this is my way of saying we're going to do something. All right, lots of stuff to talk about here. Let's grab this and just paste that in there. And from here, now what we're going to do is we're going to, in a sense, join all those threads back to our main thread in order with the results. And this is actually way simpler than it sounds. We're just going to say for r in our list of return values, logging.info. And let's go ahead and say returned. Wow, that would have been super cool if I had done that right the first time. Again, let's see if we can go for 3 here. There we go. Returned. And now we want the result. So really what happens under the hood here is you're going to say, we want all these futures, put the futures in the list, and then later on, after you've done something in your main thread, then you're going to say, okay, Python, all of those futures, we now want to work with those and we want to get the result. Under the hood, there's a lot that happens, but basically, this is Python's way of going back to that thread saying, hey, give me what you have. If you're not done, I'm going to wait on you until you are done. And this is essentially doing the same thing as calling join. All right, so from here, we can just grab this function name. Let's comment him out. And let's do it the future way. The way of the future. I don't know, I feel like I need like some big 1990s logo on the screen or something. Let's clear this out real quick. And we're going to have a lot of stuff, so let's just see here. All right, so you see all our threads are kicking off, and they're now running in the background. And then in order, we have Brian 0 through Brian 19, and then each one has a random number assigned to it. This is extremely cool. I love this. So when we're talking about futures and thread pools and things like that, for most other languages, this is tens of hours of conversations. I mean, we're sitting here talking for days about this just so you understand the technology and then how to work with it. But with Python, you can have this conversation in minutes. I mean, literally not even an hour. You can learn how to work with a thread pool and learn what futures are and how to work with them. Wow, this is powerful stuff. So the main takeaway here is there are multiple ways to do it. And there's even more ways than what this video has covered. But a queue, you can basically act like a mailbox where you can put messages and get messages. But if you do this, you should lock and acquire and unlock, release, blah, 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 or you're going to end up with some multi-threaded issues. I really haven't taken that into consideration in this video just for the sake of time and complexity. Honestly, I believe the best way, in my humble opinion, is to work with the thread pool executor and work with futures because it handles all of that complexity in the background for you. You don't have to worry about it. All you have to do is collect a list of future values that you want to work with in the future. Then, after you're done watching Netflix or video gaming or whatever you're doing, you can come back and say, hey, Python, now I want to get the result of each one of those futures. Very cool stuff. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian, and we're talking about an introduction to multiprocessing. And this is very different than threading. It's multiple processes running the same script. So far, every time I've clicked this little run button, we've run one process. See, ta-da, we've run it one time. What we're going to do is run the same script through multiple processes. Now, what are we talking about here? A process has its own memory space. When I say process, think program, has its own memory space and its own threads. Technically, the operating system owns the threads and lets the process borrow them, but processes typically don't swap threads back and forth. Let's take a look at an example here. So let's just say this is your computer. This is kind of a combination of CPU and RAM. We're going to go ahead and let's make a process. And I don't like that yellow for a process. Turn this to, say, like a green. And this is our process. Every time I hit that green arrow, we're making our own little program. Now, the thing is, as we're doing that, other processes are also out in the operating system, and they can be sucking up different amounts of CPU and RAM. Some can be big, some can be small. Like, for example, Chrome will just takes an ungodly amount of RAM. Or something like, a little text pad will take a very small amount, things like that. So what we're really talking about here is we have our process and we want to take the same script. Let's just see if I can type here. Yeah, here we go. Script.py. And we are now going to make a copy of that out in memory and run that. Let's put a little arrow here. So we're now making a copy and running it. And we can do this a lot of different times. We can have an entire pool of these things. It's just ridiculous. So let's go, whoops. Let's grab this, CV. So you can make a bunch of these and just have them all over in memory. And then you can have all of these pointing back to your master right here. And everything just works the way you think it would, and life goes on. The tricky bit, though, is understanding how this works under the hood and how Python actually handles all this. And because each process is an independent island in itself, and each process now has its own threads inside of it. Let me actually make like a little yellow thread pool here. So like this one would have its threads, and this one would have its threads, and so on and so forth. I mean, this is highly advanced computing. You go to do this in like some other language like C++, and you're talking about a 6-week course in theory before you write any code whatsoever. But Python, we can do this in minutes, as you're about to see. This is beyond powerful. This is ridiculous how much power you have at your fingertips. All right, normally I blast right through this next part, but we're going to talk about imports real quick, and I'm going to slow way down. So we're going to import logging, and we're going to introduce a subtle bug here, and I want to point that out right in the very beginning. The bug is going to be how we configure logging. We're also going to import multiprocessing. In case you're wondering why I'm intentionally making a bug, it's to prove a point on how multiprocessing is different than multi-threading. And then from multiprocessing, I'm just going to make my life a little bit easier. Some people don't like it when I do this. I'm going to say import process. That way I don't have to type multiprocessing dot process. I can just say process. And then, of course, we are going to simulate some activity. We're going to do more complex stuff in the future, but right now we just want to simulate like we're doing something. So I'm going to put the current thread to sleep. That's right, the current thread. So each process is going to have a main thread, and we're going to put that main thread to sleep. Later on, we may dive into multiple processes with multiple threads and see how all that interacts. But just understand why we have these imports. First thing we need to do, we need a starting function for our process. Think of this like the main function, but it's for each process we're going to spawn off. So I'm going to say run, and we don't have to call it run. You can call it whatever you want. You can give it any number of parameters you want to give it. It's really that simple. We're just making a function. I'm going to say name equals, and this is where people get really confused because the API is very similar to what we learned in threading. We're going to say process dot current process name. So each process now has its own name. So don't worry about naming your processes. It's all done automatically. You can definitely feel free to pass information back and forth as you need to. Here's the subtle bug that I was talking about earlier with logging. We're going to say logging.info. Right off the bat, what is the big problem here? Well, this is the starting function. We have not configured logging, but I don't want to reconfigure logging every single time. I'll show you how to get around that here in a little bit, but just understand that it has to be configured before it gets here.